because I'm not reading his profile just yet, but just to give a background, he did his PhD in Harvard, and I remember asking, why would you leave Harvard to come back to Africa? And there are people that you meet, and sometimes it's just one word that sticks with you. And I remember him saying that, well, in South Africa, he has the best laboratory, so why go to Harvard to study something that affects South Africans? And that has always stuck with me. And it's quite, the word escapes me, but it's quite, it's good that we meet here after all these years. And I still remember that you offered me a job when I finished my PhD, so I have that in my pocket. Where's Gordon? So if this doesn't work out, at least I know I have a backup plan.
Salary negotiations are coming around here.
Yeah. So I think, is Jesse Kwashi around? So I said we'll start at 9:05, right? So we have about 3 more minutes for that. I think so far, day 2 was my favorite day. I think I learned certain things about ACE2 that I didn't know before. And every day when you learn at least one thing new, that's a good day. I learned that Omicron gained the ability to infect mice, right? And which probably means that it's gained the ability to infect a lot of other species. So that's something. And I learned a little bit about how to use bat cells for cell culture and make organoids from bat lungs. And interestingly, I didn't know that I just happened to have done my postdoc in the lab where there was this very talented PhD student. And the time I joined, he had 4 papers already, and he wanted to have sort of a big story. So he looked through all the literature. He saw that fertilization is supposed to be linked to similar to viral fusion, because it was a virus fusion lab, in a way, viral entry lab. And he saw that, okay, there's been all this work. Somebody has done some work on Juno, somebody has done some work on Izumo, but nobody has actually proven the interaction. And so he set out to do a complex of Izumo-Juno. And from the day he proposed to the project to the day it was published in Science, it was 1 year. He was that hardworking, and it was back-to-back with the Japanese group that Andy Pauly mentioned. They had been working on it for years. So I just wanted to mention this because this is somebody who read the literature, saw the gap, and was motivated. He didn't have to do it. He was motivated to really make an impact. And now Jeff Lee's lab works on egg-sperm fusion. Halil, that's the student's name. He's long gone. So he was one of the papers that was cited there. But now he opened up a whole new avenue for his PI. And they also published the SMAC, I say SCA 9 or whatever, there. So it's just something for the students in the room, that sometimes you don't have to just rely on your PI to come up with all the ideas. Reading to understand, and reading to look for gaps, right? Because what we do is we're trying to create knowledge. So if we're just recreating or replicating knowledge, that's not really creating knowledge. All right. I think that was my takeaways from day 2. And of course, we had a very vibrant panel discussion, which told us that really to get from your research findings to policy, or to whatever output you want to have, you have to start off thinking about the end results right from inception, and think about the stakeholders, think about who's going to benefit and who you need to be involved. So that's, so without much ado, I hope they are here. It didn't rain that much this morning, so we won't use rain as a thing. Is Luther, well, let me call the chairs. Dr. Gloria Megache. And there's been a change to the other chair. Is going to be Dr. Emmanuel Tego. You would think I planned this, because both of them are our MedLab Kolebu campus. So that's our WACCBIP in Kolebu, and they are chairing in the same session. So I'll hand over to them to start the session for the day.
So good morning, everyone. We have our first speaker in the person of Luther Jesse Kwashi, who is talking on the revolution of turning waste into feed, fertilizer, and cash. Jesse, the floor is yours. Jesse? Is it online or in person?
Thank you. All right, I think I'll start with a story. So sometime in 2018, 2019, a group of 4 young men had a meeting in the level 300 lab. And we had dreams of transforming the agric space. We're contemplating on our future, and we decided that we're going to attack the agricultural space, because everyone eats. And from some of our lectures, we found out that food security is becoming a challenge. And so we had a meeting, and we drew a plan. And a few months down the line, we put together our resources and started a pig farm. Unfortunately, it collapsed. This was because of our inability to afford feed, as the price of feed was perpetually rising. This is not an uncommon situation in the Ghanaian agricultural space now. As at 2022, over 250 pig farms had shut down in the Ashanti region alone. Talk of poultry, many poultry farmers are lamenting for this. And for the fish industry, the Ghanaian farmer reports that as at 2022, late 2022 alone, over 90% of the registered fish farmers across the Volta Lake had to shut down, and this is as a result of feed alone. Before that, I would like to introduce the team. I am Luther. I did my undergrad here at the biochemistry department right here. Then I continued to do my service with the WACCBIP Deltas program at the TMG lab. Then I continued to WACCI to continue my MPhil program there. Right afterwards, right in between that process, we started a pig farm that eventually shut down. That's my colleague there, Emmanuel. Emmanuel is currently our Chief Operations Officer for Productions. Emmanuel also started right from here, from 2014 to 2018. And then he furthered on to also do his national service right here at the Musi Lab. And then furthered on also to WACCI to do a program in plant breeding and genetics. And subsequently, we continued the journey in starting AgriMechab. The animal feed industry is on the brink. Okay, thank you. My slides are in. All right. So now, the animal feed industry in Ghana is on the brink of collapse. But then this insect right here is the answer to that challenge. So that is me, and that is Emmanuel. All right. So the problem, high feed cost has threatened the sustainability of the animal feed industry. And this is very challenging. Imagine when you purchased or when you bought just one egg for 50 pesos, 1 cedi. Currently, how do you spend on an egg? Crazy, right? That is what is happening in the industry. The cost of feed is rising perpetually. As a result, it's affecting everything in Ghana. It will get to a point that the average Ghanaian may not be able to afford protein. What happens? What is the health implication if the average Ghanaian cannot afford protein? Terrible, isn't it? And that is why we exist. So we leverage on the technology of the black soldier fly larvae. We leverage on the technology of the black soldier fly larvae to transform organic waste into feed and fertilizer. How does this work? We obtain organic waste from various sources, and then we aggregate it, and then we take it through a process of fermentation using baker's yeast. At the same time, we have a breeding facility where we breed the insect and obtain the eggs. We allow the eggs to hatch into 5-day-olds, and then add the eggs to the waste. Now, the reason why we ferment the waste is basic biochemistry we are applying. That by virtue of basic fermentation, we're able to control a number of microorganisms that might be present, and also make the nutrition in this waste easily accessible for the larvae to feed on. And then after a period of 14 days, we harvest them. And then we take it through a process of sanitizing by parboiling them and then drying them using a dehydrator. After that, we extract the oil and produce insect meal out of it. What value does this offer? The larvae is high in protein content. It can easily be digested by all the animals and even pets, as it's largely being adapted into the pet industry. It has a balanced nutritional profile with fats, vitamins, and some minerals. In fact, there are the presence of some bioactive compounds that has been known to see its ability to improve immunity in fishes, in poultry, and in pigs. And lastly, it is sustainable and environmentally friendly, as it has the ability to transform organic waste into feed and fertilizer. Now note this. The challenge in the Ghanaian nutritional space is that we depend largely on two sources for our animal feed industry, especially the protein sources. That is fish meal and soybean. What is the challenge associated with this? Imagine growing fishes just to feed it back to fishes. It doesn't make sense, right? But that is what is happening. Imagine still growing fishes, the same fish we depend on just to feed back to animals. That's a challenge, right? Yeah. And so there's been a lot of pressure on our marine resources. In fact, many of you might recognize that as at last year and earlier this year, the Minister of Fisheries and Aquaculture locked down the sea. The reason is because of the high dependence on our marine sources, leading to depletion of our marine sources. Also, on soybean, a lot of it is being imported. And this is crazy because import logistics and the fluctuations in our currency has ensured that this becomes very expensive. How are the farmers coping? With our solution, we are able to provide a crude protein content of 48%. It has a complete amino acid profile. Its amino acid profile is similar to that of fish meal. In fact, when you taste it, it tastes just like shrimp or fish meal. Yeah. It has 0 anti-nutritional factors. This is because plant protein have a lot of anti-nutritional factors in them, as well as it is very sustainable, as you are not depleting the marine sources or depleting other resources to be able to produce it. Now remember, you're able to produce it over a period of 14 days. However, how long does it take to grow soybean? How long does it take to grow fish into maturity? And this is our solution. But then we hit a roadblock, and this is where it gets crazy. We are producing the larvae, but at a very pilot stage. And then we had people just chancing on us and decided that, oh, they want this solution because they've been looking for this solution for a very long time. And so we had a number of farmers calling in for us to support them. However, our ability to supply was very limited. What then did we decide to do? We decided to decentralize our operations. And this is how it helped us. This is how it helped us. Instead of producing for all the farmers that needed our product or that needed the black soldier fly larvae meal, we decided that we were going to help train them to be able to set up their own production processes, to be able to produce the larvae on a small scale for themselves. Someone may ask me, if we do that, aren't we selling our technology off? I'm sure there's a question on your mind. How then will we make money if we do that? Now remember, I mentioned that the larvae produces, or the conversion of the larvae, you get 2 products, the larvae meal and organic fertilizer. But who are our target market? Fish farmers, poultry farmers, pig farmers. They have no need of organic fertilizer, yet they are producing 3.5 times more organic fertilizer than they are producing larvae meal. What do? We come in to offer them some value for the organic fertilizer and then sell and then make our profits from there. Therefore, we have a number of product lines that we offer to the farmers. We offer starter kits. That is the kits that the farmers require to be able to produce the larvae for themselves. So once we were able to, so what we did in our production processes was that we leveraged on local technology and then some local equipment to be able to make our starter kits. So we didn't import what we needed. And so what we decided to do was to replicate this in mass quantities and then sell to the farmers. So we have a very solid product line where we sell the starter kits. We're also setting up a breeding facility because imagine farmers needing to set up to produce their own. They are going to need seed units to be able to set up or start up their operations. Therefore, we trade in seed units as well. But there's another catch, because inbreeding depression will set in at a time. And therefore, we decided to have, Ima is a plant breeder, and so Ima and Lydia. And so we are leveraging on our breeding skills as well as our breeding knowledge to be able to breed new and superior breeds for the industry. Also, we obtain a lot from our fertilizer as well as our product, protein meal. On the services bit, we obtain revenue from consultation, from facility setup and design, from training, and from mentoring. Currently, we obtain revenue through this means. So far, we are on our way to making 100,000 Ghana cedis in our first year, 100,000 Ghana cedi. So far, we have been able to deploy shock-resistant systems, a consistent growth in turnover matrices. We have been able to ensure consistency in the quality of our processes. On the other bits, we are currently working on operationalizing our second facility in September. We have 6 full-time staff and 4 interns, and we have about 5 people requesting to intern with us over the next vacation. So far, we've been able to raise over $50,000 in equity-free funding and establish multi-strategic partnerships, especially with the Ministry of Food and Agriculture, the Chamber of Aquaculture Ghana, Latman Farms, and research institutions. Thank you.
Thank you very much, Luther, for such brilliant talk. We now open the floor for questions and suggestions. Any question for him? Right, we have one there.
Hi, very interesting talk. I have a couple of questions in regards to your business model. So you said that you share the technology with the farmers, but then presumably you're able to then collect the fertilizer. Did I get you right? That they need it for feeding their fish, but the byproducts you can then collect. What stops them from beginning to sell? Like, what is the advantage to them to continue to supply you with that? And then secondly, how are you thinking about scaling? 100,000 cedis is nice. Is it cedis or dollars?
Cedis.
Okay. So you've raised $50,000 in support, but 100,000 cedis is nice, but you really need to think about scale. So what are your ideas about how you can scale up your business? Yeah.
All right. So the main challenge with trading the organic fertilizer has to do with 2 things. Depending on how you operationalize your system, you are most likely going to get organic fertilizer that is not yet ready. We have been able to ensure that our system is able to do that. So what most likely our farmers are going to be produced is organic fertilizer that's not yet ready, which will take about 6 months to compost. But we have a system that we're able to do that in a week. And so if they attempt to do that, they are going to have now have a lot of storage systems and now determine other markets for that. Also, they depend on us for consultancy and for production processes. And so it becomes a very good foundation for them to do that with us. And so for a number of them are positive with that. On the scaling bit, we want to leverage on the organic fertilizer as our product of skill. The reason is because our target is to be able to train over 100,000 farmers in Ghana. We have been able to establish sales points for our organic fertilizer already. And so we intend that once we're able to help these farmers set up their larvae production, they're able to reduce their feed costs, they are happy. We're able to obtain the organic fertilizer, sell, we make our money, we are happy. There's also another model that is popped up. There are a number of customers that are reaching out that they don't want to go through the headache of producing themselves. They want to provide for you the facility for you to do the production for them. The arrangement with such ones like this is that what we do is that we tell them that, okay, we are going to assign to you a technician who is going to produce the larvae for you. And then we are going to take up all the organic fertilizer, use it as maintenance cost, and to also help and to pay the staff on site.
So have you also thought about perhaps diversifying the products? I'm asking this because there's a number of companies, especially in Kenya, who are doing something quite similar. I can introduce you to some of them if you'd like, but one of them, which is doing really well, is producing lots of products from these larvae. So it's not just fertilizer. You can produce oils, you can produce fuels like bricks for cooking. So it's more sustainable than charcoal or firewood. So I'm wondering whether you might want to think, as you scale, to diversify your product base. Because at some point, if everything is fertilizer, it's possible people will start, they can start making the fertilizer easier than they can maybe refine oils. And I think this guy was talking about the oils could be potentially for cosmetics and a lot of things to replace palm oil, which is not very environmentally sustainable. So that's just a thought, to think about diversifying your product base as you scale. Thanks.
All right, thank you. You note that down.
Hi. I don't know if you touched on it, but of all the millions, thousands of species of insects, why this particular one?
Okay.
And to follow up on the diversifying bit, is it possible? I just going to focus on this particular species, or are there chances of including other flies that could,
All right. So the advantage of this species is that it doesn't have mouth parts, and so it's not known to transmit diseases in its adult phase. Comparing that to houseflies or to other insects, you are likely to have a lot of issues with regards to health and invasions. Another thing about it is how quickly it's able to transform the organic waste, and its wide range of organic waste is able to transform. So, for example, akokono has only one substrate that it depends on. So you try to replace the substrate for akokono and you're not able to do that. But these guys have a lot of digestive enzymes, and so they're able to transform a wide range of organic waste. And paralleling it with mealworm as well, mealworm takes about 6 months to be able to transform waste into protein meal. So it's a very, very suitable alternative because of its ability to transform waste very quickly.
Any other comments, questions? Just one more before our keynote speaker comes in. All right, so if you have any question, can you write them down? After the keynote speaker is done, then we could just throw questions at you.
Thank you.
Right, so if we can please give you a round of applause. Thank you so much for such great talk. Right, so we'll have our keynote speaker who is going to deliver his talk online in the person of Professor Kelly Chimbali, who is going to talk on the fostering of health, innovation, and scientific entrepreneurship in Africa, the H3D story. So we're just going to have him online. Before
Good
that,
morning.
Morning.
I'm going to introduce the keynote speaker.
Yes, please.
Is he online? I have it. Is he online? Is he online?
Not yet.
Not yet.
I said he will be online at exactly 10:30.
Okay. Yeah. It's fine. So, who are the PhD students who were getting drunk yesterday? Can you show by hand? Can you show by hand so we check your alcohol level? See whether you are in good shape to be here. Okay. Somewhere. Okay. So it's my pleasure to introduce our keynote speaker for today, Professor Kelly Chimbali. So Kelly is from Zambia, and I'm mentioning that because the first time I met him, he told me about the misery he went through whenever Ghana beat Zambia in the football match, especially at the African Cup of Nations. So I wanted to remind him of the shock and awe that Ghana can put on Zambians before he starts speaking. So I wanted to mention that. But anyway, Kelly is one of the most distinguished African scientists of our time. He has led extremely innovative work in drug discovery, not only doing the science, but in the process, building capacity and mobilizing a lot of young people and training a lot of young people and mentoring them to believe that Africa can do quality science and solve our own health problems. So he is a full professor of organic chemistry at the University of Cape Town, where he holds the Neville Isdell Chair in African-centric drug discovery and development. He's a full member of the UCT Institute of Infectious Diseases and Molecular Medicine, and the founding director of South African Medical Research Council Drug Discovery and Development Research Unit at UCT. His baby is the UCT Holistic Drug Discovery and Development Center, H3D, which is a Johnson & Johnson Center for Global Health Discovery. His educational background, he did his PhD in synthetic organic chemistry from the University of Cambridge in the UK. Then he did some postdocs at the University of Liverpool, the Scripps Research Institute, and then he also did a sabbatical at the University of California, San Francisco. He also did a visiting professorship at Pfizer in the UK. Kelly has received numerous honors and awards, and a few are mentioned here, but I think if you check him out online, you'll see that almost every week he gets an award. I'm sure as we speak, he's lining up to go for an award somewhere. But these include the South African Medical Research Council Gold Medal, Cheney Visiting Fellowship from the University of Leeds in the UK, South African Chemical Institute Gold Medal. He was named one of Fortune magazine's world's 50 greatest leaders. 50 greatest leaders, so not just African, globally. He was one of 22 black biotech leaders who were named in honor of the Juneteenth in the USA. Then he has also professionally been associate editor for the American Chemical Society Journal, and then he became the first editor-in-chief from Africa of an ACS publication. As you would hear today, his research interests are in infectious disease drug discovery and development, and he, like I mentioned, is passionate about capacity building. Despite all his awards, his life remains unfulfilled because of one thing, which is that he hasn't met his idol, who is the only professor of boxing, Professor Azuma Nelson. So I have promised that I will eventually, if he's a good boy, I'll set up a meeting with Professor Azuma Nelson so that he can make his life whole. So my brother Kelly, if you are there, take it away.
Gordon, thank you so much. Can I just double check that I can be heard loud and clear?
Yes, we can hear you.
Yeah, I can be heard, right?
We can hear
Someone-
you. Sorry.
Fantastic. Thank you very much. Gordon, thank you very much for that very, very kind introduction. And actually, before I even respond to your remarks, which is very tempting, I want to really just congratulate you for your exceptional leadership of the West African Center for Cell Biology of Infectious Pathogens. I think it's remarkable progress that you have made under your leadership, and of course, inspiring all of us and really cheering from the background, and I'm one of your great fans. So thank you so much for all you've done to inspire the next generation. It's very tempting because this can be the lecture itself. I can start talking about Professor Azuma Nelson, which, by the way, is not just the only professor of boxing. He's the only professor in Ghana. I'm sorry. Ghana only has one professor, and that's Professor Azuma Nelson. That's a fact. Secondly, to make you feel better before I spoil the fun, the best goal ever scored in the English Premier League was by Tony Eboa, playing for Leeds United. I'm sure you can be proud of that. But finally, because I was provoked by Gordon to respond to this, to remind everybody, Zambia were the 2012 Africa Nations Cup champions. Let's leave it at that. The rest is history. But really delighted to be here, and thank you, Gordon, for inviting me. And I think I really owe it to Professor Azuma to come over there in person, but I need to see the invitation from him directly, because I'm not sure Gordon can really invite me to meet the professor himself. But in the next 20 minutes or so, I would like to just share with you, I think, something that we've been doing, really not just around health innovation, but also entrepreneurship. I think this is something that if I was asked to change the syllabus, whether it's chemistry syllabus or biology syllabus, et cetera, is that I would really want to introduce entrepreneurship in science. And I think that I will illustrate this with some project examples. But entrepreneurship is really, really important in not just in the science that we do, but also in using science for development of our continent to create jobs, build critical infrastructure. In a way, Gordon has demonstrated entrepreneurship through the West African Center for Cell Biology of Infectious Pathogens. That is entrepreneurship because it's created a platform that didn't exist before, but also has created opportunities for young Ghanaian talent to stay in Ghana because there's something for them to do. So the story I'm going to share with you today is about H3D in our Drug Discovery Center. This was founded in 2010. Of course, 2010, as you know, is a significant year because that's a year when we hosted the Soccer World Cup in South Africa. But really, since the founding of H3D in 2010, we have been on a mission the last 13 years or so, on a mission to conduct infectious disease drug discovery. Secondly, on a mission to develop Africa-specific models for improving treatment outcomes. And I'll come back to this on the next slide, just to say a bit more about what we're doing in this area. We've also been on a mission to develop drug discovery platform technologies that we are deploying. And I'll come back to this and give you an example of what we're doing to develop platforms here. And of course, very critical to what we do, and of course, in a similar way to what your center, Gordon and colleagues, what you do is really training our people, our young people, in the kind of things that we would like them to see do better than we did them into the future. But of course, on this slide, you can be proud of this man here. This is Godwin Ziwonu, of course, he's Ghanaian. He's part of the team over here. All right, so that is a bit of H3D in terms of the history and what we've done so far. But before I get to the question of developing Africa-specific tools and why it's important to do drug discovery in Africa, let me just share with you what are the main drivers to establishing H3D. Why was H3D established? So what I'm capturing here are some of the drivers to establishing H3D. Firstly, when I moved to Cape Town almost 27 years ago from San Diego, clearly that exposure and experience that I had over there, both in the US and the UK, I recognized the two extremes that we have on our continent, and South Africa is no exception. Is on the one extreme, we have good clinical research and clinicians doing world-class clinical research. The other extreme is that we have good academic institutions doing excellent basic science research. But what lacked was the translational aspects of the basic sciences to bridge the gap between the lab in basic science and the patient in the clinic. So this was really the lack of drug discovery culture, which of course you see drug discovery is really a team-based science. It's about integrating multiple disciplines and the various scientists representing those disciplines working together. So that was one driver. The second driver, this is something that happened when I took a sabbatical. As you heard from Gordon's introduction, I went to Pfizer on sabbatical, and I really got a sense that pharma companies were potentially willing to engage, if we could develop the critical infrastructure to the right standards that would require them to then be able to do what we do together. So pharma industry potentially willing to engage, and the challenge for us was how do we build the critical infrastructure, and the technologies and the talent that will make it attractive for pharma companies to try and work with us. The third driver was, of course, we have this important resource in Africa of natural products. And the thinking then was, how could we develop platforms that will allow us to harness the power of natural products, to integrate this important resource in modern drug discovery paradigms. That was a big driver that required us to think about the kinds of platforms and technologies that we needed to do that. A fourth driver was at institutional level, at the University of Cape Town. And I'm really grateful to the leadership of the University of Cape Town, who were at that time, I'm talking about probably the period between 2005 to 2007, thinking about these signature themes which could facilitate or foster interdisciplinary research across departments, but also across faculties. And there was a signature theme in drug discovery that brought together scientists from the Faculty of Science, scientists and clinicians from the Faculty of Health Sciences at medical school, and some scientists from the Department of Chemical Engineering. That was an important driver to really doing what we did in H3D eventually. And then, of course, we got, as Gordon and the team have done impressively in Ghana, attract a number of capacity building grants to help us with the kind of things that we need to do to set up the foundation for setting up H3D. And of course, government was absolutely critical in establishing H3D. One was the Department of Science and Technology biotechnology strategy as applied to health was an important driver of this, which then culminated in the establishment of a national chair in drug discovery, which was really created for the recipient of this chair to drive the training of the next generation of African scientists in drug discovery. And I was very blessed and very privileged to be awarded this chair, which just came to an end last year after 15 years of holding it. Really instrumental in allowing me to ask myself the question, how can I provide leadership in drug discovery when I have never done drug discovery? And that is the reason that I went to Pfizer to take a sabbatical and learn from the experts in the field. Finally, but not least, there was an opportunity to do a project with the Medicines for Malaria Venture. And in discussions with Tim Wells, the Chief Scientific Officer of MMV, is what could MMV provide and what could MMV not provide? And what can we get from elsewhere to leverage the funding that came from MMV? And so this grant was really about a project in malaria. And all MMV could do, of course, was fund the project and find the people. But we needed the infrastructure and the equipment and other things to leverage this funding. And that is exactly what happened. So Remember what I said earlier. It's the extreme, the chasm between the patient on one hand and the lab on the other. So the questions we have to think about, how do we build the critical infrastructure? Secondly, the critical enabling technology platforms. And thirdly, a critical mass of talent. Infrastructure, technology platforms, and talent. This leads me to, before I talk about how we did this, to remind us why it is important to do drug discovery in our context, in Africa. There are many reasons for doing this. One could be a business case, but let me focus on the health issue. So I'll give you just 2 reasons for me that are really important. First of all, there is no question that there's a direct correlation between the genetics of a population or the patient, the social and physical environment in which those patients live, and treatment of disease. Therefore, it's a no-brainer that doing drug discovery in close proximity to where the patients are is really important to understand the social and physical environment and the kinds of solutions that we need to provide unless we understand what is on the ground and, of course, factor in the genetics of the population. And the second factor around genetics is because of the very low volume of clinical trials performed on our
Recording in
continent.
progress.
Because of the low volume of clinical trials, medicines have not historically been optimized for our population. And the variability that we see in the way patients respond to therapeutics is really one of the major contributing factors, are the genetic differences in the expression and activity of the so-called drug metabolizing enzymes. And for the African patient population, these are not well accounted for in modern drug discovery tools. And we recently put out a comment in Nature Reviews Drug Discovery, which you can read up, really arguing for why we need to include African data, not just in drug discovery, but also in drug development, in clinical trials. And that really is the argument for why we have to do this. But let me switch back to how we went about thinking about how do we set up the infrastructure to do this drug discovery project with MMV? How do we set up the technology platforms? And how do we build the talent? This was the picture in 2019, when a year before H3D was founded. So the only thing that we had at the University of Cape Town was chemistry. We had some chemistry labs, very good labs, but we didn't have the other disciplines that you need to do drug discovery. So early stage drug discovery requires the integration of chemistry in the broad sense with biology in the broad sense and pharmacology in the broad sense, including drug metabolism and pharmacokinetics, DMPK. Understanding early on what the human body is likely to do to the drug if it makes it all the way. So this is a picture. So the only thing we did was chemistry. The biology and the pharmacology, and the drug metabolism were outsourced through the MMV network. But that did not stop us from doing the project. But the idea from the get-go was to be able to replicate all of these platforms in Cape Town. So we have an integrated platform within the same institution. And that, of course, became reality back in 2012. But today, this is a picture of the platforms that we have. We have the chemistry platform, so we have synthetic chemistry, we have medicinal chemistry, we have computational chemistry, computer-aided drug design, and we recently brought on board artificial intelligence and machine learning to build models using our data that we've accumulated over the last number of years. And we have a paper coming out on this area pretty soon. Biology, again, reflecting therapeutic areas of focus. We have malaria biology, including humanized mouse model of malaria infection. We have TB biology, again, reflecting area of interest in TB. And we have antimicrobial resistance, screening, and biology tools that we're developing there. And underpinning all of this is also an enzymology platform to do the cloning, expression, purification of targets of interest, and then setting up biochemical assays to drive target-based drug discovery programs. And then at the bottom here is pharmacology, drug metabolism, and pharmacokinetics platform, a suite of in vitro assays ranging from physical chemical assays to metabolism assays, all the way through to rodent pharmacokinetics to allow us to design efficacy experiments with the right understanding of the exposure levels of the compounds before we do an efficacy study in an animal model. And then, of course, I already spoke about the African drug metabolism, but that's a project that's ongoing separately. Underpinning all of this, as you'll see on the next slide, is multiple programs. You need a system to store your data and manage your samples when you're doing things on this kind of scale. So this is an integrated platform. Chemistry, biology, pharmacology, working together, and scientists representing these disciplines, moving projects from the lab to the patient. All right, this is a significant development, and Gordon referred to this in the introduction. This really is arguably, I think, one of the significant developments in the history of our center. When last year we became a Johnson & Johnson Center for Global Health Discovery, with a focus on precision antibiotics, the discovery of precision antibiotics, single pathogens responsible for marked drug resistance, and hospital and community infections and deaths that we focused on here. But this is a partnership. What is a partnership? You bring something to the table. What is J&J bringing to the table? J&J is bringing scientific and translational expertise. This is the largest healthcare company with, of course, tremendous experience in pharmaceutical research. So that is being brought to this partnership, but also funding to work on the projects. What do we bring to the table as H3D? As I finished just describing, we bring talent to the program. We bring the infrastructure that we've developed, which I just mentioned on the previous slide. And we bring a very powerful research ecosystem, which of course was attractive to J&J. And remember, when I described the drivers to H3D, one of the second point I mentioned there was that pharma companies were potentially willing to engage if we could develop the right infrastructure to the right standard. And this is an example of that, and of course, other collaborations that we have with pharma companies. To put this in perspective, the company has only set up 3 of these centers, one in London, second one in Cape Town, the third one in Singapore. All right, I was talking about entrepreneurship, scientific entrepreneurship, creating jobs, using science for development, creating jobs, creating an absorptive capacity to attract talent, to develop it, to nurture it, and to retain it on the continent. And I think this is just exactly what Gordon and the team have done in Ghana very well and very impressively. This is an example of what we have done. Okay, I have 2 appointments. One, I have an academic group where I train PhD students and postdoc, and the other is to lead H3D. So this picture here is just H3D, not students. So you can see when we began, the center was really approved in 2010, at the end of 2010, but the programs really just got started in April of 2011. So we had 6 people in 2011. We have about 75 people as I speak to you today, across chemistry, biology, pharmacology, and support staff in finance and business development and project management. Again, showing in a small way that we can create jobs, we can retain talent, if we build the infrastructure and the technologies, we can attract partnerships. So this is the message here, is that we've grown substantially over the years. All right, what have we done? And this is something that we published in Nature Medicine last year. It will just give you a sense of what we've done and the kinds of programs that we've actually engaged in to show the success that we have, or lack of it, depends on how you interpret success. We've done, in the period from 2011 to June last year, I would say to the end of 2021, because this was the publication in June of last year. We've worked on 64 programs where we, after doing the screening, whether it's high throughput screening, phenotypically on, let's say, malaria parasite or TB bacteria, or screening on a protein target, then deciding on which chemical series that you identify to be promising and move it forward and decide whether you want to really invest resources is what we call formal hit assessment. So a hit is just that initial result you get. So we've got 64 programs or chemical series that have undergone formal hit assessments. And then you can see from 64, only about 30 made it to the so-called hit to lead. So a hit is a molecule that gives you a positive result in your screen. This could be an enzyme assay, or it could be a phenotypic assay. A lead, on the other hand, is a molecule that you have shown a pharmacology proof of concept that gives you confidence that if you carry on and address whatever liabilities you identify, you can potentially identify a clinical candidate. And then that came down to about 9, where you do optimization based on the issues that you identify here in hit to lead. And that came to about 9. And then 5 programs matured to what we call the selection phase, which I think is best captured on the next slide, which is really, at the end of the day, when you say you do drug discovery, they will judge you on what you have delivered to the clinic. So successful drug discovery really stops when I say stops, not literally stops, but it's about identifying preclinical candidates that if they really go through the preclinical development, potentially could become clinical candidates. So we've got 2 that we've developed as preclinical candidates, and 1 that progressed and went as far as phase 2 human trials. So therefore, we've got experience of taking a project from the lab to the clinic. And that's, of course, is always a process. You don't stop when you've got something that's going to the clinic, because drug discovery, the attrition rate is very high. A project can fail at any stage of the process, and the project can fail in clinical development at any stage, whether it's phase 1, phase 2. So you need a pipeline. You need to feed the beast. You need a pipeline of molecules all the way through different projects, multiple projects under different therapeutic areas, feeding the pipeline, feeding the beast. And of course, what you want to do is drive programs to the right. So here, then things begin to get exciting. So when you get to lead optimization, then there's a reasonable chance that you could deliver a preclinical candidate. But this is a picture today showing a huge pipeline of things that are exploratory that will enter formal hit assessment, and then hit to lead, and then lead optimization in the way that I described on the previous slide. The message on this slide is very simple. You have to keep feeding the beast. Feed the pipeline, because it never stops. All right, I'll finish off in the next couple of slides. And I'm mindful I didn't start quite on time, but I've got another 5 or 10 minutes to answer questions. But I want to finish off with just 2 more slides, just telling you what we are doing to expand the drug discovery ecosystem and community in Africa. When I say expanding, how can we share our lessons, our learnings, and our experiences with our brothers and sisters in other parts of the continent? So the H3D Center started some capacity building initiatives working with many different partners. And I'll exemplify this on the next slide. But we needed a vehicle that would drive this capacity building project so that the center, H3D, could focus on the drug discovery projects. That there's no distraction, that we're not detracted from focusing on the core mission of drug discovery. So we had to create this not-for-profit company to drive the capacity building initiatives, to enable and unlock the potential for drug discovery across the continent. And this is all the initiatives are summarized on this slide here. This initial, there are different aspects. One is Pan-African, the second one is local, South African. So the top is really a program that we started with the Gates Foundation, which you can see here. Many other partners involved in this, including the Science for Africa Foundation, including Medicines for Malaria Venture. But we began this program as H3D back in 2017 and really talked with the Gates Foundation about how we can use our lessons we've learned in H3D to begin to expand a community, an ecosystem of drug discovery. And so this was a meeting, this was a workshop last year of the cohorts that are involved in the Grand Challenge Africa Drug Discovery Program. And of course, you'll be pleased to see this picture here. This was a visit undertaken by colleagues from Dundee, who of course are working with colleagues in Ghana, developing the Ghana Drug Discovery Hub, and of course, your Vice Chancellor and some of our team members visiting the University of Ghana last year. So this is a Pan-African program that we're developing, and at the bottom here is the local South African program, working with the South African government and the South African Medical Research Council to target historically disadvantaged institutions across South Africa. And these are just examples of projects that are funded by the government for us to build drug discovery capacity, working together, sharing lessons and learnings, but making these institutions as the center of gravity for the work that we do. And they can have access to our platforms and our networks, but also we share learnings because we also started from somewhere. We just didn't land where we are. There was a journey. So this is really what we're doing across the continent, leading these efforts, but also locally within South Africa. All right, this is my final slide. It's a busy slide. I don't want to speak to every point here. I'm just going to try and highlight a couple that are important. These are the, if you like, the critical success factors when I look back to the journey of H3D. And I don't want to go through everything just in the interest of time. But I think I'm going to highlight just two things here, okay? Of course, the driver of drug discovery is recognizing that you have an unmet medical need. That's for sure. That's a starting point. Unmet medical need. The other ingredients, funding from the government of South Africa. We get, all the funding we get from the Gates Foundation, for example, it's leveraged with South African government money on a one-to-one basis. So for every dollar we get from the Gates Foundation, we get $1 from the government of South Africa. Very powerful. This is a partnership, not just research partnerships, but also funding partnerships. And government can play a role in doing that. I really want to acknowledge the tremendous support from the government of South Africa to provide not just the funding for the infrastructure that we've developed, but also providing matching funding that makes it attractive for other funders to want to fund what we do because they can leverage government funding as well. But I want to just, we've brought in industry talent on the team, et cetera. You need experience on the team. Our advisory board are all former executives and former executives because we need to learn from people who have done what we're trying to do. But I'll finish off with just two things here. Humility, in this context, is knowing what you don't know. So I didn't know how to do drug discovery. And I told you that I recognized that I didn't know how to do drug discovery. The obvious thing is to learn from people who've done it. So I took a sabbatical and went to Pfizer. Humility, very important. The final point I'm making here is consistency. You are going to have naysayers, you're going to have haters, You can have jealous people, etc., etc. They will criticize you, they will mock you, they will laugh at you. Be consistent in whatever you believe is the right thing to do. Be consistent. And I think when you're consistent, you can have the final laugh. So that's my final slide. This slide is just simply to acknowledge our funders. I don't want to name them individually, but the logos are displayed here. They go from philanthropic entities to pharmaceutical companies, to the government of South Africa on the right-hand side. These are all government funding entities that we've enjoyed support from. And of course, also a net worth individual, Neville Isdale, was the chairman and CEO of Coca-Cola. He funds my position. And of course, really grateful to all these funders that are included here, because without them, we wouldn't do what we have done. This is part of the team. I'm sure Gordon has been to the Kirstenbosch Botanic Gardens, but I don't know if Gordon has climbed Table Mountain. But there it is for you to climb if you happen to visit. And then I'll just finish off with this, because in Gordon's introduction, he mentioned Zambia. And of course, he mentioned the football. But this is where we're going back to next year to hold our 5th HRD Symposium. So please save the date for this important meeting. And of course, this Victoria Force is not in Ghana. It is in Zambia. So I invite you to come and join us next year for this symposium. I'll stop here. And once again, Gordon and the organizing committee, thank you so much for this invitation. Very grateful to be part of this, and congratulations for all the achievements. And I'm happy to take any questions that there may be. Thank you so much.
Thank you very much, Kelly. And I will send you a bill for all those advertisements that you have made on our platform. Thank you so much for an excellent talk, as usual. So, colleagues, he has time for a few questions.
Hi. Thanks for the inspiring talk. By the way, I climbed the Table Mountain in March with Elvis, one of our students. My question is on the drug that made it through the phase 2 trial. I'm just curious about the process. What was the source of the, what compound it was, and what's the status of it right now?
Thank you very much. So it's a two-part question. So the source of the compound was a commercial library. It was a library called the Soft Focus Library. It was sold by a company called Biofocus, who a few years ago were acquired by Charles River. So this was a soft focus library, synthetic small molecules. When I say soft focus, it was designed with a particular gene family in mind. And so this was 35,000 small molecules that we screened phenotypically on the malaria parasite. And then in parallel, screened on mammalian cells. And then we selected active compounds which were more selective towards the parasite. So that is the answer to the first part of the question. Where did the compounds come from? They came from a commercial library that we purchased with MMV. The second part of the question is, where is the compound? The compound reached phase 2 trials. Phase 1 was done here in Cape Town, and then phase 2 was done in Ethiopia. We, with our partners, MMV, discontinued the development of this compound in phase 2 for one main reason. And of course, in drug development, you have to err on the side of caution. And that is the issue we saw in rats, not in rabbits, where there was embryo toxicity seen in rats. Not, and I emphasize, not in rabbit. But because the mechanism that we found in terms of how this drug works is a novel mechanism, we want to understand whether this toxicity flag in rodents is linked to the target, which happens to be a kinase target. And of course, because it's a novel mechanism and there are multiple programs going after this target, and we have other programs with Merck and Novartis also have programs around the same mechanism. So we discontinue the development of this, and so that we can understand better what is the basis for this toxicity, which we only saw in rodents. And of course, it went into people already, but we have to use the data that we have to decide to err on the side of caution. Because if this was replicated in people, let's say, then of course we can't give it to pregnant women because that's an important patient population for malaria drugs. Thank you.
Thanks. I forgot to mention something, but you touched on it. What's the mechanism of action of this compound?
Yes, so the target is a kinase. It's a lipid kinase, phosphoinositol 4 kinase. And so this is the target of this. And of course, that's a concern often with kinase targets, is that you worry about off targets because of the human kinome. But there are phylogenetic differences between the Plasmodium kinome and the human kinome that you can exploit for drug discovery. In fact, this particular kinase, compound kinase inhibitor we developed, is exquisitely selective over the human ortholog. So this is a type 3 beta lipid kinase, phosphoinositol 4 kinase, type 3 beta, and the human ortholog is there, but we could achieve very good selectivity, which we can rationalize. So we are using structural information in our other follow-on programs to develop additional compounds. In fact, we have 2 candidates we developed. One was stopped, and yet it showed a very different toxicity profile to the embryo toxicity that we saw with the compound that went into phase 2. And then we have another one that we are currently profiling that showed the best safety profile of the 2, including the one that went into phase 2. So yeah, you learn lessons, and then of course you refine what you do as you go forward. Thank you very much.
Yeah, Alphonse, yeah.
Kelly, thanks very much for that inspiring talk. COVID-19 taught us that we could really shorten the time that it takes to develop vaccines and probably other drugs for the various health challenges that we face as a continent. So my question would be, has your program found any means to learn any lessons that you could use to fast track the development of some of the drugs that you're working on? Thank you.
Thank you very much. Thank you for your kind words. Thank you. So I think what COVID did was provide a blueprint, as correctly you indicate, of how we can accelerate programs. Now, what it took, and because the whole world was affected by this pandemic, and it's a shame because, because malaria and TB and other things that affect largely the poor people don't get similar attention. But the blueprint that COVID showed us, what we saw was unprecedented levels of cooperation, not just between researchers, but also with regulators, approval authorities, policymakers, and people sharing data in real time. Sharing data with regulators in real time. We had agility and flexibility of regulators. So I would say the lesson from there that we need to replicate in Africa, and then thanks to the developments that are happening, we're not there yet, is having this harmonizing the regulatory environment, so that we don't have every country with its own rules and policies and regulations for clinical trials. That's going to slow down major studies. So I think with the African Medicines Agency, I think that is a very important development, because unless we harmonize the regulatory environment, where things get slowed down considerably, then I think we're going to have a big problem. So I think for me, the big lesson is harmonize the regulatory environment. And then, of course, have very high levels of cooperation and sharing of data, which doesn't happen a lot outside of COVID, but because COVID affected everybody across the world. And so we have to say, what affects us more in Africa, let's prioritize that and sort out the regulatory environment, which is a major roadblock to this. Thank you.
Thank you. Last one.
Can you hear me? Yes. Kelly, first I'd like to congratulate you. I think it's fantastic what you have accomplished, and I wish you well in all the future goals. But I'm interested in antimicrobial resistance, and particularly antibacterial resistance on the type of pathogens that we know are very dangerous, and we don't have any options. So I'm kind of curious if you could elaborate a little more on the overall approach for antimicrobial resistance aside from TB, looking for new drugs or compounds that can potentiate the drugs that we have, which will make them much efficacious.
Thank you very much for your kind words and for your question. Yeah, so of course, antimicrobial resistance is very broad, and often the perception is that when you talk about AMR, people think about antibiotics. But no, I like the use of the word drug-resistant infections because, so AMR is not just antibiotics, it's also could be parasitic AMR, it could be mycobacterial AMR. But to your question, what we are doing within the J&J project, the Johnson & Johnson project, is first of all recognizing, and I think this is important, is we can develop the tools, but if we don't steward those tools appropriately. So that is the first starting point. Drug discovery is a risky business. You have to kiss many frogs before you meet the prince. And the success rate is very, very low. So we have to make sure we steward what we have well. But our approach to your question is actually focused on single multi-drug resistant pathogens. So we're not focused on developing broad spectrum antibiotics. We are focused on precision antibiotics that only go after one particular pathogen, because I think this is one way to mitigate resistance. So we don't want new drugs that end up killing multiple bacteria. We know the complications sometimes even with TB drugs. Now they could affect the microbiome and stuff like that. So our approach is simply to focus on single multi-drug resistant pathogens that are significant in a particular region. And that's the approach that we're taking. Thank you.
All right. So I think we'll leave it there. Kelly, very, very grateful. Thank you so much for taking the time to join us. We consider this as half of the deal done. You still need to come to Ghana, and then we would arrange for you to meet your professor. So we ask that you keep your July 2024 open, just like you asked us to keep our May. We should mark our calendars for your meeting in Zambia. We would also hope that you also mark your July 2024, which will be our 10th anniversary, by the way. WACCBIP will be 10 years next year, so we hope you can join us. So thank you so much, and see you soon.
Thank you very much indeed. Bye-bye.
Right, thank you. So we move on to our next session, which is the fellows section. And we have the first speaker for this session being in the person of Nana Adade. So Nana Adade will give us a talk on the substrate utilization in the survival and evaluation of virulence of Vibrio cholerae. Nana Adade, the floor is yours.
Good morning. So I'll be giving a talk from my PhD thesis, which I have titled Substrate Utilization in the Survival and Evolution of Virulence in Vibrio cholera. Vibrio cholera is a gram-negative common-shaped bacteria. It's a facultative pathogen. It is fecal orally transmitted, and is best known as a causative agent of the debilitating diarrhea disease known as cholera. Its natural habitat is aquatic environments where it can live as a free-living organism or in association with aquatic plants and animals. And in these two environments, in the natural habitat or when they are in the host, they are exposed to diverse stressors. And in an attempt to adapt to these diverse stresses, they have been known to evolve virulence. Generally, however, microbial stress adaptation and virulence evolution is by horizontal gene transfer and by pathoadaptive mutations. And with these two processes, we expect that there will be utilization of available resources as well as the activation of metabolic pathways. So we aim to investigate how substrate utilization capabilities of Vibrio cholera may contribute to their survival of environmental stress and evolution of virulence traits. To help us achieve our aim, we expose clinical and environmental Vibrio cholera strains to diverse stress conditions we think simulates what they go through either in the environment or in the host. So this includes osmotic to acidic pH. And as well, this was done for up to 200 days using a method called long-term experimental evolution via serial transfer, which then assay for using these virulence phenotypes as markers of virulence to show whether the evolved strains or the evolved variants had increased virulence against their parental strains at different time points. Our results show that we have strains that showed increased virulence and phenotypes compared to the parental strains. For instance, you see the shades in purple are supposed to be the one that have increased virulence traits, such as increased biofilm formation, increased protease activity, as well as hemolytic and colony morphotypes. So we wanted to find out the underlying genetic changes for these observed phenotypes. We did our genomic analysis, which included whole genome sequencing. We looked for our SNPs using SNP all the way down to doing some cluster analysis to check for the SNPs in the different clusters. We were able to zero in on the underlying genetic changes to be SNPs in genes encoding the EAL and HD GYP domain containing protein. So the figures you see there are, the pictures you see there are the domain architecture and alignment of the different domain containing proteins. So in our cluster analysis, the strains clustered into 6 phylogenetic clusters. And those in cluster 2 and 3 seems to be the ones having these mutations. So what we think is happening, because the EAL and HD GYP domain containing proteins are involved in the degradation of cyclic di-GMP. So the intracellular accumulation of cyclic di-GMP probably triggered a transcriptional response, which led to the accumulation of Vibrio polysaccharide as well as mannose-sensitive hemagglutinin operons. This then led to the accumulation of biofilm and as well as the formation of wrinkled colonies. This can be seen in the strains in the two clusters in red, which I have shown in red here. These were the ones showing the increased virulence phenotype, especially biofilm formation, as well as colony morphotypes. So we went ahead we wanted to find out if substrate utilization has any influence on the observed phenotypes. So employing biolog phenotypic microarray, which enables us to do some high throughput assessment of substrate utilization of 190 carbon, 95 nitrate, nitrogen, and 94 phosphorus and sulfur substrates. We wanted to find out if the phenotype we were seeing had anything to do with substrate utilization. So this was done, and then we did our analysis using duct tape as well as OPM. So for our results, we see that indeed Vibrio cholera strains, the evolved strains and the parental strains showed differences in substrate utilization. So we can see if we zeroed in on an environmental strain and a clinical strain, and we see that they had common carbon substrate usage. For instance, they had 44 for the carbon substrate for the environmental strain, 95 nitrogen, and 94 phosphorus and sulfur substrate. So also, you see that the strains, the variants, it looks like they had access to more substrate. This could be the reason they were able to survive the various stress conditions for the long term. So for the environmental strain, for instance, we see that the variants utilize more carbon and more phosphorus and sulfur substrate, while there seems to be a uniform utilization of the nitrogen substrate. For the clinical strain, we see that there seems to be varied utilization of the nitrogen and phosphorus and sulfur substrate, while the variants utilize less carbon substrate for the clinical strains. We then wanted to see any underlying metabolic activity that may be responsible for the phenotypes that we had observed. So using duct tape actually combines the genome. The genome is usually encoded in KEGG pathway, and then the phenome is the observed phenotype from the phenotypic microarray that we have observed, and then highlights metabolic hotspots to explain sort of the phenotypes that you have observed in relation to the utilization of specific substrates. So for the clinical strain and the environmental strain, we see that this is an environmental strain. We see varied pathways that are likely used in response to the stress condition or in utilization of this particular nitrogen compound, which in this case is glycine. And here, the clinical strain, there seems to be no variability in the utilization of this carbon compound, which is, in this case, is D-mannose, and then it looks like the pathways are not a lot. So we looked at some of the functions of the pathways that were highlighted, and then from other studies, we see that these pathways have been involved in virulence and stress tolerance or survival. For instance, we see the lysine degradation pathway, which is involved in acid stress alleviation and tolerance. We see the methane metabolism also involved in environmental stress survival, and the biosynthesis of cofactors, which are involved in oxidative, osmotic, and heat stress and survival, confirming that what we are saying, the pathways are likely and needed for the stress survival that we had observed earlier. So in summary, we concluded that substrate utilization differences likely confer the prolonged survival advantages and increased virulence traits on the Vibrio cholera strains. And then we already highlighted the pathways in the Vibrio cholera strains are involved in stress survival and virulence traits expression as buttressed by the first point. And the environmental strains likely activated more metabolic pathways, reflecting their exposure to more and diverse stress conditions. And it looks like the fewer metabolic pathways which were activated by the clinical strains because they were already adapted to using specific pathways for host infection prior to the exposure to the selected stress conditions. So significantly, we think this may add to the explanation of why certain biotypes or variants may have evolved to survive better in the environment and the host with higher pathogenic potential, such as the currently circulating et al. Biotype. I would like to acknowledge my amazing supervisory team, Drs. Dodu and Dr. Ahator, and Professors Mosi and Valvano, and then my funding partners. Thank you very much. I acknowledge these people, and then members, the labs where I did all my experimental procedures, Dodu lab at WACCBIP and Valvano lab at Queen's University. Thank you.
Thank you, Adade, for the great talk. We open the floor for questions. Any questions for her? Suggestions? Comments? You have 10 minutes, please. Ask questions, comments.
It means they understood everything I said, so you can call it here.
Right. So thank you very much for the great talk the other day. So our next speaker is Joyce Ngoy. She's a the sequencing manager here to talk on expanding sequencing capacity to sustainable impact, right? Where she's comparing genomic research with pathogen genomic surveillance. Joyce, the floor is yours.
Thank you. All right, so in the spirit of capacity building, I'll continue to talk about capacity building, especially in sequencing, and why it is important to build such capacity for sustainable impact, especially with genomic research and pathogenic genomic surveillance. Am I pointing at the right? All right. So in the last 2 days, we've heard a lot about next generation sequencing or sequencing in general. So what is sequencing and why is it important? So sequencing, next generation sequencing, also referred to as massively parallel sequencing, is a technique that enables you to sequence millions of DNA strands or fragments at the same time. And this allows you to interrogate from tens to thousands of genes to discover or analyze different genomic features in one sequencing run, and at the same time analyzing multiple samples. And this allows you to look into aspects of like single nucleotide polymorphism, structural variants, and so on and so forth. And because of the speed, the throughput and accuracy of next generation sequencing platforms, it has revolutionized the way we do genomic research and allowed us to study and understand complex biological systems at a great depth. Now, this technology has evolved a lot over the years since the development of the first automated sequencing platform. We are currently on our third generation sequencing platform, which are now miniaturized to a point that we have handheld sequencing devices that are now easily deployable to even in remote areas to allow for sequencing. The chemistry has also evolved a lot. We are now able to do what we call long-read sequencing, which allows for de novo assembly and also analysis of complex genomes that have a lot of repetitive sequence. When it comes to the throughput and the speed at which you're able to generate your data, this has also improved a lot over the years, and it has also led to reduction in cost for sequencing. So we have been developing or gradually developing our sequencing core facility at WACCBIP. This has been over the last 4 to 5 years, so it's still quite a relatively young facility. We started initially with the Ion Torrent platform, and then we moved on to expanding our capacity with Oxford Nanopore platform, especially during the COVID pandemic. And then we've also now leveraged on the medium to high throughput platforms from Illumina. The rest are just ancillary equipment that allow us to do specialized sequencing for different applications. So our main objective at the NGS, WACCBIP NGS core facility is to facilitate academic research, facilitate genomic research at the center, and at the same time support pathogen genomic surveillance. Now, we strive to strike a balance because both arms require different platforms. For academic research, we need medium to high throughput platforms and high depth because of the complex nature of the questions that needs to be answered. For pathogen genomic surveillance, these programs require low to medium throughput platforms that are also scalable and we are able to generate data within a very short time for relaying to, especially to the public health authorities. For academic research, like I mentioned, we support research projects that cut cross-disciplinary projects. And most of these projects are geared towards discovery and functional analysis of genes. Interested in looking at host pathogen interactions, metagenomics, looking at structural variants when it comes to cancer genomics and gene expression profiling as well. We have a wide variety of applications that we use to achieve this, ranging from whole genome sequencing, whole exome sequencing, transcriptomics, targeted sequencing, and so on. So for pathogen genomic surveillance, we've been very actively involved with genomic surveillance of COVID-19. And if there's one thing that the pandemic highlighted was the importance of using genomic surveillance as a public health tool. This is a map generated from a survey by Africa CDC showing that around 2018-2019, that's before the pandemic, only 7 countries had functional NGS capacity in their public health labs. And most of these were disease control programs like influenza, antimicrobial, supporting influenza, antimicrobial resistant TB. And this and other facilities, both private and public, were mobilized to support SARS-CoV-2 sequencing efforts within the continent. So we were not left behind at WACCBIP. So we leveraged on the sequencing capacity that we had been developing in the past years to sequence the first cases of SARS-CoV-2 detected in the country. I have to mention that this was also in collaboration with our sister institution at Noguchi. We had the expertise. We had sequencing platforms available and also bioinformatics analysis platforms available. And by so doing, we were able to sequence within the first 2 months. We were able to generate data to show that there was a local viral evolution in the country. So subsequent sequencing over months following the first case that was detected, we noticed that we are seeing a lot of viral local evolution and a lot of spread in the community, because initially most of the intervention was targeted at entry points, especially in the airport. So the initial samples that we were sequencing were coming from the airport. So because of this, we needed to intensify the sequencing activities at the center. So this created an opportunity for us to establish a robust system to track and monitor the virus across the country. We employed 3 strategic actions. One of them implementing partners, so creating functional networks with public health authorities like the Ghana Health Service, which would later give us approval to collect samples from, or positive samples from testing labs, hospitals, and clinics, and also funding. Integrating genomic surveillance comes at a very high cost, so we need funding for that. And also establishing sustainable sequencing protocols, not only for genomic surveillance of SARS-CoV-2, but for other pathogens. So we needed to leverage on a platform that is scalable, fast, and cost-effective in our resource-limited settings. And of course, finally, for the data analysis, where we feed our sequencing information to our high-performance computing system, so that the bioinformaticians would quickly access the data for analysis and to put it together with our clinical data to understand the virus transmission trends in the country. So zooming into building a sustainable sequencing pipeline for the technical bit, like I said, we leverage on the Oxford Nanopore technology for this work, leveraging on its scalability because of the varied number of samples that would receive, and on the speed as well, because it provides data in real time, so we are able to communicate our findings to the public health authorities within a short within a short period of time. And you can see over the time we've expanded our capacity, because our surveillance system was aimed to track and monitor the virus across the country. So we are receiving quite a large number of samples as time went by. This is a paper, you can look at it later on, showing the molecular footprint of the virus from 2020 to 2021. So just to show you what we've been doing over the years, we've been tracking the virus through our surveillance efforts from 2020, when the first case was detected, to currently. I think the last case that we sequenced was in March 2023, and you can see how the virus has evolved over the time in the country. So even before we established a surveillance system for SARS-CoV-2, we had previously been trying to implement a program for genomic surveillance of malaria in 2019. And this is an initiative led by Dr. Lucas, supported through his NIH grant, and we also work collaboratively with the Sanger Institute to implement the local version of the malaria gen amplicon kits. And this is to understand the genomic landscape of malaria parasites in the country, to help the National Malaria Control Program to tailor-make strategies for malaria prevention and control. One of the main obstacles when it comes to sequencing of the Plasmodium falciparum species is the limited amount of DNA compared to the amount of the human DNA in clinical samples. And for you to be able to get enough of that material, it means that you have to obtain large sample volumes. It's a long process to try to enrich for the parasite DNA and eliminate the human DNA. And also, because of the nature of the sample that you're collecting, it means that you have challenges with storage. So we, for this program, we have been using dried blood spots, which allows you to collect small volumes. Storage is easy, shipping is easy, so the sample integrity does not get affected. There are challenges when it comes to the quality and the quantity of the parasite material, but there are ways of overcoming that. So for the malaria surveillance, genomic surveillance program. Our choice of platform is MySeq, Illumina platform. And the way we go about it, like I said, there are challenges when it comes to targeting the small amount of the malaria parasite DNA. So when we get the dried blood spot, we extract DNA from the dried blood spot, and then we perform a selective whole genome amplification of the parasite DNA, and then go ahead and amplify regions that are important to the parasite for drug resistance. And we do this by using primer pairs, over 100 primer pairs that target over 100 regions in the malaria parasite genome. And at the same time, we try to also multiplex as many samples as possible within one run. So because of the throughput that the MySeq offers, we are able to get enough depth to be able to perform the analysis. So it's quite a complex process that I will not go through all of it. But as complex and tedious as it is, it's quite rewarding because you're able to identify mutations that are known to lead to resistance to malaria drug malaria drugs. So the other arm of our sequencing core is training. So strengthening the workforce. We've been doing or providing extensive wet lab and bioinformatics training, especially through the networks that we've established over time with other scientists, and this is to help improve pandemic preparedness. Locally, we've targeted some, especially with the SARS-CoV-2, we've targeted public health institutions, and within the region, I think we've trained over 7 different countries. And apart from equipping them with the knowledge, we also try to increase or help them build a sequencing capacity, because knowledge alone is not going to help them handle any public health threats in the future when it happens. So these are just pictures showing some of the trainings that we've been able to offer at WACCBIP, from training internally to within the country, participants within the country and across the region. So some of the challenges we've experienced during the implementation of a genomic capacity is the cost of implementing such capacity, both the wet lab and also the computing infrastructure, and the cost of maintaining the infrastructure as well. I'm sure everybody in the room will agree with me when it comes to supply of reagents. I think it's one of the things that hold us back, and consumables as well. We also need a continuous support to be able to do routine genomic surveillance. Another challenge that we usually experience is clinical data, a lack of clinical data that accompany the samples that we receive for sequencing. I would like to acknowledge the following people. Prof. Gonawandare for allowing us to share in his vision of developing a world-class genomic facility. Dr. Lucas, through the support that the NIHR grant and the project has offered to the facility. Dr. Collins and the bioinformatics team for all the support when it comes to data analysis. Dr. Kwashi, especially with this, through his support or establishing the SARS-CoV-2 genomic surveillance system. Dr. Yao Bediako and Dr. Aniwe, I didn't mention, but some of the state-of-the-art machines that we have in the lab are through grants that are awarded from the effort that our senior research fellows put in. And Dr. Gloria Megata and Dr. Dan Oduro Mensah, especially for their support in coordinating the field work activities to allow us to receive samples from across the country. And of course, the dedicated NGS lab team and the data analysis team. Thank you.
Thank you, Ms. Ngoy, for the great talk. The floor is open for questions. Any question for her? A comment? Is this the question? Hannah, please.
Thanks for this excellent talk. Very impressive, the facilities you're having here and the capacity you built. I would like to ask regarding the drug resistance markers that you monitor in malaria. Now, the usual problem is in a high transmission setting that you have mixed clonal infections, right? And wouldn't it be better to get longer reads to get actually the drug resistant types actually phased rather than just looking at the single positions? Wouldn't that be a better strategy to try and go nanopore for those?
Sorry, I didn't get the last part of your
for the malaria drug resistance markers that you're surveilling. Now, if you have a mixed clonal infection, what you usually use is the information which point mutation goes with which. So you lose the phasing information.
With short read sequencing?
If it's too short, yeah. Do you have like strategies to why don't you go and nanopore it and get longer reads?
So the target regions that we usually target for the drug-resistant genes, they're not very short. I think there are regions of about 300 to 400. And also, when it comes to the long-read sequencing, means that we have to use the Oxford nanopore in terms of the cost and the throughput, because we are targeting quite a lot of a large number of the malaria drug-resistant genes. It will not be very cost-effective. But with the kind of throughput that we get with the Illumina MySeq platform, and also the error rates are also lower when it comes to the Illumina platforms. So a combination of factors, including the error rates, the cost. Remember, we are targeting as many parts of the country that experience a high transmission. We are also targeting as many drug-resistant genes as possible. So our assay tries to multiplex when it comes to sampling and also the targets.
Well, maybe I might be more specific. If you look, for instance, at DHPS, yeah, would your approach allow you to get all the codons you usually would monitor? Because this.
Yes, I think so. So we've just successfully sequenced our first batch the last 2 weeks. So we are doing the analysis now, and I think we'll be able to get more information of that. And if we need to improve, to get more information. Yeah.
Thanks a lot.
So in the next, maybe the next conference, we'll be able to give you that information.
Yeah, so that is a very nice talk. So just 2 questions. So with you have whole genome and also whole exon. Usually people focus on the exon because that is where protein coding genes are. But clearly we know that is less than 2%. So I'm wondering, are you also getting some exciting finding, let's say, from the non-protein coding genes? And also secondly, this is a really wonderful platform. So I'm wondering, are there avenues for people maybe to also collaborate from other places so that we maybe spread this just beyond malaria to other maybe non-communicable diseases? Thank you.
So actually, our sequencing lab, our core facility, we currently don't have the capacity to do whole genome sequencing. It would be very expensive with the kind of platforms that we have. So we would actually get more information if we were doing whole genome sequencing. But because of the cost, some of the projects have that want to get information, especially for the cancer genomics, we've tried to offer the support to use whole exome sequencing. Yeah, it's a bit more cheaper for that. With regards to the collaboration, yes, it's possible. So we are trying to have a sort of a commercial system where we can offer sequencing support, not just within the department or within the center and outside the university. So yeah, we can collaborate. And I mentioned earlier that we are not just doing pathogen genomic surveillance. We support our researchers to do more than just malaria parasite sequencing or COVID or SARS-CoV-2 sequencing. We do host sequencing to determine the host parasite pathogen interaction. Yeah, so it's quite. We have a wide array of applications that we can offer based on the kind of questions that you want to answer.
Okay.
Yes, we charge for it.
Yeah, great presentation. You kind of answered my question regarding the commercial aspect. So just a little bit elaborations on that. So what kind of services do you think you can render? Maybe single cell sequencing, bulk RNA sequencing, or?
Okay, so we offer whole genome sequencing for bacteria, viruses, and smaller genomes. So for human, we are not able to offer that because of the capacity. We are limited by the capacity that we have. Targeted sequencing, transcriptomics, so RNA-seq, single-cell RNA sequencing as well. Yeah, and metagenomics or 16S RNA sequencing. Yeah, my boss says it's cheap too. So.
So that's a great first session. Let's give a round of applause for all the speakers and for our chairs. And now I haven't heard of any housekeeping items as at now, so I think we're free to go have coffee and fruits, right? All right, and we'll be back here at 11:25 for our second keynote lecture of the day. And so let's have a quick coffee break and be back sharp.
Recording stopped. The world is now a global village, so is transporting your goods across the world made easy by Bethel Logistics Company Limited. Bethel Logistics is a licensed freight forwarding and clearing agent focusing exclusively on our expertise in the movement of air and ocean freight worldwide, as well as road freight and courier services. Bethel Logistics is a member of Ghana Institute of Freight Forwarders. For your freight forwarding responsibilities everywhere in the world as a business, government institutions, non-governmental organizations, and individuals, call on us. We are experts in freight forwarding, air, sea, and road, custom clearing and forwarding, cold chain logistics management, and anything freight. Locate us in Accra, adjacent Accra Girls Senior High School. Call us on 0204 528900 or 0244 707859. Remember to preface with +233 if calling from outside Ghana. Email us on info@betterlogistics.com. Our other offices are at number 18 and 20 Linus Building, Community 4, Tema. Second floor, Ghana Commercial Bank Building, Harbour Street, Takoradi. Bethel, experts in shipping logistics.
DCL has uniquely occupied a niche in the IVD market, providing unparalleled customer service and values for our immediate community by providing quality and sustainable laboratory solutions, supply installation and maintenance of medical lab equipment, reagents and consumables, affordable products and services, after-sales support, and extended warranty obligations. Support laboratories in the areas of clinical chemistry, hematology, histopathology, immunohistochemistry, blood banking, molecular pathology, immunology, and microbiology, among others. As a result of strong partnerships with world-acclaimed manufacturers of laboratory products, DCL has been able to help enhance quality healthcare, increase handling and logistic efficiencies, and expand access to healthcare infrastructure. The palpable impact DCL has made in the IVD market has seen it rise to becoming the Laboratory Supply Company of the Year across Nigeria in the last 5 years, and in the subsistent year across the entire West Africa. It's been a highly rewarding 15 years with you.
Welcome to Inqaba Biotech, Africa's genomics company. Established in 2002 in Pretoria, South Africa, Inqaba Biotech is a rare and unique company, as suggested by the name, and we thrive to give reliable and efficient services to all our customers. How it all began. With the concepts developed in the year 2000 to speed up the arrival of primers in molecular labs in the country, Dr. Oliver Pricer, co-founder and executive director, together with the venture team of 5, secured a loan from Swiss government and got rights to be the very first company to synthesize primers locally, and thus it all began. With capacity to synthesize over 1,000 primers a day, Inqaba remains the only company that does this in Africa. This is made possible by the Mermaid 192E. Using an ABI 3500 exome, we offer DNA sequencing from various templates, and we offer primer design, PCR amplification, cloning of PCR products, fungal and bacterial identification, and much more. In 2007, we launched Next Generation Sequencing Services, which provide NGS projects design inputs, quality control library preparation, and sequencing workflow using either MySeq, NextSeq, or the PacBio systems. We have more services that include SNP genotyping and methylation analysis using the Agena Biosciences mass array systems, bioinformatics solutions that complement our NGS services, and qPCR analysis. We also are a distributor of strong international brands, which includes New England Biolabs, Zymo Research, Eppendorf, Glentham, CG, Nolato Treff, Charlab, just to name a few. Inqaba boasts a responsive technical team with expert knowledge in the services we provide. We also have a well-trained engineering staff making sure that the installation and servicing of instruments purchased at Inqaba is well taken care of. A fleet of vehicles commissioned for local trips and deliveries assures we arrive at your lab on time. In the past 18 years, we have started subsidiaries in East and West Africa, and we have offices in Kenya, Nigeria, Ghana, Tanzania, Senegal, and still maintain a strong presence in our neighboring countries. All this is achieved with a highly trained and professional team that is always ready to assist. Welcome to Inqaba Biotech.
The world is now a global village, so is transporting your goods across the world made easy by Bethel Logistics Company Limited. Bethel Logistics is a licensed freight forwarding and clearing agent focusing exclusively on our expertise in the movement of air and ocean freight worldwide, as well as road freight and courier services. Bethel Logistics is a member of Ghana Institute of Freight Forwarders. For your freight forwarding responsibilities everywhere in the world as a business, government institutions, non-governmental organizations, and individuals, call on us. We are experts in freight forwarding, air, sea, and road, custom clearing and forwarding, cold chain logistics management, and anything freight. Locate us in Accra, adjacent Accra Girls Senior High School. Call us on 0204 528900 or 0244 707859. Remember to preface with +233 if calling from outside Ghana. Email us on info@betterlogistics.com. Our other offices are at number 18 and 20 Linus Building, Community 4, Tema. Second floor, Ghana Commercial Bank Building, Harbour Street, Takoradi. Bethel, experts in shipping logistics.
DCL has uniquely occupied a niche in the IVD market, providing unparalleled customer service and values for our immediate community by providing quality and sustainable laboratory solutions, supply installation and maintenance of medical lab equipment, reagents and consumables, affordable products and services, after-sales support, and extended warranty obligations. Support laboratories in the areas of clinical chemistry, hematology, histopathology, immunohistochemistry, blood banking, molecular pathology, immunology, and microbiology, among others. As a result of strong partnerships with world-acclaimed manufacturers of laboratory products, DCL has been able to help enhance quality healthcare, increase handling and logistic efficiencies, and expand access to healthcare infrastructure. The palpable impact DCL has made in the IVD market has seen it rise to becoming the Laboratory Supply Company of the Year across Nigeria in the last 5 years, and in the subsistent year across the entire West Africa. It's been a highly rewarding 15 years with you.
Welcome to Inqaba Biotech, Africa's genomics company. Established in 2002 in Pretoria, South Africa, Inqaba Biotech is a rare and unique company, as suggested by the name, and we thrive to give reliable and efficient services to all our customers. How it all began. With the concepts developed in the year 2000 to speed up the arrival of primers in molecular labs in the country, Dr. Oliver Pricer, co-founder and executive director, together with the venture team of 5, secured a loan from Swiss government and got rights to be the very first company to synthesize primers locally, and thus it all began. With capacity to synthesize over 1,000 primers a day, Inqaba remains the only company that does this in Africa. This is made possible by the Mermaid 192E. Using an ABI 3500 exome, we offer DNA sequencing from various templates, and we offer primer design, PCR amplification, cloning of PCR products, fungal and bacterial identification, and much more. In 2007, we launched Next Generation Sequencing Services, which provides NGS projects design inputs, quality control library preparation, and sequencing workflow using either MySeq, NextSeq, or the PacBio systems. We have more services that include SNP genotyping and methylation analysis using the Agena Biosciences mass array systems, bioinformatics solutions that complement our NGS services, and qPCR analysis. We also are a distributor of strong international brands, which includes New England Biolabs, Zymo Research, Eppendorf, Glentham, CG, Nolato Treff, Charlab, just to name a few. Inqaba boasts a responsive technical team with expert knowledge in the services we provide. We also have a well-trained engineering staff making sure that the installation and servicing of instruments purchased at Inqaba is well taken care of. A fleet of vehicles commissioned for local trips and deliveries assures we arrive at your lab on time. In the past 18 years, we have started subsidiaries in East and West Africa, and we have offices in Kenya, Nigeria, Ghana, Tanzania, Senegal, and still maintain a strong presence in our neighboring countries. All this is achieved with a highly trained and professional team that is always ready to assist. Welcome to Inqaba Biotech.
The world is now a global village, so is transporting your goods across the world made easy by Bethel Logistics Company Limited. Bethel Logistics is a licensed freight forwarding and clearing agent focusing exclusively on our expertise in the movement of air and ocean freight worldwide, as well as road freight and courier services. Bethel Logistics is a member of Ghana Institute of Freight Forwarders. For your freight forwarding responsibilities everywhere in the world as a business, government institutions, non-governmental organizations, and individuals, call on us. We are experts in freight forwarding, air, sea, and road, custom clearing and forwarding, cold chain logistics management, and anything freight. Locate us in Accra, adjacent Accra Girls Senior High School. Call us on 0204 528900 or 0244 707859. Remember to preface with +233 if calling from outside Ghana. Email us on info@betterlogistics.com. Our other offices are at number 18 and 20 Linus Building, Community 4, Tema. Second floor, Ghana Commercial Bank Building, Harbour Street, Takoradi. Betlaw, experts in shipping logistics.
DCL has uniquely occupied a niche in the IVD market, providing unparalleled customer service and values for our immediate community by providing quality and sustainable laboratory solutions, supply installation and maintenance of medical lab equipment, reagents and consumables, affordable products and services, after-sales support, and extended warranty obligations. Support laboratories in the areas of clinical chemistry, hematology, histopathology, immunohistochemistry, blood banking, molecular pathology, immunology, and microbiology, among others. As a result of strong partnerships with world-acclaimed manufacturers of laboratory products, DCL has been able to
All right. Welcome back. I hope you enjoyed your healthy snack. So today I'm
Recording in progress.
very privileged to have two of the best scientists on the continent keynoting our conference. So we've already heard from Kelly, and we're about to hear from another powerhouse in African science. So it's my pleasure to introduce Professor Tumbi Ndungu, who is the Director for Basic and Translational Science at the Africa Health Research Institute, which is at the University of KwaZulu-Natal in Durban, South Africa. He's the Program Director for what we call SANTE, Sub-Saharan African Network for TB HIV Research Excellence, which is one of the Deltas programs. So we've been together from Deltas 1 to Deltas 2. He's a professor of infectious diseases at the University College of London as well, scientific director of the University of KwaZulu-Natal's HIV pathogenesis program, and associate member of the Ragun Institute. He's a co-chair of the International AIDS Society towards an HIV cure advisory board. His educational background he has a Bachelor of Veterinary Medicine from the University of Nairobi. And then he has PhD in Biological Sciences in Public Health from Harvard University. His postdoctoral research in virology was also done at Harvard Medical School. Just like Kelly, he's a recipient of the South African Medical Research Council Gold Award for scientific contributions that have impacted on the health of people. And he's a member of the Academy of Science of South Africa and the African Academy of Sciences. His research, as you would find out very soon, focuses on understanding how the immune system may be harnessed for HIV prophylactic or therapeutic strategies. We are particularly grateful to Tumbi for trying so hard to be here today. He was at an HIV meeting in Australia, and from there he came straight here and arrived yesterday. And we are so honored that he went through this ordeal of a travel to be able to join us here today. So Tumbi, thank you for coming, and you have the stage now. Thank you.
Good morning. First of all, I'd like to acknowledge Gordon for the kind invitation, as well as the other members of the organizing committee. It's a great pleasure for me to come to Ghana. Obviously, Ghana has always been the African leader, you know, setting the stage and showing us the way. And so it's a great pleasure for me to be back here and also back in this great university. I'm going to talk about antiretroviral therapy initiated in acute HIV infection, which is some work that we have been doing in South Africa. And then I will talk about how this has implications for HIV cure interventions. Yeah, so I'll talk a little bit of background on HIV and why it is difficult to cure HIV. And then I'll talk about current approaches that people are thinking about for how to cure HIV. And then, as I mentioned, I'll talk about some work that we are doing in South Africa to try and address this question of HIV cure. So HIV is the leading public health problem in Africa, particularly in Eastern and Southern Africa. And this is KwaZulu-Natal, where I work. Durban is on the east coast of South Africa, in the province of KwaZulu-Natal, by the Indian Ocean. It's very nice and warm there. We have an all-year summer, and it's a beautiful, beautiful city, as you can see. But we have a big problem of HIV in KwaZulu-Natal. And as you can see from this data that we published a couple of years ago now, showing the prevalence of HIV. And I would like just to point out the prevalence, particularly in the age group of 25 to 44 years old, where you can see that in this rural province, or rural part of KwaZulu-Natal, the prevalence is about 40% in men and about 60% in women at that age group. And that's a big problem. Because although these people are getting antiretroviral therapy now, what it actually means is that these people will have to be on antiretroviral therapy for the rest of their lives, unless we can find a way to cure HIV. And so taking a pill every day for the rest of your life is not easy. Of course, even when you are taking antiretroviral therapy, it doesn't, unfortunately, correct all the immune dysfunction that HIV causes. So we need to find a cure for HIV. Now, we know that antiretroviral therapy is very, very effective against HIV. When somebody is has a viral load that is detectable, you can take antiretroviral therapy, and antiretroviral therapy will reduce the viral load to undetectable levels. which is great because then it doesn't cause a lot of clinical problems. It doesn't cause AIDS if you're taking antiretroviral therapy. But perhaps even more importantly is the fact that you cannot transmit the virus to somebody else because you have undetectable viremia. The problem is that as soon as antiretroviral therapy is interrupted, within a few weeks, within a week or two, the virus rebounds. There's a viral rebound, and so you must continue to take antiretroviral therapy for life. Now, the reason that antiretroviral therapy does not cure HIV is because of what we call latently infected cells. So these are cells, immune cells, mostly CD4 T cells, that contain HIV in their genome, and these are quiescent cells, so they're in the body, and they're not actively transcribing HIV. And so these cells can be very long-lived. Studies have shown that some of these cells can stay in the body for more than 20 years, and so it's very, very difficult to get rid of these latently infected cells. Now, so this reservoir, we call it the reservoir. These latently infected cells, we call them the reservoir. This reservoir persists despite antiretroviral therapy, and the reservoir can vary in size. So some people have a larger reservoir than others. It can vary according to its cellular location, the cells that contain the reservoir, as well as where those genomes are inserted within the host cells, and also, of course, by anatomical site. In fact, it is thought that most of the reservoir cells do not reside in peripheral blood, but rather in tissues, such as the gut, the reproductive tract, as well as the central nervous system. Now, there are a few cases where the reservoir has been completely eradicated and people have been cured of HIV. And I'm sure you are aware of this. So we have about 5 people or thereabout that have been cured of HIV. And HIV has been eradicated. Unfortunately, these individuals have been cured of HIV through bone marrow transplants or other gene editing approaches that we are not likely to see in the clinic soon. In fact, the reason that these individuals were cured of HIV is that they themselves had life-threatening conditions that required them to undergo a bone marrow transplant, usually with somebody who has cells that cannot be infected by HIV, as happened with the case of Timothy Brown, or the so-called Berlin patient who was cured of HIV. So unfortunately, that is not an option for the majority of people living with HIV. The alternative is to induce what we call remission. And it has been shown that with antiretroviral therapy, you can progressively reduce the size of the reservoir and then control that reservoir using immune cells, such as cytotoxic T cells, natural killer cells, as well as broadly neutralizing antibodies. And I think that this is a plausible pathway to HIV cure. It doesn't obviously cure HIV. It just causes the person to go into remission. But actually what we are seeing now is that there are many more and more people who are interrupting antiretroviral therapy and going into remission. Now, this is not recommended, definitely. The idea is that people should continue to take antiretroviral therapy for the rest of their lives, unless, of course, they are in a clinical setting where they are being monitored. So, although some people have gone into remission, this is not a recommended clinical strategy in the case of HIV. So, why do some people go into remission after they interrupt treatment? So, the idea is that you have these latently infected, long-lived cells, and you can reverse latency by causing those latently infected cells to start producing virus, and those latently infected cells will then die, all because they're starting to produce HIV proteins. They can be seen by the immune system and attacked by the immune system, such as cytotoxic T cells, natural killer cells, as well as antibodies. And then, of course, so those cells will then die. And if the reservoir is small enough, then some people actually do go into remission. The problem is that remission is very variable at the moment. So some people go into remission for about a month. Some people have gone into remission for years. And we don't have any biomarker to tell us who will go into remission and who will rebound very quickly. So, and this is why this is not a recommended strategy at the moment. So in the cases where this strategy has worked, it's usually in people with low reservoir, low disease burden, and lower genetic complexity of the virus. They have low inflammation, and they have sustained immune responses that can then control this reservoir. And one of the ways that you can achieve that ecosystem within the body is actually by introducing antiretroviral therapy very, very early during HIV infection, so that you don't have a lot of virus diversification, you don't have a lot of inflammation, and also you can preserve some aspects of antiviral immunity in the person who takes antiretroviral therapy early. So most of the cases where we have seen remission happen through these immunological approaches, it's actually in non-human primate studies. And you can see a number of papers that I have highlighted there, all of them in Nature, very high-profile papers, showing that you could treat monkeys with either broadly neutralizing antibodies or with vaccines and antiretroviral therapy and induce remission. And then once you interrupt treatment, the virus did not rebound. So most of these studies, unfortunately, at the moment, have mostly happened in non-human primates. But we are also beginning to see human studies that also seem to reproduce that same data. So there are a number of studies in humans where we have also seen some short duration of remission. And so the question is whether you can actually make this much more common and much more widespread, so that it is not just in a small number of people, but rather that it becomes a generalized phenomenon. So why do broadly neutralizing antibodies in particular seem to work? So broadly neutralizing antibodies seem to be able to induce HIV remission because, first of all, broadly neutralizing antibodies have direct antiviral activity, obviously. They can bind to the virus and prevent the virus from infecting new cells. But actually what various investigators have recently shown is that if you combine broadly neutralizing antibodies with latency reversal agents that cause the virus to come out of latency, the broadly neutralizing antibodies bind to the virus particles that are emerging from latency, and these are then picked up by antigen-presenting cells, such as dendritic cells, and then these dendritic cells then present the viral particles to cytotoxic T cells and induce new immune responses. They can also obviously be recognized by natural killer cells, and then this therefore induces new immune responses that are able to control the reservoir. So we've been interested in exploring whether this is actually possible in our context here in Africa, particularly in South Africa. So I'm going to now describe to you a study that we have been doing in South Africa called the FRESH study. FRESH stands for Females Rising Through Education, Support and Health. And what we have been doing in this particular cohort is to study acute HIV infection. So we were interested in acute HIV infection because we knew that acute HIV infection, that a lot of the disease progression that happens in somebody with HIV, the early events that happen during acute HIV infection actually shape what happens in the long term in somebody who is infected. So this is why we were initially interested in acute HIV infection. So we wanted to identify people with acute HIV infection. And in order to do this, we decided, because we knew that the incidence of HIV among young women between the ages of 18 and 24 is quite high in KwaZulu-Natal. So we decided to enroll HIV-negative women and follow them over time to see whether we could identify acute HIV infection. But we also knew that a lot of these women are in very disadvantaged socioeconomic status. So a lot of them are people who have dropped from school. They are no longer attending school, and they don't have jobs. So we decided, why don't we combine this with a socio-economic intervention program where we teach them how to use computers, we teach them some life skills that can benefit them in the long run. But in the meantime, they come to our clinic twice a week for these lessons. And when they come into the clinic, we take a finger prick, blood draw, and test it for HIV RNA. And because these are all HIV negative women when they enter into the study, but they're all sexually active, so that had to be a condition for participation in this study. You had to be sexually active. Self-declared, obviously. So self-declared sexually active people. So they come into the clinic twice a week. We take a finger prick blood draw, we test it for HIV RNA. And what that means is that because they're all HIV negative, if they acquire HIV infection, we will be able to detect it immediately because HIV RNA obviously shows up in peripheral blood much earlier than antibodies. And so that's what we have been doing. We follow these women for 9 months once they enter into the program. After 9 months, they have acquired some skills. And actually, we are very proud of this program because 80% of the women have been able to get jobs or return to school by the time they finish this particular program. We also give them HIV prevention. We offer them HIV prevention such as PrEP, pre-exposure prophylaxis, because we know that you can actually prevent infection using pre-exposure prophylaxis. We test them for STIs, and if they have an STI, we treat it. We give them condoms. But despite all these interventions, unfortunately, we are still able to get some acute HIV infection. In fact, since we started this study in 2012, we have now been able to get 101 acute infections that have happened in women who are in this study, unfortunately. Now, as I mentioned, the acute HIV infections that we get here are very early. So the first 14 individuals that we identified with acute HIV infection, we did not treat them immediately because at the time the South African treatment guidelines said that you had to, you started treatment when your CD4 count fell below 350 cells. So those were the treatment guidelines then. So at that time we were not treating. We were withholding treatment until the CD4 count fell to below 350, which was the national guidelines. But once we had started identifying acute HIV infections, we actually went to the ethics committee and we said, ethically, we cannot do this. We cannot continue to follow people. We are identifying people with acute HIV infection and not treating them. So we were given permission even before the national guidelines changed, and we started treating people immediately. So the 81% of the people that we have identified with acute HIV infection were in what we call FIBIG stage 1, and I will explain in the next slide what that means. Most of them test HIV negative 4 days prior. So last week, somebody will test HIV negative, and then this week they test HIV positive. So it's very, very early during HIV infection. And for those that we have started treatment on, 87 individuals now, we start treatment the following day after we detect acute HIV infection. So very, very early as possible, humanly possible to start treatment. So FIBIG stage 1 refers to this period here before peak viremia. So this is FIBIG stage 1 and 2. Before they reach peak viremia, that's when we are actually detecting most of the acute infections in this cohort. And what we do then is that we put them on treatment immediately. And I just wanted to highlight that this study has been ongoing for a long time now, 10 years, and we have had a lot of publications on the transmitted founder virus, the immune responses, as well as the impact of antiretroviral therapy when it is initiated early. So I'm going to tell you a little bit about what we have learned about introducing antiretroviral therapy early. So the first thing that we learned is that if you start treatment early, you blunt peak viremia. So this is the first 14 individuals that were not treated. You can see that they went up to a peak viral load of about 10 million copies, and then the viral load came down and stabilized at around 100,000 or thereabout. However, if you start treatment early, you can see that the viral load goes to undetectable within 4 weeks, at most 5 weeks. So the exposure to the virus is very, very limited. And actually, if you look at peak viremia, the peak viremia in the women who are not treated during acute HIV infection was about 10 million copies, as I mentioned. And the peak viremia in the women that were treated, the median peak viremia was about 10 million copies. The other thing that we noticed was that when you start treatment early, you preserve CD4 counts. So CD4 counts are used as a surrogate for how the immune system is doing in general. So you can see that for those that were not on antiretroviral therapy, we have their pre-infection CD4 count, and you can see it's high, and then it goes down to what we call a nadir, which is immediately after infection, the CD4 counts tend to go down, and then there is a slight recovery, but it never goes back to what it was before infection. In contrast, in the people that started treatment in hyperacute infection, although there is a dip in CD4 T cell count, the CD4 count actually go back to pretty much what it was before infection. And this actually illustrates, I think, the power of starting antiretroviral therapy so early. It really does preserve the immune system. Now, we've been interested in characterizing deeper the immune responses in these women who started treatment in hyperacute HIV infection. And so we did Western blot to see whether they actually do seroconvert. So you can see these are the first 14 women that were not treated. And the blue dot represents a Western blot negative sample time point. And the red is indicative of a positive test. So you can see that the first 14, all of them seroconverted and became HIV seropositive, as you would expect. But interestingly, for the women that started treatment in hyperacute infection, they had such limited exposure to the virus that most of them actually do not seroconvert. So they remain seronegative for HIV. Now, it doesn't mean that they are not infected with HIV, and we have to do a lot of counseling to make sure that they understand that they are still HIV positive, despite the fact that they do not seroconvert. It's just because they have had such a limited exposure. But we do know actually that, in fact, if they interrupt treatment, and some of them have interrupted treatment for various reasons, the virus rebounds again. So it doesn't mean that they are not infected. It just means that they have had very limited exposure to the virus such that they don't make immune responses. So that was CD4, that's humoral immune responses. We also looked at CD8 T-cell immune responses to see whether they made CD8 T-cell immune responses. And we found that actually the majority of them do make HIV-specific CD8 T-cell immune responses. And the frequency, the magnitude of the immune response is lower in those women who are treated early. Again, I think this is because of the limited exposure to the antigen. So you can see that their frequency of HIV-specific CD8 T cells, as measured by tetramer staining, is much lower compared to the untreated women. However, interestingly, although the frequency of HIV-specific CD8 T cells is lower, the ability of those cells to produce interferon gamma, which is one of the cytokines that we measure to see how functional HIV-specific CD8 T cells are, is higher in the early treated women. So early treatment seems to preserve some functions of CD8 T cells, as shown here. And actually, we went ahead and did transcriptional profiling, whole genome transcriptional profiling, and we can show that early treatment is associated with long-term memory, markers of long-term memory, such as BCL, upregulation of molecules such as BCL2, which are a marker of long-term memory, and anti-apoptotic CD8 T cells. So overall, we think that although early treatment reduces the frequency of HIV-specific CD8 T cells, the few CD8 T cells that they make are actually much better in the long term, or might be better in the long term in terms of their functionality. We have also looked at generalized immune activation, and here we just used a standard HLA-DR and CD38 as the markers of immune activation. And again, here you can see that for the women who are treated during hyperacute HIV infection, their level of CD4 T cell activation is almost the same as women who are HIV negative, so they don't experience any increased immune activation, whereas the women who are not treated during acute HIV infection, shown here in red, obviously have much higher levels of immune activation. The levels of immune activation do go down after you put them on antiretroviral therapy, and the same thing here again with CD8 T cells, where you can see that there is no CD8 T cell immune activation in the women who started treatment early, but there is high level of immune activation, CD8 T cell activation, in the women who started treatment late. We have also looked at the cytokine storm that is usually induced in acute viral infections. So most people suffering acute viral infections will have increased levels of cytokines that are circulating. And here I just showed you two examples here, one of IP10. And again, you can see that the women who are not treated have high levels of IP10 that they then control to normal levels. But the women that started treatment in acute HIV infection really have levels of cytokines that are circulating that are almost the same as women who are HIV negative. And the same thing here with another chemokine, CXCL13, where you can see that it goes up and stays high for the women who did not start treatment in acute HIV infection compared to the women that started treatment in acute HIV infection who have hardly any cytokine storm. We have also been characterizing the virus, and again, this is a phylogenetic tree. Maybe somebody told me recently I should change this tree from an aerial version because it doesn't look good. It looks good to me. But the point I wanted to make with this tree is that the virus, if you look at one patient, for example, this patient 093, you can see that all these dots, these are all single genome sequences that we generated from this individual, and they are all lying on top of each other, showing that there is no diversification. And this tells us that this person was infected with probably one single variant of HIV. So there is a transmission bottleneck that happens when somebody is infected, so that although the infecting person has many variants of HIV, it's only one single variant of HIV that is transmitted. And this is beautifully shown with some of these patients where you can see that it's only one single variant of HIV. The same thing with this patient 036 and 186. There are a few patients where several variants can be transmitted. An example here is this patient 271, where you can see that this patient was actually infected probably with two different variants that branch nicely in the phylogenetic tree, showing that there are some cases where there is multiple variant transmission. So because of the potential of broadly neutralizing antibodies for use in HIV cure strategies, we have characterized the transmitted founder virus to see what are the broadly neutralizing antibodies that they are sensitive to. And we chose broadly neutralizing antibodies in different regions of the virus envelope, the CD4 binding site, the V1, V2 loop, the V3 loop, the EMPA region, and so on. And this heat map shows which antibodies were very good at neutralizing these transmitted founder viruses. And it's a lot of information, but I just can summarize it for you that these two antibodies, VRCO7, 523LS, and CAP256, were the best antibodies. One targets the CD4 binding domain, and another one targets the V1, V2 loop. And so these antibodies, we think, could be used for HIV cure interventions because they are neutralizing most of these transmitted founder virus. And when I get to my last slide, I'll come back to this because we are actually now using these two broadly neutralizing antibodies to do a cure intervention in this cohort with the hope that we might be able to induce a remission. So in my last part of the talk, let me talk about characterizing the reservoir. So we've been interested in characterizing the reservoir in this cohort and comparing women who are untreated for a while. Those women, once the guidelines changed, obviously went into treatment, and you can see that this individual, for example, went into treatment. The viral load became undetectable. They recovered in terms of CD4 count, but the CD4 counts remained relatively low compared to somebody who was treated early, where you can see that they very quickly controlled viremia, and their CD4 counts remained quite high compared to the person who was treated in chronic HIV infection. So we've been interested in characterizing the reservoir in these two groups, in these actually three groups: the untreated individuals, the chronically treated individuals, as well as the acutely treated individuals. And the first thing that we noticed was that, as I mentioned to you earlier, that treatment in acute HIV infection blunts peak viremia. As you can see here, the untreated people have a much higher peak viremia compared to the individuals who are treated during acute HIV infection. Interestingly, the HIV proviral load, which is the reservoir, which represents the reservoir that is hiding in immune cells, is actually not impacted by early treatment. And the amount of peak viral load measured at exactly the same time points that we measured the peak viremia is not significantly different whether or not you treat. And this tells us that the reservoir, HIV reservoir, is established very, very early. So, and it doesn't matter even if you introduce treatment, the virus is already there and has already spread, most likely in our immune cells. And it's really very difficult to cure HIV from there on. However, although the peak viremia was the same, we then longitudinally followed these individuals. So again, these red dots here represent people who are not on treatment, those who are not treated immediately, and you can see that the reservoir is quite high. It doesn't change much over time. And even after they go on treatment, after 1 year, it is not significantly different from what it was originally. In contrast, individuals who went on treatment immediately, the reservoir steadily decreases. And by 1 year post-treatment initiation, it is significantly lower than what it was in the beginning. So early treatment is actually beneficial, even though the starting point is the same, but over time, you get a much lower viremia. And this is illustrated here, where you can see in the chronically treated individuals, they have much higher proviral load compared to acutely treated individuals after 1 year of treatment. But we haven't stopped there. So the data that I've just shown you is done by droplet digital PCR, where we measure the amount of virus in the cells. We have gone ahead to sequence the virus within the reservoir. And basically what we can show again here are the individuals that were acutely treated, and we are comparing them with individuals who are not initially treated acutely but then went on to treatment. And basically what we see is that when you treat individuals in acute HIV infection, the intrapatient diversity is much lower in the acutely treated individuals. So when you treat people, you're preventing virus diversification in the host, which might actually be beneficial in the long term in terms of therapeutic interventions. We have also looked at the genomes, the kind of genomes of the virus in these individuals. The blue represents sequences that are intact, meaning these are bioinformatically inferred sequences that can replicate. And you can see that in these untreated individuals, you have high numbers of these genome intact viruses, whereas the rest of the colors represent basically genomes that are defective. And you can see that in the chronically treated individuals, again, there is a reduction in these genome intact viruses, but they really never disappear. And this is in contrast to the individuals who are treated in acute HIV infection, where by 12 months, we can hardly detect any genome intact virus sequences. Usually we get just big deletions or hypermutated genomes, suggesting that the numbers of replication-competent viruses within the reservoir is very, very small when you start treatment in acute infection. And you have quantified this. Again, these are the intact genomes shown here and defective genomes. And you can see that in chronically treated individuals, the slope of decay, the decay is much slower compared to individuals who are treated in acute HIV infection of both the intact and defective genomes. But actually, the intact genomes seem to be decaying much faster than the defective genomes. And this could be because these intact genomes are perhaps producing viral proteins and can be seen by the immune system and are getting cleared, whereas the defective genomes represent genomes that are not cleared by the immune system, and so those cells can be very, very long-lived. We have also looked at cytotoxic T-cell immune responses, especially escape within known cytotoxic T-cell response epitopes of HIV, and I've just shown you a few patients here. This is a person who was untreated. You can see that by 24 months, the virus has escaped. The red represents escaped epitopes because this person is the virus is continuously seeing immune pressure, and the virus is escaping from immune pressure. And so in the genomes, you end up with all escape variants, and this is what you see when you sequence the reservoir. Is all these are escape variants in red. In the early treated individuals, the sequences are wild type because the virus doesn't have the chance to escape because it is not under any immune pressure. And so what goes into the reservoir are the wild type sequences. And we think, therefore, that it might be easier to intervene with a vaccine or anything that induces cytotoxic T cells in these early treated individuals. So where is this work leading us to? And this is, I think, my second last slide. We have now started to do a cure intervention study in this cohort. And the idea behind this intervention study is that because we are treating during acute HIV infection, very early during acute HIV infection, we rapidly control the virus, and this is beneficial to the patients. We are then intervening with the two broadly neutralizing antibodies that I mentioned we identified, VRC07 and CAP256, and a latency reversal agent, toll-like receptor agonist known as phosphotalamide, which is already in clinical use for cancer. And then we are interrupting treatment to see whether the virus rebounds. And the idea here is to see, will this intervention lead to new immune responses that induce durable control? And if not, why not? So we will be addressing, it's a small study, phase 1 study, to try and see what are the mechanisms that could be leading to remission if it does happen. And if it doesn't happen, of course, if remission doesn't happen, we put back the patients on treatment, and we'll again be answering the mechanistic questions why the remission did not happen. So just to conclude, there's emerging evidence that some immunotherapeutic interventions combined with other approaches such as early treatment may induce remission in some individuals. Early treatment, we have shown, preserves components of antiviral immunity. It abrogates the cytokine storm and reduces inflammation and immune activation, which may create an environment conducive to HIV remission. And ART in hyperacute infection blunts peak viremia, but not the reservoir, because the total HIV proviral DNA levels are similar with or without hyperacute ART. However, ART initiation reduces the reservoir size and complexity over time and preserves antiviral immunity. And I just thought that I would give this talk here because we wrote an opinion piece in Nature a few years ago, really trying to advocate for more HIV cure research, because a lot of HIV cure research at the moment is being done in the global north, where they have very few cases and where the epidemic is dominated by men who have sex with men, whereas here the epidemic is much more balanced, where there are men and women who are impacted by HIV. And then finally, I wanted to acknowledge these are the two institutes where I work, at the Africa Health Research Institute and the HIV Pathogenesis Program at the University of KwaZulu-Natal. I have a brilliant lab team, very talented, who are shown there. And I particularly wanted to acknowledge Kamini Gaunda and Kavitha Reddy, who have done most of the work that I presented today, as well as Bongiwe Ndlovu. I collaborate with the people at the Reagan Institute, particularly Krista Dong, who runs the FRESH study. And we have received a lot of funding from both South African sources as well as other international funders, and we are very grateful for that. Thank you very much.
Great, thank you very much. I see hands going up all over the place. I know some of you want to know why, despite all the preventive measures that they gave to the cohort, people still got HIV. So don't ask that question. Okay, where's the microphone? Okay.
I have one. He has one. We'll arm wrestle and we'll determine who goes
Okay,
first.
we start from the back. Hold on. Yeah.
Yeah, we'll work our way up. Thanks, Peter. First question, from a clinical standpoint, what treatment was it and how does that compare to what was utilized for post-exposure prophylaxis some time ago?
So what's the question? What is the
The
treatment we are
treatment
giving?
that you gave the individuals, what was the treatment and how does it differ, or does it differ from post-exposure prophylaxis?
Okay, so the treatment that we are giving is the standard first-line treatment in South Africa. I can't now remember the three drugs, but it is the first-line drugs that we use in South Africa. And we did that only for the first 7 patients. After that, we decided to add another drug, raltegravir, as a 4th drug, to see whether we could actually, because when we started this study, there was this idea that maybe very early treatment could cure people.
Sure.
So we added a 4th drug to see whether we could even be further bring down the reservoir. But actually it turned out not to have any impact on the reservoir.
Okay, great.
So it's a standard 3 drug, but we also give a PrEP, and the PrEP regimen is different from the first-line treatment regimen because the way the WHO and others have structured this is so that you're using 2 different drugs so that in case somebody was taking PrEP and gets infected, there is no problem of drug resistance if they go into antiretroviral treatment.
Okay, so from clinical medicine to basic science. Really nice job. I love the data that you showed, so thank you for that. A question that I had the entire time in my mind was, when we think about the bone marrow transplant and the cure, the magic, if there were to be such, was those individuals that donated the bone marrow actually had the 32 base pair deletion in CCR5, okay? So when I'm thinking about the chemokines that you're showing, we saw IP10 and I think CXCL13. Did you look at RANTES and CCR5 in these individuals and just not show it? So if I'm thinking about HIV, keeping virus low, and then I think about what's the magic of a transplant? That's pretty freaky, right? Well, apparently what we used to know about HIV in terms of it using CCR5 in the early days and then going to CXCR4 may not be as true as we thought. If I give you bone marrow and I lack that CCR5 mutation, so I can't infect. So the point would be, the central theme to me as an outsider who hasn't been in this area of research with HIV for a long time, that central thematic issue appears to be CCR5 in RANTES or CCL5. And so I was just wondering, if you look at data, because you looked at cytokines, chemokines, did transcriptomics, how does the receptor and its ligand RANTES look? Do they change with treatment? Do they change it early versus late?
Yeah, we haven't actually looked at that specifically.
Please do. Please do.
But it's a very interesting thought. We haven't looked at it. There is a time before this study started where we were looking at CCR5 polymorphisms in African populations.
Sure.
And we couldn't detect
1% or less. That won't be the answer, right?
Yeah.
But you know, with the monoclonal antibodies, the CCR5, et cetera, it seems like a central thematic issue with your research and then of others is the ability for the virus to get high, go to other cells, which is related in many ways because of those bone marrow transplants to expression of CCR5 going up and down, and its ligand hitting it to activate the cells. So you have the data, it'd be cool to look at, and you can just add me in the publication author list. So thanks.
All right.
This is just my complete ignorance. Beautiful, beautiful data. So can you predict when somebody's remission will be successful? So if they're early treated, they don't make much of an immune response. Is it those people then that can't go into remission when you remove the therapy? And are there no predictors? Do they make those that do go into remission? Do they have broadly neutralizing antibody? And the third thing is, if you did intermittent therapy rather than just the continual therapy on those that are treated early, would you increase the chance of remission?
Yeah, this is a problem we have in the field, is that nobody knows, we don't have any biomarker for predicting who will go into remission if you interrupt treatment. So everybody who has interrupted treatment so far has been blindly done. It's either because they developed some kind of toxicity or for whatever reason they were not willing to continue taking antiretroviral drugs. There is a huge effort at the moment to try and understand what are the predictors of people going into remission. And one of the things that we are doing in this cohort is to try and understand, are there factors that are associated with low reservoirs, low genome intact reservoirs that we can identify that could then be used to hopefully inform HIV cure interventions and see who could benefit, who will go into remission. But at the moment, there is none.
Okay. Fantastic talk. I had a question. So I think early on you showed us that in the treated and hyperacute phase, you have the long-lived memory T cells. And I was wondering whether it was linked to maybe a lower chance to start producing these defective HIV genomes, so there's less decoy effect, so the T cells that are produced early are more specific, and that's maybe why they're longer lived. But then later on, some of the data seem to kill that thought in my head. So do you think there's could that be that you're treating it and you're getting those very specific T cell responses early? And
I think maybe when you treat early, you do focus the immune system. It helps to focus the immune system so that it's perhaps focused on a few epitopes, and then those immune responses tend to generate this phenotype that appears to be long-lived. I have to say, though, that actually if you follow those people for 12 months and you look for that immune response, you don't detect it. And that's because you have taken away the virus because of suppressing viremia. But you can actually expand those cells again. So there's memory there, but they're very, very low frequency. So
does that reduce the chance of, let's say, immune exhaustion? And
yes, it does. Definitely reduces immune exhaustion and immune activation, detrimental immune activation. The only problem, again, as I say, because you are taking away the viral antigens by treating, whether that will be enough for you to, when you interrupt treatment, for that immune response to be recalled and control the virus, that's a question. And I think that most of the studies now are showing that it's not enough, because if you interrupt treatment, the virus actually does come back. So you need more than just the natural immune system.
Yeah.
Okay. First of all, I like to echo the other comments. The talk was really nice, very interesting study. And since Gordon doesn't let me ask my question, I have two more.
I said you shouldn't ask the question.
No, actually, I'm interested in the neutralizing antibodies that you referred to, that you can use therapeutically. Well, first, a logistic question. How do you get the antibodies? Is based on passive therapy? This is what you're talking about?
Yeah. So, sorry.
And then I have a second one after.
Okay, so these are antibodies that I'm talking about, the broadly neutralizing antibodies. These are antibodies that were isolated from people who are HIV infected. Most of them were infected for more than 4 years. They were cloned and shown to be very broad in their activity. And so we are now giving them passively to these individuals that have controlled the viremia to see whether in people who have undetectable viremia, if you give these broadly neutralizing antibodies, will they be able to, and if you give a combination of them, will they be able to control?
So they are produced from clones, so they're monoclonal? Or?
Yes, they are monoclonal antibodies, passively infused.
And is it anything that we can learn from those in terms of what will be the epitopes that will be useful?
Oh, yeah. We know a lot about these monoclonal antibodies, and at the moment, broadly neutralizing antibodies seem to fall into 5 classes based on where they target within the viral envelope. And so these are the ones that are being now developed commercially. And there is this idea that if you have broadly neutralizing antibodies that are targeting different epitopes, they almost act like antiretroviral therapy, and you might actually be able to inhibit virus replication because they are targeting different regions of the virus, and the virus will not be able to escape. But whether this is actually going to work in real life with HIV, I don't know, but it's being tested.
Okay. Yeah.
Okay. Thanks, Dumbi. As usual, really great talk. I was wondering about, kind of in line with Peter's question. So you showed that the CD4 T cells from these, or the T cells from these individuals were, in the early treated people, were better quality, but fewer in number. So the first question I had was it linked to, you said you talked about BCL2, but did you look to see whether or not, for instance, in the chronic infected people, they had higher PD-L1 and some of these quote-unquote exhaustion markers?
Yeah, they do.
Okay, and then my second question, sort of in line with your response to Peter, was, is anybody trying to expand in vitro these T cell populations and then put them back in? So kind of like CAR T cell therapy for cancer. Could we expand them outside and then put them into these people?
Definitely. There's a lot of research going on CAR T cells for HIV cure. And in fact, there are some clinical trials that are already taking place in the US. The problem, I think, with CAR T cells in Africa is that you have to have this ex vivo. You have to take them out, and people can hardly get any medication here. So doing an ex vivo gene therapy study in Africa is going to be challenging. I'm not saying it shouldn't be done. I'm just saying at the moment it is difficult. But certainly people are thinking that way.
Evelyn, do you have, sorry. Mariama, after Mariama, then Evelyn.
Thank you so much. Very, very nice talk. I want to ask, if you look at about the subtype, who is the host of the reservoir? If you look at that, what do you see? And what is the difference between the early treatment people and chronic treatment people?
In terms of the what?
Do you look about the subtype, who is the host of the reservoir or not? In subtype of CD4 T cells, like.
Okay, so first of all these individuals are infected with subtype C because it's in South Africa. But I think you're asking about which cells the reservoir is in.
Yes.
And actually, I didn't have time to tell you, but give the story. But I have a PhD student, Nicole, who is actually looking at where is the reservoir, what cells, and what we find is that most of the reservoir is in memory CD4 T cells. So we have done cell sorting. But interestingly, we also find that there is a reservoir within myeloid cells. We think these are monocytes because they are all in peripheral blood. And even in monocytes, the reservoir seems to be long-lived. So you can still detect it even 2 years after antiretroviral therapy started in monocytes. in the people who started treatment in chronic HIV infection. In the people who started treatment in acute HIV infection, almost all the reservoir is in CD4 memory T cells. You don't find any within monocytes. So we think that's very interesting. We are doing further studies now to see whether actually is that a replication competent virus. But primarily it is the CD4 T cells, memory CD4 T cells.
Thank you.
Thank you very much. That was very insightful. And just to make a point that we're doing HIV cure research here, and we're doing some of these things. But you spoke about the assays you used. For the Western blot, you actually specified it. But for the RNA detection, when you were doing the follow-up from the negatives, you didn't say. Can you please tell me what detection kits you used to follow to make sure that they got infected because they didn't seroconvect?
So we were doing Western blot because we started treatment. So first of all, we are using Biorad.
No, the Western blot I got, it was on your slides. But for the negative cohort, you tested with RNA until what?
The idea was just to see whether the Western blot profiles of the early treated was going to be the same as the late treated. And basically what we see is that whereas everybody who is late treated becomes positive, the early treated, they don't seroconvert and they remain Western blot negative. I'm not sure whether I'm answering.
Yes.
She's asking for the method you use, right?
No. Before they got infected.
Yes.
So you had people who were negative and you were following them till they got infected. At that stage, to find the acute infection, what assays do you use to find
RNA.
Yes,
we are using RNA because RNA test comes up fast before antibodies. So if you really want to detect very early acute, what I'm calling hyperacute infection, the RNA test is the best.
I'm okay with all that. The genes you were targeting, what gene were you looking for at that stage?
For the RNA?
Yes.
For the RNA we use...
Because that's the most difficult part for me.
P24.
P24.
Yeah.
Yes. Okay. All right. Okay. Thank you. Then secondly, those who you said did not seroconvert, are there people still in the cohort after all these years who have not seroconverted?
The people who?
The seroconversion. So you showed that among those who were treated early, some did not seroconvert.
Yes.
At a point. But I'm asking, this is a cohort you've been following for almost 10 years.
Yes.
Are there still people from the beginning till now who have not seroconverted?
Yes. We do have people who have not seroconverted and have been in the cohort for almost 10 years.
Okay.
We have lost some to follow up, but most of the people in this cohort, we still have access to them, and they come to the clinic 3 times a year, and so we are able to continuously follow them and see that they have not seroconverted yet. If they're taking their medications, some have defaulted on medications, and actually they became seropositive.
Thank you very much.
Okay.
Thank you for your presentation. I believe the big men and women have asked deeper questions into the sciences of the work.
But you're also a big
in my
also ask you a big question.
yes, so in my little mind, I want to ask with regards concerning the stigma of HIV, because in your submission you mentioned that HIV is still one of public concern, which is very sensitive. But we all know that in our part of the world, if one is diagnosed of HIV, a lot of stigmatization comes around the person. And I remember when I was in level 100, I had a friend who was diagnosed of HIV, and we don't know how it happened, but the information got out there, and she was being stigmatized, and at the long run, she had to commit suicide, and she died. So I want to find out how...
Don't laugh. You can, at attempt suicide and not die.
I'm sorry. I'm sorry. So I want to find out with your patients, do you offer regular guidance and counseling session for them before, during, and even after? And how well is your patient's confidentiality as an HIV advocate? Let's say I come to you that and test and I'm positive, and maybe you know me very well. How well am I safe with you with my information? And also you mentioned that sometimes when you test your patients, at one point they are positive. They come to test again and they are negative. So due to the alleles. So I want to find out that when you test on the first time, do you mention to the patient that, oh, you are positive? Or you keep on doing various tests to be sure before you administer drugs to the person? Because if you tell someone the person is positive, it can reduce the person's lifespan from 100 to 0. So how do you go about it? Thank you.
So one of the
These are big questions.
Yes. Yeah, actually, one of the problems that a talk like this doesn't do justice to is the incredible people who work in this cohort. We have an incredible team of community-based people who have established such a good and powerful relationship with the women in our cohort before they get infected and during infection, so that these people feel like they are family. And there's no other way to describe it. I've gone to, I told you we offer a 9-month training program, socioeconomic empowerment. I wish I had time to show you some of the videos of the graduation ceremonies of these women when they are graduating. It's such a beautiful celebration. So, yes, of course, there is a lot of stigma around HIV. We do have very strict guidelines on how to protect confidentiality. And the team have just really done an incredible job of counseling individuals such that even the women who became HIV positive when they're in this cohort, nobody in their group, and we recruit women in groups of 30. The one in their groups did not even know that somebody seroconverted. And some of them have come forward later and said, I cannot believe that you got HIV when you are in our cohort, because we never knew, nobody knew. And so it's actually an incredible program. Let me just stop there because of time, but we do protect confidentiality, we do a lot of counseling, we do all HIV prevention strategies, because our primary goal is to try to actually first prevent HIV infections.
Thank you for the insightful talk, and now I choose to commit social suicide by asking a statistical question. I was wondering throughout some of your talks, actually, when you see a reduction or not a reduction of whatever measurement, what would be like the clinical effect size that you would consider relevant? And I ask that because you have a fairly large sample size, and then often things show up significant, although they might not be relevant. In some of those plots, it seemed to be very relevant. So that what would be the relevant effect size usually for the different measures, A, and B, have you thought about putting, especially the time series measurements that you showed on the later slides, into something like a mixed model to really, rather than just stratifying in early treated versus not early treated arm, to combine that and really see a difference and use several factors as covariates and do more like a multifactorial analysis?
So if I got your question, your first question correctly, just asking what is clinically relevant in terms of viral load reduction, and I think there have been many studies that have shown that a log difference in viral load is usually clinically relevant. So somebody with let's say 100,000 versus 10,000 tends to be clinically relevant in terms of their disease progression. But in terms of the models, I'm not quite sure that I understood your question about putting it in a multivariate model.
We can talk later.
We can talk.
Yeah, at lunchtime, yes.
We can talk, but yeah.
Yes.
I'm a virologist, not a biostatistician, so.
Yes, please.
Okay. Thank you very much for such a wonderful and excellent presentation. My question is about the multiple viral infection in one of your patients. So during the multiple viral infection, after the 1 year antiretroviral therapy, did it suppress both variants? And also, yes, that's my question.
So multiple variant transmission, by the way, this finding that there's only one single variant or a few that are transmitted is not really novel. It's not new to us. We are not the first ones to find this. There are many other studies have published that only a single or a very limited number of variants are transmitted. And people have also shown that if you have multiple variants transmitted, usually that's bad clinically for you. You tend to progress faster. So multiple variant transmission is not good. And actually multiple variant transmission usually happen when there is a sexually transmitted infections. So if somebody has a sexually transmitted infection, it tends to relax the genetic bottleneck so that there is much more diverse viruses that are transmitted. And women, by the way, are also more prone to getting multiple transmissions for reasons that are not very well understood. It could be something to do with the microbiome. I'm not sure that I answered all your questions, but
during the break, you can
yeah.
get more.
So,
yeah, Peter.
So this reminds me of something I was thinking of when you were showing the data. Did you see sort of like clusters, infection clusters within your cohorts?
No.
Okay.
We have actually tried to look for infection clusters to see is the virus coming from, is there like epidemiological linkage? And I have to say we haven't looked in great detail, but we always align these sequences to see, and we haven't seen any clustering. So this seems to be independent transmissions that are happening within the community.
Yeah, so the impact of early treatment is very clear. The question is how can national and global control mechanisms mitigate the early detection and hyperacute treatment, or initiate the treatment early on for the general population?
I don't think, so our study is a research study. It's not really a public health strategy, and I don't think it can be testing everybody regularly, and it's just not feasible. It's not cost effective. So we do recognize that, and we are not really recommending this as a public health strategy. This is a specific study, proof of concept, because we had the money, but also because we had good ideas about what it might achieve, and if we can demonstrate that it works, it could inform HIV cure strategies. But we are not really saying that this should be a public health strategy, because it will be very, very difficult and very complicated to test everybody on such a regular basis.
Yes, so I have one question, a very quick one. Out of curiosity, you mentioned that the reservoirs are established very early on in the infection. Yes, that's one. And that once it's established, it's very difficult to do the latency reversal to get all of them and then effectively cure the HIV. But my question now is that you mentioned in your presentation that for the ones that got treated early, after you started the treatment and then you looked at the reservoirs that they had, you noticed that the reservoirs reduced with time. And then for the ones that you started treatments late, they did not reduce. So my question is, if you're not doing any latency reversal and the reservoirs technically are supposed to remain the same, then how come for the ones that you started treatment early, you see the reservoirs? Of course, I'm expecting a lower reservoir because you started early. But why does that lower reservoir still reduce with time? Is there an idea as to what is happening?
So I think, there is a reduction of the reservoir. First of all, I have to say, we have only, the data that I was showing was only after follow-up for 1 year. So it's very limited time of follow-up. But there are studies that have been done where patients have been followed over a long period of time, even up to 10 years and more. And actually, what they have shown is that the reservoir does reduce, even if you start treatment in chronic HIV infection. The problem is that it reduces very, very slow. The decay of the reservoir is very, very slow. It's almost flat, but it goes down over time. So, but if you start in acute HIV infection, somehow that decay seems to be a bit faster. It doesn't mean that it eliminates HIV, but it is certainly much faster than somebody who has started in chronic HIV infection. And I think your first question was about...
if you were adding latency reversal to what you were doing in any way.
You're adding what? Latency reversal agents. Oh, latency reversal, yeah.
Because you didn't mention that. I was just asking that.
You can't add latency reversal. You can only do it for someone who is infected, right?
Yes. So I was only asking that because of the fact that you saw the numbers reduce after the treatment. So I wanted to know if maybe post-treatment you changed it maybe midway and then you saw that decline.
The one thing I have to say about latency reversal, by the way, is that there are many latency reversal agents that have now gone into clinical trials and they have not worked. So a lot of latency reversal agents, they seem to work in vitro, but when you put them in patients, they don't seem to be doing a very good job. So I don't know whether this will be the case with our latency reversal here, but some cells seem to be in deep latency. And we haven't yet figured out how to make cells that are in deep latencies to start producing virus. So this is a very active area of research. People are trying to develop better latency reversal agents.
Thank you.
Okay.
So,
yeah,
this is a follow-up to Colin's question. I know that a lot of the self-testing kits, for instance, are more antibody-based. But if you were able to address the cost issue by having self-testing, then this would be a viable approach, right?
Yeah. I think the problem with RNA testing is that it is expensive, but you are right. Just as we have rapid COVID tests, we could have rapid HIV tests where if, for example, you have engaged in, let's say, risky behavior, you can go and test. And I think it would help from a public health perspective, but we need the costs for RNA testing to come down for that to happen.
Maybe a LAMP-based...
Or a LAMP, yes.
Okay, last question.
Thank you very much for the nice presentation. So I was just wondering, have you or have anybody in your circles in this research done this study?
We can't hear you. Is the microphone?
Can you hear me? So I wanted to ask if you have done this study also in a co-infection setting, like because other studies have shown that, for instance, helminth is able to induce bystander immune response, for instance, the virtual memory CD8 T cells. So have you done this study in co-infected population, let's say in helminth endemic areas, and do you think the outcome would differ from what you're saying? Thank you.
So this study, we do it in, it's called Umlazi in KwaZulu-Natal. It has a lot of, people have a lot of co-infections there. As I mentioned, some of them have STIs, some of them have parasitic infections like schisto, and so on. So it's a poor community, let me put it that way. So there are a lot of co-infections, including TB, which is very common there, although because this is a young group, most of them don't have TB. But yeah, we haven't really investigated properly, and maybe next time if you invite me, I will talk about the other work that we are doing in terms of the factors associated with HIV acquisition, where we have shown that the vaginal microbiome can predict who gets infection. So women who have lactobacillus deficient microbiome are much more likely to acquire HIV infection. We published this in Immunity a couple of years ago, a study led by Doug Kwan in our group. But that's another topic altogether. But the issue is that co-infections do play a significant role as well.
Okay, Matt, last.
Okay. So my case, I'm asking for an expert opinion. Throughout the talk, I believe that you are concentrating on HIV type 1. But on this part of the continent here in West Africa, we have both HIV 1 and HIV 2.
Yeah.
So the interventions you have suggested, and some of them are in clinical trials, do you think someone who has both HIV 1 and 2 infection, they can work the same as you have demonstrated here?
I'm actually smiling because I can't see. Yeah, but I'm smiling because I'm looking for one of your colleagues. Yeah, because he had a project that we reviewed a couple of months ago in a Research Academy, where he wanted to look at HIV 1 and HIV 2. And the short answer is that we don't actually know whether it will work in the same way. So I think we need to test both for HIV 1 and HIV 2. HIV 2, as you all know, is a slightly different virus, but it actually might be more difficult to cure HIV 2 because perhaps it has even more deeper latency than HIV 1, although that's just speculation. But certainly this is research that should be done.
Great. So
thank you.
So, Peter, over to you. Yeah?
All right. So, once again, I'm between you and lunch. We're a little behind schedule. Actually, I'll sit over there. Okay, so we're a little behind schedule. So for today's presentations, you have 1 minute to present your abstract, well, to present your topic for people to come to your poster. So without much ado, the first Turbo Talk will be Aaron Adomenu.
Good day. So I'm Aaron, and my topic is on development and utility of a SARS-CoV-2 pseudovirus assay to screen for compounds as well as antibodies against entry inhibition. So during the pandemic, there was a quest for finding therapeutics against SARS-CoV-2. So my work sought to develop an assay that could be used to find compounds or neutralizing antibodies against this virus. So basically, for my results, I developed the SARS-CoV-2 permissive cell line. Then I produced my pseudovirus, as well as using this platform to screen for compounds and plasma samples for entry inhibition. So to find more about my interesting findings, meet me at poster 1 so that we can talk more about it. Thank you.
Okay, so I'm going to call Elizabeth W. Bugasi, and while she's presenting, the others should also get ready so that we can move fast, which will be, after her will be Tosin Yetunde Sembadejo and Barbara Boache, Jokam Zun Alexandra Lindsay. So, start.
Oh, I didn't know I was short. Hello. Good day, everyone. I'm sorry. It's supposed to be because there were no allowed for transition. So I know we all miss the times where bacteria were actually susceptible to antibiotics, where we were able to treat diseases that were caused by these bacteria. But now these bacteria have actually gained resistance to these antibiotics, which is actually sad and alarming because it's difficult to treat the diseases that are caused by these bacteria. So what the study sought to do was to see if calcium could be the unsung hero that is going to come to the rescue of humans in terms of antimicrobial resistance. I bet you don't want to miss the interesting findings of my research. So I'll meet you at poster number 7. Thank you.
So Tosin, is she here? Okay. Che. And Lindsay, get ready after her.
Good morning. Okay, so we all see these numbers, COVID numbers, in the COVID era. This was a very difficult time for us. And we remember how the nose mask gave us some level of protection and we're all comfortable with. However, what we did not know is that our sense of protection may have been contributing to certain things that we did not know, like certain pathogens there that may have contributed to these numbers. We don't know how that happened. So please, we have found a lot of things or a lot of pathogens there that may have caused a lot of things to us. Please come and find out how your nose mask was protecting you or if it was causing other things you are not aware of. Please come to poster number 25 and see what was happening to you. Thank you.
Well, as he gets to the podium, Steve, get ready.
Ladies and gentlemen, I had a dream, which became a vision, and now a mission. Just like Professor Chibale, I want to see men of African descent considered in pharmaceutical companies with data produced from Africans. And today, I give you a ray of hope. For the first time on the continent, we have DNA methylation profile of Africans. Please come to poster number 29 to see what we found and the novel markers that we identify for prostate cancer aggressiveness. Thank you.
Thank you. Stephen gets ready. Alberta and then Angela, please be prepared.
Right, so I guess I could feel a bit special because I'm the only one coming to tell you something about the brain, so schizophrenia, bipolar disorder. And also, everyone seems to be talking about protein coding genes. I'll tell you about non-protein coding genes. So I consider this to be small molecules with big impact. These are microRNAs. So we screened this from patients with schizophrenia, bipolar disorder. And we got a number of candidates. And from these, we also observed differential impact of antipsychotics on their neuron and also astrocytes within the brain parenchyma. So many things. I'll simplify things for you. So just come to poster number 32 and let's have fun. Thank you.
So, after Angela, there will be Jacob Krekudong.
Good afternoon, everyone. My poster is about the effect of SARS-CoV-2 infection on cancer-like phenotypes and cytokine expression in vitro. We focused on this because we all know that the SARS-CoV-2 infection was associated with cytokine storm. And one other big thing that we also know is that the receptor that the virus recognizes and binds to has a very wide tissue tropism, whether diseased like cancers. Another serious thing is that the disease was severe in comorbid patients, which also include cancer patients. Even though there was a lot of reports on how mortality was increased in comorbid patients like cancers, we did not know what actually happens at the cellular level. So visit poster number 35 to see what our work exhibited concerning that. Thank you.
Angela, before Jacob. Oh, just sit there.
Hello. My poster is on the molecular serotyping and virulence of Streptococcus agalactiae and cultured tilapia. So basically, Streptococcus agalactiae is a potentially zoonotic pathogen causing disease in deadly bacterial diseases in humans and fish, such as tilapia. And unfortunately, the indiscriminate use of antibiotics in our Ghanaian aquaculture industry is posing a threat of multiple drug resistance and vaccine failure due to serotype switching. And in fact, our study has really found alarming information about possible serotype switching and virulence, major virulence factors. So if you want to know more, please visit poster 49. You won't be disappointed. Thank you.
Jacob Kweku-Donko.
My work is about refocusing the effort in finding malaria vaccines using non-falciparum species. So we managed to screen non-protein putative gene from non-falciparum species on pregnant women from Mamobi and Kwon to see antibodies levels in them. So meet you at poster 42.
Thank you. So next up, we have Joseph Nto Anobel, followed by Prince Burak and Akins Ablode. So the two of you should get ready while I'm presenting.
Good afternoon. My name is Joseph Anobel, and I'll be speaking on the topic comparing naturally acquired immunity to malaria-specific antigen between Ghanaian children with HBAA, HBAS, and then HBAC genotype. So basically, we know that malaria is a disease of clinical interest, where and sickle cell has also been sickle cell trait has been found to have protection against malaria. So during the asexual states of the malaria parasites, the merozoites usually infect the RBCs with their surface proteins. And since they have a lot of their surface proteins, they switch their surface proteins to evade immunity. So what I'll be looking at is that we'll be looking at the antibody responses between the people of different genotypes and to the various specific antigens. So I'm going to look at the malaria crude antigen, the MSP1, and then the MSP3. And the next one is I'm going to also look at the trend between increasing, antibody response and increasing age, as well as the differences between the antibody response and the gender. And then the last one is going to be the differences in the antibody response between those who tested positive and then negative for malaria. Thank you.
Thank you.
So I'll be at poster number 43.
So Prince Burak. Oh, Barak. Is that Prince?
Good day, ladies and gentlemen. I'd like to keep this short. My name is Prince Baruch, and then my presentation is on prioritizing domains and peptides of Plasmodium falciparum merozoites associated protein as vaccine candidates. So we know that effective vaccines are imperative to the fight against malaria, and as such, we'll need to investigate more parasite proteins to be able to identify targets. So previous studies have shown promising results using the PFMAP protein, and then we seek to prioritize vaccine targets because there'll be convenience for more robust protection and antibody production. So we sought to map monoclonal antibodies specific to the PFMAP protein to be able to identify their binding proteins, aside many other objectives. So you could pass by poster 44 for more insights on.
All right, Akins Ablode. And while Akins is coming to the podium, Josie Na Akla Okai, get ready, as well as Isaiah Deborah and Mami Ekwia Akwa.
Hi. Yeah, so my work is basically on the use of mosquito coils. So usage of mosquito coil has about 40%, it's about 40% in Ghanaian homes. But the use of these mosquito coils to control mosquito has another downside, and that is the formation of resistance by the mosquitoes. So this work is basically about exposing the mosquitoes to mosquito coil in the lab. So when you take a look at what we have here, the up side of the figure is about the resistance, below it is the dwindling of the resistance. So it's about exposing the mosquitoes first to mosquito coil, then the deeper colors up shows the development of resistance, and below shows that that's the control group. The control group show the mosquitoes do not get so resistant after they're exposed to mosquito coil. So taking a look at the graphs below, the second graph to the right is an expression of enzyme activity that results in a detoxification of insecticides when we expose the mosquito coils to the mosquitoes. I think this is insect biology. You'd have to take a lot of mental trip to understand this. But to get it more clarified, you can meet me at poster number 45. Thank you.
Thank you. So, Josie.
Hi everyone, my name is Josie Okai, and I'll be presenting on molecular investigation of Plasmodium falciparum infections diagnosis in Ghana. So malaria continues to be a global threat, and one of the factors that is hindering its complete eradication is misdiagnosis. So misdiagnosis affects the treatment, control, and management of malaria. Now, when it comes to some malaria diagnostic tools, we have the laboratory methods such as microscopy and RDTs. And then we also have the molecular methods like PCR, the RT-qPCR, nested PCR, multiplex PCR. We also have serological assays like ELISA. So for my project, we realized that there were some discrepancies in microscopy results and RDT results from experiments that were carried out in the field. So we decided to use PCR as a standard to confirm and then compare these two diagnostic methods to find out which one was giving us more false positives. We found some interesting results, and you can come check it out on poster 51. Thank you.
Isaiah Deborah.
I'm Isaiah Deborah, and the title of my project was about insecticide resistance and whole transcriptomic profile of Anopheles phoenistus population in Western Kenya. Anopheles phoenistus is one of the dangerous vectors of human malaria, and its resurgence in Western Kenya was partly attributed to insecticide resistance. So my study sought to elucidate the resistance status and underlying mechanisms. And I've got some interesting results out there. Kindly meet me at poster number 56.
Thank you. Mami Ekwia Akwa. And Araba Mels should get ready, along with Diana Asandem and Dovi Ignatius.
Good afternoon, everyone. Let me take you back to the peak of the COVID-19 pandemic, where there were daily increase in cases and death tolls. What we sought to do was to find testing strategies. So we have the RT-PCR, which is the gold standard. But the challenge with that was that it had a long turnaround time for results, about 24 to 48 hours. And even with the introduction of the RDT, which was faster, for some tests, you couldn't distinguish between past and present infection. Currently, the global death toll is about 6 million people. So what if we could have decreased the death tolls by increasing testing capacity? What if I told you that there was an instrument that combined the accuracy of the RT-PCR and the speed of the RDT? So see me at poster number 64 for more. Thank you.
Thank you. Is Araba here? Go to Diana.
This is not my slide. However, type 2 diabetes mellitus is a metabolic disease that results in complications such as neuropathy as well as kidney diseases. Existing drugs that work by activating glucagon-like peptide receptor have become ineffective and sometimes cytotoxic. So there is a need for effective drug agonists that can act as anti-type 2 diabetic compounds. So my research also the traditional methods existing are time-consuming as well as laborious. This is where machine learning comes in to save the day. So our aim was to train so in this project we trained 5 machine learning models to predict agonists of glucagon-like peptide receptor that can act as anti-type 2 diabetic compounds. So if you look at our results, our best performing model, when evaluated across the matrices accuracy, recall, sensitivity, as balanced accuracy, were all above 90%. Random forest was our best model. And when our best performing model was tested on 9 FDA approved drugs, 6 out of 8 was predicted active with a higher confidence. So this is our server on figure 3, which shows exenatide as active. So you can meet me on see my presentation. My presentation is
poster number 91.
Number 91.
All right. So now we're only 4 minutes behind schedule. Is Constance here? She was supposed to present yesterday. Okay. So that means that we can go for lunch. And we'll be back here. I think we'll all agree that we've had a fantastic morning session. And we'll come back here. Just like yesterday, we're going to have the lunch break, followed by the poster presentations. And please do visit our sponsor stands. They are a little bit forward from where we are sitting. Please do go there. I'm sure they have pens and sweets and things like that, as well as things that you might want to buy. And we'll come back here at 3:20 for the last session of this year's conference. Bon appétit.
Recording stopped. Recording in progress. Recording stopped.
throw this in. It's okay. I needed to talk louder and I couldn't talk louder. I need to do like this, difficult. Oh God. Maybe I need to stand this way.
apology. This is okay. It's okay. It's okay. It's okay. Last one. Okay. Thank you. Sorry.
Hello. Good afternoon, and welcome back from the lunch break. So as we wait for the others to join us, we will take a presentation from Caramore International and MES Equipment Limited. They deal in reagents and also some biomedical consumables. So without much ado, I invite Stanley Alifo, if your presentation is ready. In fact, they are one of the sponsors, they are one of our sponsors for WRC 2023. So they want to show us some of the stuff that they deal in. Thank you.
Good afternoon. Okay. Good afternoon, ladies and gentlemen. Okay. Thank you for this opportunity. I'm with Caramore International and the MES Equipment. So we would like to present to you what we do as an institution. So I have Caramore. We are the local suppliers of Caramore International here in Ghana. So what they do is next slide, please. Okay, so I'll just basically continue. Once the slides play, then I'll pick it from here. So we are into... Okay, thank you. All right, so we are associated with logistics, paperwork, clearance and delivery, advice, and then export packaging, and then a third-party logistics. So that is, we here as MES Equipment, whenever there are items ordered by anybody from here, from Caramore, when it comes to Ghana, we work on the item and then we deliver to the various clients. Our services as MES Equipment here is, we deal in scientific equipment, and then those are Agilent products. These are Agilent products like HPLC, which we use for spectroscopy, and then AAS for HPLC for chromatography, and then the AAS for spectroscopy. We are also into laboratory equipment, and then we do after-sales services. So that is, when we supply you with the instrument, we have a long lifespan of the instrument. That's my team. Okay, this is our stand. If you go out there, you see a Caramore banner, a very big one, with our items displayed over there. So basically, that is what we do. No. Please, let me go. Okay, so we are also into training on instruments. So analytical instruments such as HPLC, AAS, MPAES. We do training on this instrument for every researcher who is interested in using this instrument. We also do deal in UV-Vis, that is for protein analysis. And then we do bioanalyzers as well. We also help with exemption documentation. That is when you want to clear your goods and then your goods are in, and then maybe you are struggling with processes with customs to clear your goods to be delivered to you. We can help you, and then we can advise on how to do all this documentation. Thank you. Please, any questions? Okay.
Okay. Thank you. My question is, I just want to know why it takes so long to get our reagents when we order. Sometimes.
Okay.
Because I know
I was
some of
expecting
the-
this question.
Some of the master students, they ordered it about 6 months ago and they still haven't received. They're supposed to submit their thesis in the next 2 months. So
Okay.
Can you do something about that?
Yes, we can. So, with this issue, I think with the beginning of this year, there was an issue with exemption processes with customs. That is, there was a bill by Parliament to have these issues, let's say, in a high fold of money payment. So what is happening is we are supposed to get exemption documents, and then now the government has put some kind of taking off most of the taxes from these documents, which is increasing the price of exemption to be paid on a shipment before clearance. So then, if you don't get your processes right and then you don't get your exemption, you are not going to be grant a permit to clear your item. So then, we are supposed to go up and down, chase a lot of people, go into a lot of offices, either rather than the previous online approval. So that takes a lot of time. But now it has been resolved. So right now, I can boldly say, whenever you place an order, if you place an order this month, I give you 4 to 6 weeks to receive your order.
Hey.
Very sure, very sure. So if I have my exemption ready and then items are being sent, I have even like a week or 2 to clear it out. Okay, I think there's someone here.
Does that mean that you've reduced the extent of bulking up orders?
No, okay, so this is how it happens. When procurement, the WACCBIP procurement has an order, they put together the order and then send to Karamo for purchase. So as and when the order has been received, all those orders are put together. Readily available orders in stock are being sent straight away. Those that are not available are being given time frames. So there's an email to update you on what is coming per shipment, so that you get. Thank you.
All right, that means our logistics problem is almost solved. Yeah, we tick that box. And this is, I hope everyone enjoyed their lunch. I hope they didn't eat too much, because we're going to have food in the evening, so we should basically enjoy this last session. I know we'll miss the signs and everything, but this is the last but not the least session of the entire conference, and it's also the second section dealing with drug discovery mechanisms and resistance. And I'll let the 2 chairs for this session take it away. Dr. Irene Amwako-Usu and Dr. Sam Dodu.
Hello? Okay. Oh, good afternoon once again. So this afternoon for our plenary talk, we'll be looking at anti-cancer drug discovery. And for this, our speaker will share with us how 280 paces can be used as druggable DNA damage response regulators in neuroblastomas. So, ladies and gentlemen, let's welcome Joachim Sian for the talk.
Good afternoon. So my name is Joachim. I studied in this department, finished in 2012, and went to Sweden for master's, continued with my PhD, and now I'm doing a postdoc in Belgium in Ghent University. So my PhD training was mostly in cell culture and cell signal, mostly wet lab. Now I'm doing bioinformatics, but I also do my own validation if I have to go back to the bench to do this. And I would like to thank the committee for actually giving me this opportunity to present my work. I've also tried to be in the WACCBIP conference every other year, so I was here in 2021 and I think 2018 or 2019, so it's good to be back. So my talk is on RUVBL1 and 2 as novel druggable DNA damage response regulators in the NMIC regulatory network in neuroblastoma. So neuroblastoma is a pediatric cancer. It's the most common cancer of infancy and also the most common extracranial solid tumor of childhood. This disease accounts for about 15% of all childhood cancer-related deaths. The tumor mainly occurs in the adrenal gland. So adrenal gland is located on top of the kidney, and the tumors are found there, and also along the sympathetic chain, so the nerves that run parallel to the spinal cord. So you can have tumor arising from the neck region, in the abdomen, also in the pelvic area. So the tumors originate from neural crest-derived nerve cells. So during embryogenesis, we have these neural crest cells are just some transient cells that are actually found in the dorsal part of the embryo, so the green. And you have neural crest cells that are in the cranial region, and these cells develop later into the cartilage and the bones that make the face. And also, some of these neural crest cells can develop into the heart, and also, so the cranial or the trunk neural crest cells would develop into these sympathetic neurons, and also the chromaffin cells that makes up majority of the adrenal gland. And it's believed that neural crest, some precursor cells that are derived from these trunk neural crest cells, we call them the hepatoadrenal cells. When they fail to properly differentiate into either chromaffin cells or the sympathetic neurons, they can continue to proliferate and may later develop into neuroblastoma. So you may ask, what causes neuroblastoma? Neuroblastoma can be found even in children that are born 1 month old. Sometimes it can be diagnosed even while the fetus is still in the womb. When parents go for ultrasounds, they can detect neuroblastoma. And we know that cancer, in general, is a disease of age. As you grow, you have mutations, and at a certain age, at a certain time, with the right mutation permutation, you may end up developing cancer. So these kids usually, fetuses like 1 month old, they haven't grown that much. They haven't had that time to actually develop these kind of mutations. And that is the case also for neuroblastoma, that it's usually not caused by point mutations, but rather it's caused by numerical and structural chromosomal alterations. So you can have a deletion in a part of a chromosome, then you lose a whole bunch of genes, or you can have a gain, that is certain regions you have multiple copies, or you can also have some translocations associated. We also have numerical chromosomal alterations where you can gain a whole chromosome, extra copy, or you lose a certain chromosome. And so, but we do have some few recurrent genes that are mutated in neuroblastoma, and that is anaplastic lymphoma kinase, ALK, associated with about 10%. We have PTPN11, also known as SHIP2, which just, they are not very common, but these genes are the most recurrent ones that are mutated in neuroblastoma. Yes. Yeah, so I would like to just show you. So this is something we did from our lab. So this is the profile of a neuroblastoma patient. If you look at the genomic profile. So if you are on this line, that means you have 2 copies. And as you go, if you have, you move up, that is a gain. So 17q gain is usually the most common one. So you can see this patient has a gain in the 17q region. You have a loss in 11q, which is also quite common in neuroblastoma. So this is typically what the genomic profile of a patient or neuroblastoma tumor looks like. High-risk neuroblastomas account for about 50% of all cases, and about 50% of these patients will relapse even after giving them heavy chemotherapies, radiotherapy, and also with surgeries. These patients will relapse, and usually when they relapse, only 20% will end up doing well. About 80% of them will die anyway. And then you can also imagine chemotherapy basically is like a poison. So you say you try to kill both the patient or the tumor, but you hope that the tumor dies before the patient, because anything that is actively dividing in the person will be affected by chemotherapy. And these kids, like a 1-month-old baby or 2 months, they are actively growing. So giving them heavy dose of chemotherapy actually leaves them with a lot of deformities and also life-threatening toxicity. So there's a need for better treatment or better drugs so that we can improve survival and also curb the long-term toxicities that are associated with this. And NMYC is it's one of the genes that is frequently amplified in neuroblastoma, and we know now that it is very important in the pathogenesis of neuroblastoma. It's associated with about 25% of neuroblastoma cases. And so our research aim mainly is to identify novel signaling nodes within the NMYC network for therapeutic targeting. And the reason why we did this is because MYC, even though it is important in tumorigenesis, targeting it directly has been quite elusive. So we want to find alternative approaches for targeting this pathway. And so what I did was I did a signature score. So I used the cancer hallmark gene set, about 50 gene sets, and then you score for activity. So basically what I found is that, again, this NMYC V1 target has the highest signature score in neuroblastoma, particularly the high-risk cases, which indicate that this gene or the pathway is very active in neuroblastoma. And what I did then is to find out what genes are inside this network, and we know that we have about plyosome, which is highly deregulated in neuroblastoma. It's also found in this gene set. What is notable, interestingly enough, is also connected with MYC. So we became interested to understand what RUVBL2 does in neuroblastoma. RUVBL2 and its related protein, RUVBL1, they are members of this ATPase associated with diverse cellular activities. And the 2 proteins form a complex, and in this complex, they acquire ATPase activity. On their own, they have no ATPase activity. And so this protein complex is involved in 2 major protein complexes called the pachyosome, basically like a chaperone, and they help to assemble other protein complexes, and also the AT-chromatin remodeling complex involved in chromatin remodeling. There are other functions such as DNA transcription and DNA repair proliferation that is associated with this protein complex. It's been shown that IUV interact with c-MYC to regulate transcription and also interact with E12 and amplify the transcription of E12 target genes. So the question is, how important are these genes in neuroblastoma? And the complementary analysis, we show that high expression of IUVBL1 and 2 is associated with poor prognosis or poor viral survival. This is a univariate analysis. There are other biomarkers that we know to be associated with neuroblastoma, like MYC amplification. Patients that have amplification of this gene will usually do bad. Children that are older than 18 months, when they have neuroblastoma, they also do worse. And then stage 4 tumors also show poor prognosis. But if we correct for this other covariant, RUVBL1 still stand as independent prognostic markers as indicated by the hazard ratios. So the story here is that RUVBL1 and 2 are independent prognostic biomarkers for high-risk neuroblastoma. We have to validate this. Are these genes really important for neuroblastoma? And the answer is yes. So basically, if we inhibit the ATPase activity of this gene, and we use a drug called CB6644, just inhibit the complex, and you treat the cells over a period of time, you can see that this is the control, and you can see that cell proliferation is inhibited in 5 days. And if you do this continuously, maybe for 2 weeks, you can still see complete abrogation of cell growth. And mechanistically, we want to understand what is going on. And here, basically, we are only inhibiting the ATPase activity, so the total protein of IUV1 and 2 still stay intact. But what we saw is that the ATM and ATR, phospho-ATR, these are proteins that are important for DNA damage response. You can see that over time, the protein levels and phosphor levels go down. What is quite interesting is phospho-check1. Phosphorylation of this protein on this side, as serine 345, is indicative of replication stress. So what we observed is that when you treat the cells for 24 hours and 48 hours, you increase phosphorylation on check1 at these sites. And this we observed in 4 cell lines that we tested. But then on the 3rd day, the whole thing collapsed. So basically, when you treat these cells, they are under replication stress. They want to resist, because if you don't correct this stress, they acquire a lot of DNA damage and the cells are going to die. So they are fighting back by upregulating this check1 phosphorylation to help them resist this stress. But after 3 days in the presence of the drug, they cannot. So the whole thing collapses, and immediately you see gamma H2X, which is a marker for DNA damage. So you have a lot of DNA damage breaks, and if the cells sustain a lot of breaks, what happens? Apoptosis, as you see with Cliff caspase 3. So you can see that these markers come up only when the replication resistance actually collapses. What we also saw is that MYC or c-MYC, which are the most potent oncogenes studied in neuroblastoma, also go down in this case. So the story here is that IUVB1 and 2 may be acting as replication stress resistors in neuroblastoma. So basically saying that they actually help to help the cells to resist replication stress, and as you take them away, the cells undergo or they become exacerbated in terms of replication stress. We also show that by inhibiting IUVB1 and 2, basically the cells are arrested in the S phase, as this is the control DMSO or cells, parental cells without anything, but with the treatment, you have a lot of cells more accumulating in the S phase, and this is it makes sense considering the replication stress and also the DNA damage intensity that is taking place. So we wanted to understand on the home transcriptome what is happening when you inhibit IUVB1 and 2. So we show that, yes, we did a bulk RNA sequencing, and if you compare the treatment versus control, we can see a lot of genes going up and then a lot of genes that are also going down. The question is, what are the pathways that are affected by this gene set? So we did a gene set enrichment analysis using the hallmark gene set. And as expected, we see these MYC and E2F targets that appear to be the most depleted pathways. That is, the genes that are going down are mostly enriched for these pathways. As I showed earlier, we saw apoptosis in terms of Cliff caspase, and so we can see the apoptotic mark. So the genes that are upregulated are mostly enriched for apoptosis and also P53, and so we also know that the apoptosis is induced through the P53 pathways. We asked the question, what transcription factors are influencing these transcriptional changes? And we saw that indeed most of the transcription factors that are highly enriched are MYC, E2F, and MYC-N, which is more typical for neuroblastoma. We also saw SOX11, which is shown to be also important in neuroblastoma. So in general, we identified that MYCs and E2Fs are acting as transcriptional effectors for IUVBL1 and 2 signaling. We also, as I talked about, ATR. When you inhibit IUVBL1, you can see that ATR phosphorylation is going down, DNA damage response is going down. And in our lab, we showed earlier on that when you inhibit ATR, you basically can abrogate neuroblastoma growth even in animals models. So I asked the question, what happens when you combine inhibition of IUVBL with ATR? And the green is the combination of the ATR inhibitor BA and also the CB, which is the IUV inhibitor. You can see in some cases here we have a synergistic effect. In other cases we have some additive effect. At the biochemical level, we can see that when you inhibit, when you have the combination, you have increased DNA damage, which is accompanied by increased pulp cleavage and apoptotic mark, and also caspase 3. So basically, a combination of these two drugs increases apoptosis in neuroblastoma. In summary, we've shown that RUVBA1 and 2 regulate making, and making will regulate cell progression and proliferation. But making also has the tendency to induce replication stress, which is not good for the cells. The same making then forms a multimer that shields store replication forks, which are usually the product of replication stress. At the same time, RUVBA1 also positively regulates ATR check 1, which helps to regulate replication stress. So when you take this away, all the replication stress response have been blocked, and you have exacerbation of replication stress. Excessive replication stress will lead to DNA damage, and the consequence is apoptosis. So in this work, we show that RUVBA1 and 2 are prognostic biomarkers in neuroblastoma. They are also acting as therapeutic targets, and we hope that this can be further investigated for potential clinical translations. I'd like to acknowledge my lab, Professor Jimmy van de Eden, and also my lab mates, our collaborators in Sweden and in Belgium, and also the Swedish Childhood Cancer Foundation, Nuna Barnes Cancer, who is funding my postdoc in Belgium. So I have a 4-year postdoc grant, 3 years will be in Belgium, and I have to go back to Sweden for the 4th year. So thankful for the funding. Thank you for listening.
Thank you. Thank you, Joachim. Questions?
I guess it's very clear. Well, so we do have some genetic predisposition. So this gene ALK, those ones that are familial, that is genetically, is very about 10% of the cases. And this gene, anaplastic lymphoma kinase, is associated with about 90% of those familial cases. So there's some genetic predisposition to it. Yes.
Yeah, so, okay, there's a question at the back.
Thank you for the interesting talk. I'm still not in this topic. So I have a pretty basic question, and that's about like the genetic disorders that would cause this type of cancer. Would they occur all over the body, or would it be localized?
Have to.
Yeah. So you mentioned there are chromosomal disorders causing this type of cancer. Would it be at which level of development would they occur? Would it occur essentially in every cell, and it's just expressed in the glands? So would the whole body be affected essentially, or would it be something localized?
Yeah, so that's a good question. So basically, mostly neuroblastoma, when patients have neuroblastoma, they don't have any other genetic disorders. So from that point, you can assume that it is more in specific cells. But there are also some genomic diseases that when people that have those kind of disorders, they have high risk of developing neuroblastoma. So we have some kids that have this craniofacial deformity, and usually it's associated with chromosome 11q deletion, which is also very common in neuroblastoma. So whenever children have this type of disorder, they have very low stature and their face, things are not properly organized. Those children, they normally put them under surveillance for neuroblastoma.
Let me maybe as a follow-up, maybe you could take not just the tissue sample from the cancer, but like also from the skin or from some blood cells, and see would they have the same chromosomal disorder or not, so that it would essentially even be able to have prenatal screening for this type of disorders and eventually have early treatment or gene therapy or something as a therapeutic?
Well, I didn't get a full question, but
well, you could take you could check whether not just from the from the cancerous tissue sample, but also from healthy tissue samples and from blood cells and so on, whether they have the chromosomal disorders in pretty much every cell around the body.
No. So this is mostly within the neuro. So if you take maybe in the blood or any other tissue, usually they have normal profile. So most of the aberrations, apart from those kids that have these genomic syndromes, apart from those ones, about, I would say 99% of neuroblastoma cases, only the tumor has this aberrant chromosome profile. Normal tissues have normal profiles.
Okay, thank you.
Yes.
Is there another question? Okay.
Yes. So I just want to ask about the biomarkers you identified. Are they specific to this type of cancer or other, it has been implicated in other cancers?
You mean the gene I presented or the other markers?
Okay, I saw you said you got two.
So we have age. So kids, so this is more particular with neuroblastoma. Kids that are, so if a child is diagnosed, let's say first month, those kids usually, they undergo what we call the spontaneous regression. You don't even have to treat them. They just observe them and the tumor just disappears. So if you have a neuroblastoma before you are 12 months or 18 months, you most likely going to have good prognosis without even treatment. But if you have tumor after 18 months, usually your progression is, you have very poor prognosis. And then the stage, of course, if you come with stage 4, usually then you have metastatic disease. And you know metastasis is what kills. And then the next one is so we have and then making amplification, which is also associated with poor prognosis, yes. And these are very particular to neuroblastoma, yes.
Okay.
All right, thank you very much, Joachim, for the wonderful presentation. So, we're going to presenter. There's a slide change of topic. President Seth is going to present on DNA-based assay to monitor resistance to anti-malaria therapy.
Okay, good afternoon. So actually, I'm not going to present on DNA-based assay. It's on RNA-based assays. So I would like to give the introduction. So I was happy today about the last keynote speaker. I think at the end of his presentation, he talks about diagnosis. And during the question section, Collins asks about how we can extend diagnosis to the general public so that we all can be doing routine diagnosis. Then I think it's from the answer, we realize that it's very difficult because of cost. But this is something very important that we need to do. So Dr. Kwashi proposed that maybe we can use LAMP to do that. And that's exactly what we are working on. We think it's possible for us to develop diagnostic tools for diagnosing various infectious diseases. So that's what I've been working on. So I'm going to show you something. But before that, I think I had an introduction talking about the drug assays that we did. And so in terms of malaria, currently we diagnose with microscopy and RDTs at the hospitals. And these, we know that they have several limitations. So there's a need for us to move to the nucleic acid-based assays. And preferably, we want to use RNA-based. But the type of assays that we are developing now, when you look at literature, it's mostly based on DNA. So we are proposing that maybe we should look at RNA, and the RNA gives several advantages, including monitoring drug resistance. Okay, so to do this, we first did a study. We recruited children from 30 communities within Hoho municipality, and when you look at the prevalence of Plasmodium species, you can see that it varies. Even though it's within one municipality, you can see that there's wide variation in the prevalence of Plasmodium species. And that's interesting because you would expect that within the same environment, there shouldn't be so much variation. But we see from 0 to as high as 82.5 prevalence. So that's interesting. So those are positive, some of the children. So this, the number was 1,697. So those as were positive. We selected 104 58 of them. Then we treated them with ACT. Specifically, we used artesunate amodiaquine. So when we treated, we were expecting, because the general assumption is that ACTs are effective. So we're expecting that it should clear. But then after day 3, with PCR, we can detect some of the participants harboring parasites. And this is a high number, about 60% of them. But when you quantify with qPCR, you see the parasite load goes down. So by day 3, we see a reduction in the parasite load by at least 88%. So it shows that, yes, the parasite load is down, but we still have some individuals harboring this parasite. With microscopy, we are unable to detect these ones. So perhaps you call them submicroscopic infection. So what we did was to look at the genotype. So usually when you're infected with Plasmodium species, when you take one species like Falciparum, we have several genotypes. So we look at the different genotypes. So you can be infected with more than 1, sometimes 4, sometimes 5. So this refers to as the multiplicity of infection or the complexity of infection. So when you look at before treatment, we have about 4, up to 4 different strains infecting one person. Then when you treat, by day 3, we see it goes down. That's what is expected. So it looks good. The interesting thing here is this particular, the B. So usually when we do this drug assays or the surveillance, we don't look out for this genotype to see whether there's differences in their response to these drugs. So this work, we looked at the genotype, and we realized that for the 5 genotypes that we looked at, you can see that the K1, FC27, and the 3D7, after 3 days, which is the red bar, you can see some of them come up. So we were detecting those strains, but then for the other ones, we didn't detect them to mean they were cleared. So that could mean that some of the genotypes may be less, especially in our papers. Okay, so this one cohort. So another cohort, what we did is we followed them up for 70 days. Then after the 70 days, you can see the parasite load after treatment. By day 7, it goes down. With microscopy, you don't see anything. You get 0. So it means all the parasites are cleared. But with PCR, we can still detect some at least up to 18%. Then when you follow them up for up to day 70, we see increase the parasite load or parasite prevalence increases, then it falls by day 70. And the same for microscopy, it increases from day 14, then it falls. So okay, so are we saying this is new? This is not new. So when you look through literature, there are several publications to this. And the question is that, are these microscopy, when you look at all these papers, they have microscopy negative but PCR positive. So there is a review here, and this review puts it that it's likely that these submicroscopic infection could be viable asexual parasite that's below the level of microscopy, or it could also be coming from gametocyte, because we know the ACTs that we use, they are not too sensitive to gametocyte. So the parasite that we're detecting is coming from gametocyte. Another possible observation is that maybe the DNA that we're detecting, because it's PCR, it could be DNA that's released by dead parasites. So it's not really live parasite. So what's the challenge? The challenge that now we still don't have tools to clearly tell what's happening when you treat and you get some microscopic infection. So that's why we propose RNA-based assays. But before that, like I said, to show that perhaps it's not really that it's coming from parasites that are dead, we took samples that were diagnosed as microscopy negatives and also positive from the hospital. And you can see that with the negative sample, which is represented by the red dots, and the positive by the blue dot, you can see that of the 200 samples that we look at, 65% of them tested PCR positive. What's interesting is that when you look at their CTs, the lower the CT, the higher the parasite load. And usually at CTs less than 15, you would expect very high parasite load. But these samples were diagnosed as negative at the hospital. So it's interesting. It just shows that. So I think that it's not really they are below the detection limit of microscopy, but there are other factors accounting for what we are seeing. Now, based on this, that's why we propose our RNA work. So if with RNA, we will be able to monitor, because RNA is less, it has higher quantity, meaning we can target with high specificity and sensitivity. And so it's less stable in that when you treat and the parasite is cleared, RNA will be rapidly cleared from your body, unlike DNA. Then using nucleic acid-based amplification assays and with the biosensor. So these are two different assays that we are looking at. With the nucleic acid-based amplification, you amplify your target before the detection. With the biosensor, we can directly detect our target without the need for amplification. Okay, so LAMP assays, are they new? They are not new. In fact, LAMP has been in the system for the past 20 years. So this is the first point-of-care LAMP kit that was granted, it was given authorization for emergency use during the COVID time. And the cost, so this was developed by Pfizer. The cost is about $75. So as we discussed, it's expensive. And we cannot be using such kits for routine diagnosis. Okay, all right, so like I said, this is the only approved diagnostic kit that we have. So to solve this issue, for us to do wide surveillance for various infections and monitor drug resistance, and also detect early HIV infections, we put together this project, different partners coming together, and WACCBIP is here. So we have African partners and also some other partners from Europe. We came together to put together the project which refers to the Open LAMP RT LAMP project, and the focus is for us to establish RT LAMP here in Africa and make it very cost effective and easily accessible. Okay, so to do this, we focused on establishing the assays here. So we've already established the assays. I'm sure we've heard a lot about protein expression and purification. Exactly, that's what we did. So with the plasmid, we express our enzyme, purified, then we lyophilize. So what we did is lyophilize for us to easily transport it to our the steady sites. So this is one of the things that we do. After successfully purifying or producing our enzymes, lyophilizing, we develop our LAMP assay. So we've developed it for malaria. We've also done for schistosomiasis and COVID-19. The interesting thing here is all these, we can see that when we compare purified nucleic acid, which to the unpurified template. So with the malaria, we use blood, system, urine, then COVID to sputum. You can see when you compare the detection limits, they are comparable. So it shows that with the LAMP, we don't need to purify our target, and that's very good for our point-of-care assays. So the good thing here is that we are using lyophilized reagent, crude template, then the assay is also based on color change. So we just use a dye, and at the end of the reaction, if there's amplification, you see a color change, and that makes it very good for point-of-care application. Okay, right, so after we've successfully developed the assay, so the different partners that I showed you, we came together. So we've been doing a number of field testing, at least I know we've been out for about 5 different communities, and this is the group. I'm sure yesterday we heard about Andy's presentation, so this is Andy and also Max here, then other African partners, and we came together, we've been doing some field testing. This is a team processing the samples for the assay on-site. So with this one, we did on-site testing of the assays. So the challenge with the assays is because it requires electricity, because we need to heat the lamp, we need it to about 65 degrees. So you can see we had a lot of equipment on site, and this still is not feasible for point-of-care application. So the next step, or which is what we are doing now, we are looking at developing a disposable acid, which is electricity-free and uses chemicals for heating. So basically, we know some of these chemical reactions, they give off heat, exothermic, they give exothermic reaction. So when you have iron with magnesium ion with water, when you add water to it, it produces heat that is okay for us to do our reaction. But the heat, you do it in the presence of what we call phase-changing material. The phase-changing material has a melting point at the preferred temperature. So we do the assays at 65. So the phase-changing material we use has melting point at 65. So at 65, once this reaction heats up to 65, the phase-changing material amplification. So this is what we are working on now. So it's just going to be a small kit for us to do our assays. Okay, so the other thing which I spoke to you about is the biosensing in the platform. So this is what I've been working on for some time now. So this is a chip that I use during my studies, PhD study. So it has, this is the sensing unit, very small, it's about 700 micron. So what I did is to immobilize DNA. So this is DNA-based assays. You immobilize DNA, then you're able to, when you add your sample, you're able to capture and do your electrochemical analysis and able to get your results. So it's a very simple assay. The good thing about the sensing platform here is you don't need to do amplification. You don't need to do purification. Just by adding your sample to it with few lysis buffer, you're able to get your sample, you're able to detect your target. Okay, so this work, I published last year. So what's the next step? So the next step is that we want to develop this into a multi-electrode sensing platform, which allow you to detect multiple pathogens at the same time. So we have modified electrodes. So the initial one was only one. We've modified into 5 different electrodes. So with this, we can detect 5 different targets. So you immobilize your DNA probes or RNA. So here we're looking at RNA. So that's the next step. So we immobilize our RNA probe, and we'll be able to, once we add our sample, we'll be able to detect the different pathogen of interest. Okay, so this project was put together by different partners from Africa and in Europe. So I'm very grateful to all the partners I presented on their behalf, and very grateful to my supervisors, Professor Godawanda, Dr. Yawanewe. The drug assay, the first part that I presented on, it's work that I did with, we did with Dr. Dinko. Then, so I'd like to thank everyone. Thank you for your attention.
Okay, thank you. Thank you, Felix. So we'll take questions, please. Any questions or suggestions?
Yeah, so Felix, I want to ask you a question. So is your RNA assays yet to be developed, or you're, because I didn't see any data on
so
that.
this one, the ones that I showed, the LAMP assays are based on RNA.
RNA.
Yeah.
So are you using capillary blood or blood spot?
Sorry.
What sample are you using for your detection?
The sample type?
Yeah, sample type.
So the sample type, like I showed you, with the COVID, you use sputum. With the schistosome, you use urine. So we are detecting schistosome hematobium. And with the malaria, we use blood.
Yeah, so with the blood, how are you preserving it?
How are we processing it?
Preserving it.
So this point of care, so once you get a sample, you just do it. So all that we did, we went on site, and we take the sample and we do the assay the same day. So we just pick 2 microliters of the blood, add it to water just to dilute it. Then we pick 2 microliters into a reaction mix, then heat. That's it.
That's it. Okay. Thank you.
How big a problem is this? How big a problem is it?
How big is it?
Yeah, there must be some relationship between this type, the number of targets, i.e. the number of kits that you think, or sorry, the number of tests that you would have to do versus the cost to make the whole, versus the problem in sheer humanity of how many people are affected. Well, I just don't get a feeling for, you know, what's the size of the problem?
Yeah, okay, good question. So to me, in our environment, let me put it that way, in the environment is very important, because up to now, you know, even in the hospitals, the hospital settings, we don't have good diagnostic for detecting just some common malaria that we've been with for years. So we here, like I always say, we depend on, like when COVID came, we're depending on the other countries, the other continents to get these assays running. So it's very important that we develop them. We just don't have good diagnostic kits for developing most of these infectious diseases. So that's the first thing. In terms of the number of the pathogen, that's the reason why, so for the last part of the LAMP assay, what we are trying to do is to do multiplexing. So per assay, we are going to detect more than one pathogen, because sometimes you go to the hospital, this work that we are doing is acute fever illness. There are several pathogens that can cause it, but we usually look out for only malaria because of lack of diagnostic kits. So if we have kits that can detect multiple pathogens, then we can detect maybe our target within a single assay. So it's good we have kits for detecting multiple pathogens, because in our environment we have several pathogens that can cause diseases with similar symptoms.
Okay, here.
Thank you, Felix, for your presentation. My question is, with your heat, your energy problem, have you considered solar?
Okay, sorry.
Please, did you get the question?
The question again.
So have you considered using solar panels for your LAMP assay?
Yeah, so for now we've considered battery, we're looking at battery powered. So the one I showed you from Pfizer is battery powered, and also the chemical heating. It's something I have in mind, but then I feel like we can start with the chemicals and the battery, because that's accessible. We are working with some partners working on similar platforms, so they've done that. So we want to use that one. If it works in the near future, we can look at solar power. It's something very good that we'll consider. Yeah.
Okay.
Felix.
We'll take 2 more and then that'll be it.
Thanks, Felix, for the nice presentation. So I wanted to ask, in the introduction, you made mention of the fact that you wanted to circumvent the idea that you might have dead parasite DNA and also gametocytes. So the question is, I should repeat it?
Speak louder, please. Sorry.
Okay, so the question is, in the introduction, you made mention of the fact that you want to circumvent the issue of having to detect dead parasite DNA as well as gametocytes.
Yeah.
So the question is, does this LAMP assay deal with that?
Yes. So when you are with RNA, you should be able to, because that's why I said RNA, it's also nucleic acid, but it's less stable. So once the parasite is dead, it's easily removed from circulation than DNA. So it should be able to solve that challenge.
Yeah, but then the LAMP is also detecting DNAs, right?
Sorry?
Isn't the LAMP also detecting
So
DNA?
these are nucleic acid based, as you decide whether you want to detect RNA or DNA. So we are detecting, you just have to select, but you just need to add reverse transcriptase to your reaction mix.
Okay.
So it's better we are going to select, the one I showed is based on RNA, but like I said, most of the assays that we have that have been reported based on DNA.
Okay, thank you.
Thank you. We'll take 1 more and then.
Okay,
the
Felix,
rest.
please, will the assay be able to determine mixed infections?
Yeah, so with the lamp, because it's based on, currently it's based on color change, it should be able to, because nucleic acid based amplification, with your specific primers, you should be able to pick the target of interest. But then it's all based on the detection method. So with the lamp, because it's based on color change, in a single reaction tube, you can't detect different pathogens, right? You won't be able to distinguish it. But then if we are doing it in a different tubes on the same platform, like multiplexing in different tubes on the same platform, then you'll be able to detect multiple pathogens. Then with the sensing platform, that one, because it's specific nucleic acid, you'll be able to detect mixed infection, because each panel or each electrode would have probe specific to a particular infection.
Okay, thank you very much, Felix. Okay, so our next presenter will tell us how probiotics can help reduce anxiety and depression in mouse models. So we'll have Righteous for that. Righteous, thank you. And you have 12 minutes. I'll notify you after 10 minutes.
Hello, good afternoon. Okay, my name is Agua Righteous Kwiku, and I'm presenting on the antidepressant-like effects of probiotics in chronic unpredictable mouth stress-induced depressive and anxiety-like behaviors in mice. This is an MPhil project that was led by Aliu, but due to unfortunate emergency, he was not able to be here today. So as a co-investigator, I am taking over today. Okay. So for the background, stress can be defined as a physiological response to physical and emotional demands. When all the demands of the situation exceed all available resources, we all have been stressed. Imagine ordering for your stuffs and waiting for 10 weeks, 20 weeks for it to be delivered to you. But we thank God for Caramo. We have our things very quickly. So depression is a stress-like syndrome, and depression may be precipitated due to uncontrolled persistent chronic stress, due to inflammatory cytokines in susceptible individuals. So somebody might ask, the guts and probiotics, is there a correlation with the brain? So pertaining to this work done by Foster et al., we get to see that the gut-brain axis is a bidirectional communication network between the gastrointestinal tract and the central nervous system. So these people here show this kind of relationship between our guts and our central nervous system. So then what are probiotics? Probiotics basically are live microorganisms which, when ingested, infer some kind of benefit to us. So what was the need for this work? So probiotic-based therapy can be proposed as an alternative treatment for various neurological and neurodegenerative disorders such as depression. So the aim of this study is aimed to explore the antidepressant-like effects of combined probiotics in chronic unpredictable mild stress and induced depressive and anxiety-like behaviors in mice. Now, if you should look at the action of probiotics, probiotics are able to produce tryptophan, and tryptophan is a metabolite. Now, tryptophan is a precursor for the production of other neurochemicals such as serotonin, which is responsible for our flight or fight. So the production of tryptophan helps in the production of neurochemicals. So the objective for this study is to assess the effects of probiotic treatment on depression-like behavior induced by stress using behavioral tests. So over here, we are looking at the physiological aspects of this, and also to assess the effects of probiotics treatment on hyperregulacia induced by stress. That means we are looking at hot or cold temperature, which can also induce stress. And also to assess the effects of prolonged stress and probiotic therapy on liver and kidney function as well. So for our work, what we did was that we had a commercial probiotics, and after getting the commercial probiotics, we cultured. And after culturing we had a bifidobacteria, and we also had lactobacillus species as well. So after this, we made a formulation, and after that, it led to administration of this to the mice models. Now, for the formulation, we had a higher concentration, which is 10 raised to the power 8 CFU per ml, and a lower concentration, 10 raised to the power 4 CFU per ml. So after administration over some number of... So there were ethics concerned for the work, but however, we had our ethics from the University of, from the Health and Allied Sciences, and also from Noguchi Memorial Institute of Medical Research. So we had 63. So group 1 is a control group, and these group of mice were not stressed and were fed with normal saline for the course of the study. And we also have group 3, which was our positive control. But for group 3, they were stressed and given fluoxetine. Fluoxetine is a natural antidepressant. So this was our positive control. For group 4, we had stress mice, but however, they were given high dosages of the lactose mice, but however, we're given different concentrations and of the lactobacillus species, different concentrations of bifidobacteria, and different concentrations of the mixed species between lactobacillus and bifidobacteria. So we utilize a chronic unpredictable mild stress protocol for this work over here. Adaptation, we measured for their SPT, and SPT is sucrose preference test. We also measured for the weight. After the 14 days to the 28 days, they underwent chronic unpredictable mild stress. We put them through some stresses, some mild stresses conditions. However, we didn't treat them, and we didn't treat them with any probiotic. And during every week, we took both SPT results and the weight. So this served as a basal for the measurement of our SPT levels and also other behavioral levels as well. So after the 28 days, these groups of mice went through treatment. The group 2 were given their fluoxetine. Group 1, it's a control group, our negative group. They did not go through any of these stress conditions. So in the end, during the 56 days, we measured for SPT again, the weight again. We measured for forced swim test levels. We also measured for tail suspension tests and open field tests. And these mice were sacrificed. The sera was extracted from them, and biochemical analysis and other tests are being done currently at the moment. Okay. So for our results, looking at weight loss, Zhu et al. Proposed that the higher the stress level, generally the higher the stress level in mice, the higher they do, or the higher the amount of weight they do lose. So in our research over here, we found out that the first group, which was our normal control, the control did not go through any of the stress conditions. And it can be seen over there, after acclimatization in the first 2 weeks, there was an increment in their weight across board up to the number of days, up to the 56 days. It can also be seen over here that the second group, which was the stress group and the group that were fed with the normal saline, had an opposite effect of the negative control group. That means their weight declined as the study progressed. So, for the third group, which was the group given antidepressants, it can be seen over here that they had an increment in their weight because the antidepressants were actually counteracting the effects of the stress conditions that we were giving them. So, it can also be seen that the high concentrations, that means that is 10 raised to the power 8 CFU per ml, concentrations of probiotics that we were giving them over here, led to an increment in their weights over the years. And you can see that this study is looking at the dichotomy between different dosages, looking at 10 raised to the power 4 and 10 raised to the power 8 CFU per ml. So over here, we can say that, and we can attest to the fact that, according to literature, for a probiotic to be administrable, or for us to administer probiotics, it has to be in the concentration of 10 raised to the power 6 to 10 raised to the power 9 to elicit their effects. So we can see that 10 raised to the power 8 elicited the effects of preventing weight loss. So due to this, we can say that these probiotics actually do prevent weight loss in mice. After the 56 days, this was what was observed. So we also measured for sucrose preference test, and this was recorded as anhedonia. Basically, anhedonia is a condition that happens whereby people don't like to have pleasure. They feel for pleasure. So over here, we measured for anhedonia, and it could be seen that the group that were stressed and they were given normal saline over here had a very, very, very low preference for sugar, for sucrose. It could be seen that the group with the antidepressants over here had a very, very high preference for sucrose. It could also be seen that the lactobacillus high had a very, very, very high number of weeks, and the stress conditions applied to them, and what we were measuring, which was sucrose preference test. Now, these SPTs and other tests that are done are... So, with respect to helplessness, we all know that helplessness is a kind of, or it's an example of when someone is helpless, the person might be stressed. So we wanted to mimic the same conditions in the mice model as well. For 6 minutes to see whether they will be immobile, or we will see whether they would have some level of resistance towards this. So this is a physiological study as well. Okay. So over here, the immobility time for the control group was quite high because the control group had not gone through all these stress processes, and hence there is actually high level of fight or flight hormones released in them. So they would not want to drown, and hence put up some kind of resistance towards the stress conditions that we are giving them. And also we could see that over here, the VHS group, the stress group that were not given any treatment, that were given normal saline, were very, very immobile for a very, very long time. But to prevent their drowning, we had to scoop them out to prevent that. Okay. Yeah, we had to scoop them out. We didn't want them to die. Okay. So the group that were given fluoxetine, which is the antidepressant, it could be seen that they also had a relatively low immobility time. That means that the antidepressant was working. So we looked for helplessness. We looked at immobility time. We also looked at swimming time. Yes, and we also looked at climbing time as well. So all these things, these results, I were able to prove that, yes, probiotics induce some kind of, as I said, it leads to the production of tryptophan, which can produce a precursor for serotonin, which is involved in flight or fight situations. Okay, so we also test for, they don't want to even be the center of attraction in most cases. So we also mimicked that same condition with respect to the humans as well in the mice models. So what we did was that we placed them in a cage over here to see how many hours or how many times. So when we did that, we found out that the normal group, the control group that were not
You're right, Charles. Okay. Reverend, is a question from Reverend.
Okay. Yes.
Okay. The mic.
All right. Good presentation. So you mentioned that you think that tryptophan is produced as a result of the probiotics, but you haven't really showed anything that suggests that. Maybe you could give the mind some drug that block the conversion of tryptophan to serotonin and see whether you can actually block this effect.
Okay, so thank you so much. But it's actually an outstanding work that we are looking at the moment, whereby we are looking at the neuro pathway and everything that has to do with the production of tryptophan and the cascading pathways that involve that.
Thank you. So, Reverend,
I didn't get the question whether that is similar to what I'm asking. So, one, the probiotics, very likely, of course, would have worked in some way in inducing the production of the tryptophan, right?
Yes.
Is that what you were responding to?
Yes, please.
Okay. So, what you are saying is that basically you haven't dealt with that yet.
Yeah, it's an outstanding work we are looking at the moment. At the moment, we are looking at the biochemistry aspect of it, and we are looking at the histology aspect of it as well. So this is the physiological response to these stress conditions and how the probiotics help in reducing anxiety and depression levels.
So eventually you will be
yes, please.
measuring the levels of tryptophan and so on.
Yes, please.
Okay. So I was just wondering, first, has there been any work done to demonstrate what the mechanism of action of these probiotics are?
Yes, please. There have been some review papers actually on the mechanism of action of these probiotics. But however, these are different strains of probiotics. The ones that we used were Bifidobacterium and Lactobacillus species as well. So we are seeing that there might be different mechanism of actions that we might not know of. So it's an outstanding work that we are going to look at.
Okay. I was just also wondering, sorry. Did you, as part of your control, could you have inactivated these bacteria and use that to demonstrate that indeed it's the live ones that are acting?
So we actually done some tests on the ability of the probiotics to colonize the gut microbiota, and over there we mimicked some conditions of in silico. We mimicked some conditions of the gut to be able to see if they will be able to live in these conditions, and it went quite well.
Okay, so with the very last question. All right. How did you also confirm that the induction was successful?
Okay, so for the induction of the stress, we use the CUMS protocol, which is a chronic unpredictable mild stress protocol. With this protocol, the important thing about this protocol is the unpredictability of the stress. And the stresses conditions were basically maybe tilting their cages upside down, food deprivation, water deprivation for some small number of...
Then how did you confirm that the induction was successful?
So how we confirmed the induction was measuring the whole process of the stress.
Because of time. Thank you very much, Righteous. This really proved that you were part of the whole study. Presentation for the whole conference is now, and we have in an alternative route to fungal resistance. Becky, you have the floor.
Good afternoon. And I thank the organizers for the opportunity to speak. Heterochromatin provides an alternative route to resistance. It's commonly found in the environment, and it's an opportunistic fungal pathogen, mostly to cause about 600 deaths per year. Here I'm showing Cryptococcus infection in the brain of an HIV patient, emergence of drug resistance, and a WHO fungal priority pathogen list that was recently released. Here we see that Cryptococcus is right at the top of the critical group, showing how important this pathogen is. So when it comes to drug discovery for fungal pathogens, it's quite difficult because they are also eukaryotes, just like the host. And as a result, there are only 3 main classes of antifungals available for treatment. Azoles are the most commonly used. And for Cryptococcus, there is also a nucleotide analog, which is flucytosine, that is recommended to be used in combination with amphotericin B up to a year. And this overuse leads to resistance. Here I'm showing increasing azole resistance, both in plants and animals since their introduction in 1977 to 2017. We can see a large increase in resistance. So there is a mechanistic and structural overlap between clinical and agriculturally used azoles. Here we can see fluconazole, which is used in the clinics, which is a triazole, having a triazole counterpart used in agriculture. The azoles target ERG11, which is involved in ergosterol biosynthesis, and the action of azoles alters membrane fluidity and allows influx and prevent growth of fungal pathogens like crypto. Normally what we're used to when it comes to mechanism of resistance is genetic mutations that increases target overexpression, increases efflux, and also inactivate the target. In crypto, there is also this reversible mechanism, which is aneuploidy, where they increase copy numbers of certain chromosomes or an arm of a chromosome. Here I'm showing increase in copy number of the left arm of chromosome 1, where you find the ERG11 gene, increasing the gene dosage. But we think there is more to drug resistance. We think that epigenetics could also cause drug resistance. And for my work, I'm focusing on methylation of histone 3 on lysine 9, H3K9 heterochromatin mediated gene silencing. So methylation of histone 3 on lysine 9 results in chromatin compaction and represses underlying genes. This mechanism occurs by a read-write mechanism, and we have methyltransferases that put the methyl groups on histone tails and readers that bind to propagate the mark and silence more genes nearby. There are also erasers, which are demethylases that remove the methyl groups. In S-POMB, which is a model yeast that is commonly used in our lab, it's known that heterochromatin can be transmitted through multiple generations in the absence of the demethylase. Recently in our lab, we showed that when S-POMB is exposed to caffeine, we're able to isolate unstable resistant cells, and the resistance is mediated by ectopic heterochromatin at different loci in the genome, which I'm showing here, which are not found in the wild type. And we also found that these unstable caffeine-resistant isolates are cross-resistant to various azoles. So we wondered if this phenomenon could also drive resistance in clinical isolates in fungal infections. We know that in Cryptococcus neoformans, genome instability plays a big role in pathogenicity, and also it has the orthologs of H3K9 methyltransferase. So the question we asked was, does heterochromatin contribute to resistance in clinical isolates of C. neoformans? So we came across this paper where the authors were trying to figure out the mechanism of resistance in some clinical isolates of Cryptococcus from HIV patients in Tanzania. They had 20 in all. Out of that 20, 12 of them had aneuploidies, which could explain the resistance, but 8 of them did not have any aneuploidies and also did not have any genetic mutations to explain their resistance. And we also know that this kind of resistance is reversible when you remove the drug. So we got these 8 non-aneuploid isolates and hypothesized that heteroresistance, they will have ectopic heterochromatin, which we might be able to link to drug resistance. Sorry. So basically what the original authors did was to obtain CSF from HIV patients before they started fluconazole therapy and plated them on YPD only and YPD modified with fluconazole. And also after fluconazole therapy was initiated, they went also for samples, CSF, and plated them on YPD. Crypto that grew out of the CSF, we've obtained them and I've done CHIP6 on them. Patients are identified by patient numbers. So here, I'm showing 4 of the non-aneuploid patients that I've worked on, and we can see that there are no obvious aneuploidies in their genome. So I went ahead to do H3K9 ChIP-seq, and we realized that at several loci in their genome, there is ectopic heterochromatin in the clinical isolates that are not in the reference H99. And this, I'm showing this particular one occurs in most of the isolates that I have, but some could also be unique to a particular isolate. What was very surprising to us was that even in isolate that has never been exposed to fluconazole, still had ectopic heterochromatin compared to the reference strain And also, I realized that these isolates, clinical isolates, are cross-resistant to agricultural azoles, including enoconazole and tebuconazole. So what we thought might be happening here is that probably the isolates were pre-exposed to environmental azoles, which caused the formation of ectopic heterochromatin, or after infection of the patient, responses in the host and stresses cause formation of ectopic heterochromatin that were able to confer resistance. So knowing that this kind of resistance is reversible, I took one of the patient's isolate 18 and passaged it on for 16 days on non-selective media without any fluconazole and kept the isolate and re-challenged them after 16 days. And we can see that after 16 days, there's considerable loss of resistance. They revert back to sensitivity to fluconazole. I've done H3K9 ChIP-seq to look at the H3K9 profiles, and we see that in the original isolate, we still have the ectopic peak, but in the reverted isolate after 16 days, H3K9 peaks goes back to almost wild-type levels. And I've confirmed this with Q-ChIP. ChIP-Q PCR. So this is the reference strain. This is the original strain, which still has it. And this is the reverted strain after 16 days, which has lost the H3K9 mark. And these are the genes found underneath this loci. So the next question we asked was, does host conditions influence H3K9 formation? And with this, we're collaborating with Joe Heidman, and I'm working with Maribel. So what Maribel did was to infect biopsy mouse that have not been treated with any fluconazole with Cryptococcus neoformans, and after 16 days, harvested organs, plated the lysate on YPD plates only without any fluconazole. I got the isolate that emerged and did a drug test and also H3K9 ChIP-seq on them. So the isolates that were used were the reference H99, the original heteroresistant isolate, and the isolate that has lost resistance. And the questions that we asked was, does H3K9 ME heterochromatin appear in the reverted isolate? And could host conditions also cause formation of H3K9 islands in the reference and result in fluconazole resistance? So when I did a drug test, what I realized was after passing through the mice, the isolates essentially lose resistance. The colonies from mice, they lose resistance as compared to the original one that still maintains the resistance. And it was the same for the reverted isolate and the reference. H3K9 ChIP-seq, as usual, shows the presence of the ectopic peak in the original patient 18 isolate, whilst the rest recovered from mice do not have the peak. So it's the same thing from here. When you lose resistance, you lose the H3K9 peak as well. So having it at the back of our minds that H3K9 represses genes, I obtained gene deletion mutants from a collection for genes that are underneath some of my H3K9 peaks, and these are color-coded here. We found that these gene deletions confer resistance, which would mimic the action of H3K9, what it does. So in conclusion, we've shown that clinical isolates of seniorformans exhibit novel ectopic H3K9 chromatin islands that are lost upon loss of resistance, and deletion of genes near or underneath H3K9 heterochromatin confers fluconazole resistance. And so we think that heterochromatin-mediated repression of specific genes within or near islands may impact transient fluconazole resistance. I'd like to acknowledge my lab, my supervisor, Professor Robin Osher, and the rest of the lab members, our collaborators, and our funding partners. Thank you.
Thank you. So because of time, we'll take just 2 questions because of time. 2 questions or suggestions. Okay, Keith, and then, yes. Thank you.
Thanks. That's a good talk. So you briefly mentioned the genes, and then I'm just wondering what their functions are and how they account for the resistance in your isolates.
So generally, the genes that are underneath the peaks that disappear are involved in stress response. That's the general feature of these genes, that there are genes underneath pigs that do not disappear, and those ones I'm thinking are involved in genome defense, but those that go and come are mostly involved in stress response. Okay, the actual, I can mention one of them. Okay, so some of them are involved in mitochondrial functions, and one of them is in a stress response pathway, which it's essentially suppresses the stress response. So I'm thinking that if that gene is suppressed, then the stress response pathway is actually activated. So it's a lot of genes. I'm not able to keep all of them. Sorry.
All right.
So, so this is very nice. Before I ask my question, though, I'll make a comment. You shouldn't restrict a student at the end of a day because her seniors can't stick to time earlier on. So my question is, if your answer to the last question was that you sort of think that there might be a mechanism of de-repression, right? Then one imagines that you would be able to, say, downregulate that gene with a mutation in its promoter or something like that, and therefore get solid immunity, which would be genetically transferred to generations, not just an epigenetic effect. Have you thought of sort of testing your model in some ways like that?
As in, we having genetic mutations also contributing or collaborating with the epigenetics to bring about resistance? Yes, I've seen papers in CEREBCA that occurs, and I've done work in POMB where there's ectopic heterochromatin and also a genetic mutation in a mitochondrial gene, so that also happens. But in these isolates, so far I've not seen any genetic mutations that might be relevant to that.
No, what I was meaning was that you find the heterochromatin island, which seems to be contributing. Then you go back to a normal wild-type strain, and you make some mutations in the promoters of those genes to downregulate them, and ask whether or not they are resistant or not.
Yes. For these clinical isolates, we've not done that. But for the POMB caffeine resistant, we did exactly that. Most of the unstable resistant isolates that we had, about 70% had the ectopic heterochromatin at a particular loci. So we did exactly what you're saying, reduce the expression of the gene at by manipulating the promoter level, and we actually saw resistance, caffeine resistance, and also cross-resistance to other azoles and other compounds, so that we've done.
Okay.
Yeah, so thank you so much for the presentation. So on this note, we would like to thank all the presenters for this afternoon section. It was very wonderful. I don't see Peter here. So, okay, Professor. Yes. Yes, thank you, Prof. All right, thank you so much. All right.
All right. So somehow we've managed to come to the end of the conference. We've managed to get through all those talks, and I'm sure all of you have seen all those posters. Normally, at the end of the conference, before we close, we do a conference evaluation. And this is normally in two parts, the written anonymous one. You also do an open discussion one, where we just openly criticize or suggest changes to the format for next year. So whilst we wait for the prizes to be determined, we can have a discussion about the conference before we start to close. So, can we have your reactions to the conference? What the good and what did they say? The good, the bad, and the ugly. So feel free to give us feedback. We don't. We're not going to not invite you next year if you said everything was crap. We'll say okay, thank you. Come again next year. We'll do better. And if you say everything was good, we would say come again next year as well. So it doesn't make a difference what you say. So please feel free. If you've been here previously, what has changed? What has gotten better? What has not improved? If it's your first time, what do you think? What are your opinions? So we would like to hear from you. So where's the microphone? Kristen.
Thanks. It was a pleasure being here again, like always. It's my third time. I think it's my third time.
First.
Third.
Third. Okay.
Yeah, you know how it is. The first time is a premiere, the second time is a repetition, and the third time is a tradition. What substantially improved since last year is the space for the posters and the food and the queuing. That really
you said what? The displays for the posters?
The display space for the posters improved.
Oh, the space.
Yeah.
Yeah, last year was a little cramped.
Last year it was a bit cramped, and that improved substantially. So that was great. It was also great. The catering was great, having some fruit. So those things are important, and they really improved. What could be done better is sending out the invitation letters earlier, because that's a substantial problem given. I don't know how it's in other countries. In Germany, the normal visa application time, if you don't get the express visa, is like 15 working days, which is like 3 weeks. Right, so I would suggest to send out the invitation letters already with registration, and not wait until the abstracts are, because I don't think anybody cares.
Well, you're talking about invitation letters for visas and stuff.
Yes.
Okay. All right. Normally, yeah, once you register, we should be able to send you an invitation. That's what you mean?
Yes.
Okay. All right.
Yeah. And of course, what is not in your hands is the obstacles with the visa application process. And it kind of substantially increased because they want more and more material. And yeah, that's becoming a bit more cumbersome. But earlier invitation letters would be great. Yeah. But apart from that, it was great, and it's not over yet.
All right, great. Yeah, I think generally we are going to try to start the process much earlier so that the abstracts are, reviewed much earlier and notices are given much earlier, and then all the visa arrangements, everything. So we're going to try to shift the timeline much forward so that we can have more time for people to plan their travel. So that is well taken. And I've also noted your appreciation for the food and the fruits. The fruits is a new thing. We used to have pastries for the tea and coffee. And this year we decided to be more environmentally friendly by killing plants. Anyway, yeah, this year we tried to be more healthy and use fruits. And like we're chatting during lunch, some of us were sitting talking about procurement. The interesting thing is that yesterday they came to whisper to me that the person who supplied the fruits may not be paid because the procurement wasn't done properly. So speaking of procurement, it's not only reagents that get stuck in procurement. Even the fruits you are eating, the person paying her may be an issue because of procurement matters. So, but anyway, Miguel.
Yeah, but by the way, the food is a great idea, and also it's good for the microbiome. So I think it's part of the sustainable component of of the conference. Yeah. This is my second one, and I think it was really nice. The first one was very exciting too, but like my colleague said, the first one everything looks one way, and then you repeat it, and this I think looks better. I think the themes of the conference were very interesting. There was a fair bit of diversity. If I don't recall wrong, is better in diversity than the first one. The first one, by the way, was in 2018 for me. So
2018. That was our third one. Yeah.
Well, I don't know, but there was a big lag, so I cannot judge from
definitely
in between.
Yeah.
If I can say something in terms of criticism, I think it would be an advantage to, obviously, to stick to the time. I've noticed that the speakers don't always, maybe I also was in fault for that, but the speakers don't take all the time, or they use more time than is required, which I think goes to the detriment of others. And also the chairs are not enforcing that. They are very mildly, they are not enforcing the time.
The chairs are not enforcing the time.
In there and
chairs, you are weak,
calm,
man. Chairs.
Very relaxed. And
weak chairs.
I think the chairs should be doing two things that I think are critical for the chairs. First, time has to be enforced.
We need to put a clock here next year, stop clock.
Exactly, something
so that
like
when you start to be counting down, you can see it. Everybody can see.
A timer that the speaker can see with colors, yellow, red. There are things like that that are not too complicated. And
we will do.
The second thing is that the chairs should be told they have to prepare a question.
Okay.
Because we have a few cases where the presenter, particularly a PhD student, the presenter, there are no questions.
Yeah.
And it's fine. That could be the situation, but the chair should give that opportunity. So I think that could be something that the chair should take more ownership on what they do.
Sure.
Not necessarily a good thing to put in the CV. I chaired this session, but also they did something for it. So that's a prize for being in the putting that in the CV. Yeah. So I think that will make the conference more dynamic. I think. But of course, it's always hard to, the timing in all conferences is an issue. But there are many conferences that run this very well traditionally. For example, Gordon Research conferences, at least the ones that I attend, have this characteristic of the time. FACCBIP conferences follow the time very well. It's almost everybody agrees to keep that time in place. So I think that will be a detail that can be added. It's not too difficult. And other than that, I'm personally very satisfied. It was very nice. I learned a lot. I took a lot of notes, which is an indication of interest. And there were talks that are not in my area. I don't know how my colleagues feel, but like the talk on for example, on the fertilization was a fantastic biology.
Yeah.
So it may not be related directly to infections, but I think it's fantastic. So that kind of people selected for the talks, etc., create a nice, in my opinion,
nice mix.
A nice atmosphere. I think for the PhD students and the masters, all the trainees, I hope it's been a really exciting time. But if the chairs could take more ownership, will be a major change.
Okay, good. Thank you very much. So chairs, next year chairs. We are going to be watching the chairs. We will also score the chairs. Next year, I think we should score the chairs, right? We'll give you score sheets to every session. We score the chairs. Yeah. But anyway, Stefan, are you taking notes? Where's Stefan? Are you taking notes? We have to definitely have a stop clock here, you know, so everybody can see the time. And if you go over your time, everybody will see you. Yes. Who has the microphone? Yeah. Any more comments, feedback? Mark, yeah.
Small practical comment. You're so comfortable behind the podium with the microphone that I expect you spend several hours each day behind a podium. A lot of the students found it difficult to use the static mic, and I think you should get one that hangs around the chest.
Okay. Actually, I would need my ICT team to explain, because last year, I remember that we spent a lot of money to buy a lapel microphone, which they, you know, we all agreed would be better. And we spent some money on it. I don't know where it is. Tio, where's the lapel microphone? Yes? Yes, I want, really, I want to hear about the lapel microphone.
I'll delegate my assistant to answer that.
Yes, Alfred. Alfred wants to answer.
Yeah, so the lapel mic is actually available, but most people will always demand for the handheld instead of the lapel. So we have it right here.
You didn't offer it to me. Did you ask me if I wanted a lapel?
It's there, it's right in the box.
You see, Mark, this is why I asked, because it's there. Can you believe that?
Well, my suggestion is to use it.
Let's make the options available to the presenters. What type of microphone do you want? Yesterday, I think DJ wanted to walk around with.
Yeah, so the one thing I was going to say to Mark, thanks for mentioning that. So I don't get nervous on stage, but I'm a relatively hyper person. So walking around and not being able to move the slides and talk didn't make me anxious. It made me want to cuss, and then I didn't want to do that in front of you all and actually be myself. But it's a great suggestion, and I need to use that as an excuse every once in a while when I crash and burn in front of an audience so I can blame it on the IT. So thank you.
Yeah, but please, the microphone issue, we need to sort that out. People need to be comfortable when they speak. If they want a lapel, give it to them. They want to walk around, let's do it. You don't need to be stuck here.
Yeah, I just want to agree with all of that, because short people like me, standing behind there, don't even reach the microphone. Yeah. So
And I spend the money to buy it. That's what just annoys me, because we bought the thing. All right.
So Gordon, so first of all, thank you for inviting me to this meeting. It was really a pleasure to participate. And maybe you have to take my comment with a pinch of salt, because I wasn't there from the beginning. But one thing that I missed was to see the other partners within WACCBIP, because I know that this Deltas 2, we were required to have different partners from different countries, but I didn't see, so I don't know whether there are other partners from other countries that are participating here, and I would have wanted to see how these other sites are performing, and some of the people showcased in their...
I want the lapel one, please. Yeah.
In terms of presentations and sharing sessions and so on, so as to foster that intra-African sort of collaborations, which is one of the things we really want to promote.
Yes. I think that's a fair criticism. The partners, some are here. Lagos is here, Liberia is here. But they are new partners. The existing partners didn't quite come a lot. Maria Matu is here, but she didn't present. You did a poster? She didn't present. So partners are here, just that some may not have submitted abstracts. Normally we invite people to submit abstracts. So some submit, some don't. Some submit this year, next year they don't. So the partners are here, but you're right. This year, it seems like we didn't have a lot of partner institutions presenting. So where's Peter? Peter is the one in charge of the abstract review. He's the chair of the scientific committee. So I don't know if we had the abstracts, but they were not selected to present or whatever. When he comes, he'll explain. But it's a good observation. This year in particular, we don't have as many partner presentations. It's probably also because Deltas went to sleep for a while. So the research that they had done, they had presented already, so there's no new research. So maybe from next year, we'll start to generate new data from the new project, and then we would have more partners showing up. Okay? Any more? Yes, big woman with big questions.
Okay, thank you. So, please, mine is not a critique, but I would like to say a word of appreciation to the lecturers, principal investigators, senior research assistants, the sponsors, and the organizers, and everyone who was involved in making this conference a success. And to also thank all of us.
What's your name? What's your name? Angelica.
Angelica.
You're a master's student?
No, please.
Undergrad?
I'm a service personnel.
You're a service personnel, okay. So you're an intern?
Yes, please.
Okay. Angelica?
Yes, please.
You see that, now I know her, you see, there are a lot of people here that I see them, I don't know their names. But today now I know her name.
So I would like to thank all of you for giving us, I'm talking for myself and my other young researchers, the opportunity to present our works both in oral and poster presentation, offering us the opportunity, because for me, this is my first time presenting in a gathering like this. So when I was coming to present, I was very nervous, very anxious, and during the presentation, I had a lot of appreciation, a lot of critiques, but most especially my work was appreciated, and I feel it gives me a lot of motivation to do more in the future. So thank you very much to everyone.
And thank you very much for speaking up and for having the courage to ask big questions and to speak at this big forum in front of all these big people. You're already on your way to being a star. Yeah. All right.
Yes, thank you very much. This is my first time, and I think I've enjoyed it. Maybe just two quick observations. I don't know, I think we are growing, and I believe that next year will be far bigger. So I'm wondering whether during the oral sessions, whether it's possible to have parallel sessions so that we could also free some of that time also for the posters, because I've noticed that for people with posters, the timing is said that you can't leave your posters to another person. But I think with some conferences, they have times where you are supposed to be by your poster compulsorily, then you have a time where you could optionally be there so that you could go to other places and also know what others are doing. So I suggest if it's possible, that would also be a great avenue. And also, well, I guess my bias is I am in the non-communicable disease, so I'll just appeal that maybe whatever it would take to encourage some of those in those fields to also be coming. I think that also helps, because certainly most of these diseases, inflammatory disorders, affect other parts like the brain and other places. So some of those people being here can also have the opportunity to network or even plug in their research fields into the exciting work here. But all in all, I've really enjoyed it, and I'm looking forward to next year. Thank you.
Great. Thank you. Thank you. That is well received, well noted. Yes, any other? Students, I want more student comments. If you speak, I'll designate you as a star, so that is gold dust, which can do a lot. There's a student there who wants to speak.
There's a very old student. Gordon, Let's refine the question a little bit and get some brave participants here. One of the things I want to say is it's always a pleasure to come here. I love seeing Gordon and my other colleagues, but it's really fun for me to interact with the students, right? And it's a busy venue, and so one thing the students may or may not want would be to interact with us a little more. And so maybe someone could comment on whether or not that would be useful in a venue for such, because probably the most interactions we will have will be tonight over alcohol. And those, where I come from, can certainly land us in human resources, so. It's a thought.
Yeah, so, well, it's a good question for the students. Do you feel that you had enough opportunity to interact with the faculty, both local and international? And yeah, you said no? Why not? Because they were there. Is it that you were intimidated, or you didn't feel like there was enough opportunity or time? Please speak up.
Yes.
Hold on, let me listen to the students first. I'll come to you. Who wants to speak about this issue of interacting with faculty and collaborators? Yes. Nobody wants to speak. So how would you have interacted? You wanted to interact, but you don't want to speak.
Yes, so my name is Angela, and I think the best time that we could have spoken was during the poster section. Because I remember I was talking to someone, we had just started the conversation, and we were called back in. It's time, so we had to move.
So you are saying the poster session was not enough? The time for the posters was not enough? Okay.
Yes.
Please, my name is
So
Mami.
would you rather just have a few orals and the rest to be protests? No, seriously, I'm asking. It's a trade-off. Or should we do a one-week conference? Maybe next year for the 10th anniversary, we'll do Monday to Friday. So everybody will get plenty time for their posters. We can do only like 20 posters a day. What do you think? Yes.
Okay, so my name is Mamekwa, and I think that
Who's holding the mic? Oh, okay.
I think
By the way, I hear your drawings are making waves on Twitter.
Thank you very much.
Multi-talented WACCBIP PhD student.
Thank you.
She has been drawing all the presentations into posters and putting them on Twitter. So you can check out your poster on Twitter. Tumbi, including yours. I love it. You saw it? Okay, good.
Thank you so much. I think with the interaction, you have to make the opportunity. So let's say somebody give a talk. After, if you have a break, you can make a few minutes to actually talk to the person, or I enjoyed your talk, and I think this and this. But I also think that if there could be a time to network, because if you are sitting in for a talk, you can't exactly talk to someone. If you are standing by a poster, you also can't network. So if we can get something like that, thank you.
Yeah, this time issue, eh? We wish we had more time. Yeah, I think last year, or one of the years, we had a cocktail on one of the evenings. So that it's not only those who like to go to Lodgia who get to, because the networking has been going on at Lodgia every evening, just that some of you don't come. But one of the years, we did an on-site cocktail at the end of the day, so everybody got to interact. So maybe we bring that back and do that on one of the days that we close at 5 and we have a cocktail up to like 7 or something like that. It's just, chatting and having a drink. Maybe we'll bring that back if we get some more money. Dominic, I limit you to 2 minutes. I know you can talk for 10 minutes.
I thought I'm the one. So
oh, you have the microphone. Please go ahead.
Yes.
Yeah.
So just to respond to the concern about not interacting with the collaborators, I think it's largely or partly because we do not know their background.
You don't know their background?
Yeah, their discipline. And
no, but you should ask them. That's the first entry to the interaction.
Yeah,
Anyway,
maybe,
go ahead.
I think that's a starting point, but I'm thinking that we could include it in the brochure and such that we could have read a bit about them, and so that when you are doing the introduction, because I noticed you did the introduction at the onset of the conference, and so we would have quickly connect from there. That's a quick way to.
So you want like a list of all the traveling faculty who are coming and their areas of specialization?
Something like a brief profile of each of them.
The book, then the handbook there.
No,
the brochure will be very big.
Yeah, I understand now.
Last profile is about 206 pages.
Okay.
Most of it is pictures of pregnant women. Not that he impregnated, please. Yeah. All right. So, Dominic and then Chris and Lindsay. Okay. All right. Now we have a lot of hands. Let's do it quick, because the goods are here. You have the goods. They have to print the certificate. Okay.
Yeah. It's another great opportunity, but I didn't want to talk, and I realized I have to step in. With respect to interacting with senior faculties, what I have noticed in other conferences, early in the morning, since the conference is actually starting around 9, early in the morning between, let's say, 8 to 9, there could be tables set up outside. And then also, as Francis initially suggested, we could have some information. It doesn't need to be in the brochure. It could be on the WACCBIP website somewhere. And then students could actually look at it. And then there will be a form there where they could sign up that between 30 minutes, let's say 8 o'clock to 8:30, I'm going to interact with Professor David Conway, provided Professor David Conway has agreed to be available during that. And then just a roundtable discussion where people can actually interact. And in the middle of the table, it will actually be displayed Professor David Conway's table. And then we just sit and talk among ourselves, 30 minutes each, but it should be probably earlier in the morning before the main program starts. And that will make students actually have time early in the morning to interact with the seniors. I just feel that is another way. Thank you.
All right. Thank you. Chris?
I think it's the same point I wanted to make. So it will be like chat the mentor session.
Come again?
I'm saying that it's good. It's like the same point I wanted to make.
Okay.
So a day should be like 30 minutes within the conference to just say chat the mentor session, so that we sit around the table, we chat with the kind of mentor you want to talk to. I think it's a good thing.
Okay. Thank you. There was a hand. Yeah, Lindsay. Oh, sorry. Please go ahead. You have the mic already. Go ahead.
All right. So I had an experience where it was in a similar training or academy where we had the opportunity to interact with most of the faculty, not at a special gathering, but mostly during breaks, during lunch and all those things. We get to sit with them on the same table and we can have an interaction. So maybe going forward, we can look at that option where we can mingle or we can interact with them over coffee, over all the breaks that we've been having. And I think that's a good way we can go about it. And one commendation is I look at this, it has been paper light. It has been paper light. Most of the things you can scan and download, and I think that is a good way to go.
Okay. Good. Yes. Last comments.
Good evening.
Yeah.
So I was just wondering if, because when we come for the conference, we expect to get feedback from the work we have. So sometimes when we go for the poster presentations, there are so many posters, and sometimes you don't have people pass by your poster. But at the end of the day, you don't achieve the objective of coming to the conference, which is getting feedback for what you've done. So how can we, what's the best approach, or how can we mitigate this so that it doesn't happen So at the end of the conference, you can say you actually got feedback from what you came from.
Okay, all right, thank you. So I think it's a recurring theme, the posters. More time for posters.
Yes, I think it was suggested to me that we could do, Google Doc with for the scoring the posters. That way you have the scores available and the comments and everything. Well, not the scores, the comments for your posters available to those who did the posters, because it's true that a lot of times you don't get any feedback. You just know that you have great feedback if you won or you were second or third. Hey, I don't know what to do. So are we just getting feedback from the conference? Yeah, we've already done the scoring, but we're waiting for the certificates to be printed. Has he done the positives and the negatives yet? That's what you're doing now. So are these the negatives or the positives? Both. Okay. So we can keep going. Yes.
With respect to the interaction, I think for the students and postdocs, you guys should approach us. Sometimes it's very difficult to regiment all of this. I can tell you, some of you might have observed, I did on purpose sit in every lunch in a different table on my own. And I instead of talking to my colleagues, which in many ways would have been, you will say, well, it's the main attraction for us because we can discuss all kinds of things. But I wanted to really see interactions. And I can tell you, I was enriched by the conversations. Today, I learned about Boko a lot. And I sampled it, and I think it was a very good experience. And we were exchanging ideas with one of the students on different things, science and non-science, literature and other things. So I think it's a matter of us also, the more senior colleagues, to spread out a little, and you guys don't be afraid. Sit down with us, because we can chat we can start with silly things, but then eventually go into whatever questions you have. And I think it's a great experience.
Is that my microphone?
Yeah. Okay. Yes, and I think one comment that we realized that this year has been quite packed with 2 different pre-meetings, so maybe we'll make it a 5-day thing where we have it built into the system so that they are not competing events for our planning, but it's all part of the conference, especially at least for next year, which is the 10-year anniversary.
So Peter has just asked for double of the budget for the conference. Every day means more money, yeah? So if you are going to do a whole week... Okay, all right. Thank you. All right, so I think we can start to wrap up now, because Mark Carrington just whispered to me that the beer is getting warm, and you don't want beer to get warm, right? The food is not here yet, so there's no fear that the food will get cold, but the beer will get warm. And warm beer is not good for your health. So... No, let me, I have other things to do before, so let's wait. Okay, so I want to start with the thanks. So first, I want to thank all of you. So let's give each other a round of applause. It's always a pleasure to have this gathering and to see people that we haven't seen for at least one year. And then, even those who are here, sometimes we don't get to see each other because everybody's so busy. So it's great that you all took the time, whether walking from your hostel to here or traveling from Australia to here.
You know, it's great that everybody took the time to be here for us to have fun for the last 3 days. For some people, 5 days. Others will continue next week. You know, so it's really great. And WACCBIP, as always, we're very grateful for the support and your continued belief in what we're doing and you know, being part of this. So thank you all very much. And I always say that once you've come here, if it's your first time, you are now like an ambassador for us. You've come to see what we do here, what we're trying to achieve, the young people here, the passion that they have. You are ambassadors for us wherever you go. Talk about what we're doing. Ask people to support us and give opportunities to our young people to develop themselves and to build their talents. So please keep WACCBIP on your lips wherever you go. And we would also do the same for you. All right. Then I want to particularly thank those who spoke, right? We've all talked about, you know, all the stresses and pressures of even speaking up in conferences. So people had to prepare presentations and prepare posters and all that. So again, we're extremely grateful for all your efforts. We appreciate all the work you've done to come and share your research with us, and we are most grateful. We want to recognize our keynote speakers in particular. It's, you know, all these people are extremely busy people, very successful people who have, you know, many things they could have been doing with their time, you know, who, you know, could earn a lot of money per hour doing something else. And here they are doing this for free, probably losing some money in the process, because when you travel, sometimes you end up spending more money than you wanted. So we are very grateful for our keynote speakers for taking the time to share with us such excellent and incisive presentations, very inspiring talks all around. So we thank Kelly, who's not here, Ngozi, who's here, and my friend Tumbi, who made the trip all the way from Australia. So to show our appreciation, we have a little token for those who are here. So ladies first, I will call Ngozi first to come for a token on behalf of WACCBIP. And my brother Tumbi, please. Tumbi also has a dress, just a shorter one. Yes, thank you, my brother. Yeah, it's a shorter dress.
Thank you so much.
All right. So next year, I hope people will be lining up to be keynote speakers. Last, your application would be accepted. All right. So thank you very much to our keynote speakers once again. Then we want to recognize our local, hardworking team. So we start with the logistics, yeah? Those who make sure that everything works so you don't have to think, all right? Those are the logistics team, starting from, picking up from your hotel to making sure you have your breakfast and everything. So for this conference, we had a logistics team. It was led by Professor Lydia Mosi. So please. And then the scientific committee who did the call for abstracts and reviewed the abstracts, and if they rejected your abstract, I'm now about to tell you who did. They gave you poster instead of oral. You can sort them out now. And that team was led by Dr. Peter Kwashi. So. So we appreciate the efforts. Then we want to acknowledge the entire WACCBIP machine, as I always say. In between those two people, there's a whole lot of other people who do all kinds of things that I can't even remember all the things that they do, because it's a lot of things that everybody does, small little things, sweeping this place, mopping the floor every morning, cleaning the washrooms, drivers picking people. I mean, it's a whole operation. So we call that the WACCBIP machine, because I don't know how to describe whatever they do. So it's like a machine. When we switch it on, everybody knows their job that they have to do, and then the whole system works well. And it took us years to build a machine, but the machine works, and it's strong. So I want to give credit to the WACCBIP machine. We have awards for some of our staff. Usually every year we recognize staff who have put in an extra effort beyond the call of duty, and we recognize them. In spite of the fact that everybody has done so well, we try to recognize people every year and appreciate the efforts that they've made and the sacrifices that they've made. So this year, we want to recognize two people. First is Sika. Where's Sika? Where's Sika? Please go and call Sika to come. She's busy working and setting the food. Is that my book? Okay, good. Do you have the certificates? You have all the staff certificates too. Where's the staff one? Ask Felix. Okay, you have interns and what? Oh, okay. Maybe we'll give it during the dinner. Okay. Is it in order? Have you signed them? You guys. Where's the has to be hard. They have to print a hard copy. Okay. So, no. This best. Let's run out. Okay, and this is which category? So, is it PhD and master? Okay, and then the poster you have? Okay. Or PhD? Please arrange them for me. Always arrange from second run up to the winner. The winner will come last. So arrange them for me. Okay, start with the poster. All right, so we'll do the poster awards first. Whilst we wait for Sika to come for her award, we'll do the poster awards. So, should we start with masters category? Have the masters. It's masters. First runner.
First runner. You're supposed to print that because we had a tie here, and then I found out that this is a biomedical engineering, so she's not our student. So now he has to print it. So that's the winner.
So one is missing.
Yes.
Oh, they were not ready. Maybe we should just do this during the dinner because it's.
We should just do everything during the day.
Yeah, because it's. Okay, so I think we'll just do it during the dinner because it seems like one or two are still missing and all that. So we don't want to hold you up from your beer. So we'll go and have.
Dominic wants to make a presentation.
To what?
Said to keep going.
For what?
For the thing that they did.
What thing?
The training. Okay.
Okay, so please, thank you very much. Let's go. Let's start having drinks. Let them sort out all the order of the posters and oral presentations. Then we do it outside. Okay. So thank you.
Hello? So if anyone wants a ride back to the hotel, we're going to try to organize one shortly. No, some people want to go rest. Rest.